Yo, what's up guys? Welcome to your 100-part series in Java. Now, I just wanted to do a real quick in-person video so you can see the face behind the beautiful voice that you're going to be hearing in the upcoming tutorials. Now, if you want to get the most from this series, I encourage you, one, to subscribe, right? Duh. But also just to go through the exercises yourself. Don't just watch the series straight. You're not going to learn nothing. You need to be coding these exercises. On top of that, don't proceed to another video until you at least have a good general understanding of the previous video. That's because everything builds on top of each other. So if you think, oh, that's not going to be important, or I don't need to worry about that, it's probably going to bite you in the butt and you're going to regret it down the road. So I'm super excited for this series, and I couldn't do it without the support from you guys, so thank you so much. Welcome to my channel, everybody. My name is Caleb, and this video series is going to give you everything you need to know to be a Java developer. So we're going to start you out from a complete newbie, and by the end of this series, you should be writing Java applications like a pro. And here is this beautiful speed drawing that you guys can stare at for a couple minutes while I talk. One thing that makes this series unique from all the other Java series on the internet is I don't have the goal of boring you to death. I'm going to try and make everything entertaining and fun. Now, I'm just going to tell you up front though that it does take work to learn any programming language, and you're not going to get there without practice. Java is one of the most popular programming languages, and it's often taught in schools. One of the huge benefits of Java is that it allows you to build an app that can run on Windows, Mac, and Linux. So it allows us to make an app that can be used by as many people as possible with as little work as possible. And we're going to talk about how all of that works in this series. But what you need to know now is that Java is a very powerful programming language that can enable you to make some pretty sweet apps. Some of the things we're going to talk about in this series is just the Java fundamentals, so how to actually use the language, but also some of the technical details and the how and the why behind what we're doing. So I don't want you to get from the series what to type, I want you to understand why we're doing that and give you that foundation to be able to write your own applications. Now, I think one of the problems with people who study programming and just don't get it is they dive in a little bit too soon and they don't really understand what they're trying to do. So first we're just going to talk a little bit about the architecture of Java. So we write code, which is basically a series of commands to tell the computer what to do. And Java has made the process of us talking to the computer super easy. And why is that exactly? Well, the reason is because Java is a higher level language. And what that means is it's actually a couple steps away from talking to the computer directly. So we basically talk to Java and something that makes sense to us, and then that's converted to something the computer can understand. So if you wanted to see this visually, it would look like this. Boom. Now there's a lot of stuff here, but we're going to go through it from beginning to end. So when we write Java code, that is known as source code. And these files are going to be named something with a .java at the end. So the asterisk just means any file. So something.java. And what happens is we compile this code into what's known as bytecode. We don't actually look at this bytecode, but it's a very important step in this process. The bytecode is going to be .class. Then what happens is each one of these operating systems can understand this bytecode. We don't have to worry about writing something for Windows and then rewriting it for Mac and then rewriting it for Linux. We just write one thing in Java and the rest is done for us. Right now, this seems a little bit magical, but there's a few things that make this possible. The first is what's known as the JDK, the Java Development Kit. And as you would guess, this is how we develop in Java. So the JDK is up here. It gives us all the tools that we need to program in Java. The part down here that allows our code to run on all these different operating systems, this is known as the JRE, the Java Runtime Environment. So there's the JDK and then the JRE. You can remember which is which because the JDK is Java Development Kit and the JRE is Java Runtime Environment. And when I say runtime, just think of running the actual code. So each one of these operating systems runs our application. If this just seems like a bunch of jargon right now, trust me, by the end of the series, this will be like second nature. But just to overview, we write Java code, and we do that with the help of the JDK, and then we compile our Java files to .class files, which contains bytecode. And then this bytecode is ran by these different operating systems using the JRE. So one thing that's always kind of annoyed me with Java is that if you have Java installed on your computer to run certain applications, it asks you to update like every 2 days. And that drives me crazy. I don't know if you guys have experienced that. But that thing that's asking you to update is the JRE. It's what allows people to run Java applications on their computer. To put this into context a little bit more, if you go on the internet and search Java, what's going to happen is you're going to come up with this java.com, and this is the JRE. So this is what people are going to install to run your application. The other thing is the JDK. So if we search JDK, well, now we have something else, the Java SE. The SE just means Standard Edition. It's the free version that everyone can download and use. This is what we are going to download to start programming in Java. When you download the JDK, that's going to include everything we need to run Java as well. So we're going to be able to develop and run our Java. So this includes the Java runtime environment. You don't have to worry about downloading both. So what we're going to do is go to this website here and download Java SE. And the version might be newer, so that should be okay. But this is the version I'm going to be using for this course. Now you're going to need to download the version for your operating system. I'm going to be developing on a Mac, so that is the one I am going to download, this bin.dmg. Oh gosh, you have to accept. There we go. I'm going to let that download, and that's all I really have to say to introduce Java for you guys. In the next video, we are going to create our first Java program and just talk about all the pieces to getting started. Before you guys go, I want you to check the description because there's going to be some other resources for you guys. Specifically, each one of these videos is going to be tied to a blog, which has the code there for you guys to copy and paste or read through if you prefer that. And also there's going to be a link to a Java crash course. This is something you guys would be interested in if you want a nutshell version of this series. So if you want to review everything we talked about in this series, or if you just want some more hands-on examples and want a syntax reference guide for all of the content, check that out, guys. That could really be good if you want to prepare for a job or just study for an exam. Definitely recommend it. Last thing, there will be a link to the sponsor who has been tremendously generous in helping me make this series. So please go to their site, sign up, and give it a try. That's what I did. Honestly, it was one of the best decisions I made. I ended up using Pramp for personal use to study for a technical interview that ended up going really well, so I'd highly recommend them. With that, if you guys have any questions, comments, or concerns, please leave them in the comment section below. Please subscribe, and I'll see you in the next video. Welcome back, everybody, to your second Java tutorial. This video is where we're actually going to write our first Java program and just break down the structure. So there's a couple things you're going to need. The first thing is the Java Development Kit. So I already downloaded that. Installation is pretty simple. I'm not going to go through all of that. Just go through the steps. The next thing you're going to need is an IDE, which stands for Integrated Development Environment. Doesn't really matter if you know what it stands for, but basically it's a fancy text editor. There's two really common ones with Java. One is Eclipse and the other is NetBeans. So which one you choose is totally up to you. I'm going to go with Eclipse because that's what I have experience with. If you have NetBeans and that's what you use, you should be okay to follow this series just the same. But if you don't have anything, I'd go with Eclipse. Okay, download. I'm on Mac, so I'm going to go down here and click this Download Packages button, and then you can see that the different options are over here on the right. The one I'm going to go with is this Eclipse IDE for Java developers, and I'm going to get the Mac version. And I'm just going to drag Eclipse into the applications. And there we go. We should have everything we need to start programming in Java. So in your applications, you can just look up Eclipse. And there you go. When you open Eclipse, it's going to ask you about a workspace. And you can see it just stores your preferences and a bunch of other junk. So I'm just going to say that this is fine and that we can use this for all future occurrences. All right. When Eclipse opens, you're going to want to click Create a New Java Project. In here, you can name anything you want. I'm going to call it Hello. And then I'm just going to click Finish. And then I'm just going to click Don't Create. All right, so you have your project open. Some of the different things you should know about in Eclipse, this thing over here, the Package Explorer, this is where all your projects are going to be, and you can open them and look at all the files. This is going to be used quite often. Oh, that's overwhelming. Good thing we don't really have to worry about any of that. Down here on the bottom is where your compilation errors and your warnings are going to go. So when you try to run something, they'll show up right here. And then there's some other junk over here, which I don't really care about, so I'm just going to click these little minus signs and get rid of those. We can start working with our project by right-clicking it and clicking New Class. And then make sure you check this box, Public Static Void Main, String Args. So check that, and what that does is basically say, hey, this is where I want my application to start. Then we can give it a name. I'm just going to call it My Sweet Program. And then click Finish. All right, and then double-click it. And here's our program. So the first thing I want to do is I want to run the project so we can actually say, hey, we created our first application. And then what I want to do is I want to break down some of this garbage in here. So get rid of this line and replace it with system.out.println, and then put these parentheses, and inside of these parentheses just say hello there. Okay, so you have to copy this exactly, including the capitalization. So system starts with a capital letter, and then a lowercase o, and a lowercase p, and a lowercase l. So everything else is lowercase. And we're going to talk about all the capitalization and junk in this series, so don't worry about it. Once you got that written, you can save it by holding Command S, or if you're on Windows, Control S, and then going up here and clicking this play button. And you can see it prints hello world inside of our console window. The console window is where we're going to be interacting with our program a lot. This is where we're going to give input, this is where we're going to see our output, and this is basically our application. As you get better at Java, you can then move on to user interfaces, or you can move on to web applications, which would serve like JavaScript and HTML and CSS. And even you can do mobile applications, you can do Android applications, and there are even some things out there to help you make iPhone apps with Java. So the sky is the limit, but for the basics, it's always best just to start in the console. That is all I'm going to talk about in this video. In the next video, we're going to talk about every single piece of this code here, so you have a good understanding of that foundation. I feel like a lot of people just jump in, start writing stuff, and you really don't understand what any of this means. So hopefully by the end of that video, you're going to understand what every single one of these keywords means. It might take some time to really, understand it deeply, but at least getting that basic understanding. That's all I got for you guys. Please be sure to check out the description for a link to the crash course, as well as the blog and the sponsor Pramp, who is super awesome. So check all those out, guys. Thank you, and I'll see you in the next one. Welcome back, everybody. This is your third video over Java programming. My name is Caleb, and thank you guys for watching. This video, my goal is to help you understand all of this stuff. And this is honestly probably where most people quit. So congratulations on being better than like 95% of the people that watch these videos. All right, now to covering all of this crap. So if you're new to Java development, you can kind of ignore everything above this line and everything below this line and just kind of put your code here in the middle. And a lot of beginners do that, but you guys know that my principle here is that I want to help you guys understand why we're doing things and how it's working rather than just what to type. So I'm not going to ignore this stuff. So before you start learning what all these terms mean, I just recommend you go in here and start changing things and see how it affects your program. Now my goal is to help you guys understand everything here. But one thing I wanted to tell you guys is that at some point you're going to X out of something important and you're going to be annoyed because you're not going to know how to get it back. That happens to me all the time. So if that's the case, what you need to do is you need to go up here to the top and go to Window, Perspective, Reset Perspective. And that's just going to get everything from the fresh start that we had at the very beginning. So now we can go and open our code again. So now that you know how to protect yourself in the case of failure, let's get started. The first thing that you need to know is that everything is inside of a class, and each class has a name. We named it MySuiteProgram. Inside of classes, we have what are known as methods. So this is an example of a method. Just like a class has a name, MySuiteProgram, well, all of your methods are going to have a name as well. And in this case, our method is called main. The technical name for this right here is an identifier. So our class has an identifier and our method has an identifier. Inside of our method, we execute statements. So this is an example of a statement. And throughout this series, you're going to learn all kinds of different statements. So it's kind of like this nesting doll. The biggest thing here is the class, and then inside of the class, we can have a method, and then inside of the method, we can have statements. Another thing you should know is that this method is an example of a member. So every single thing that's part of this class, MySuiteProgram, is known as a member. So you can say that the contents are the members of this class. We could go in here and add more members. So for example, and if you don't understand all the syntax, that's cool, don't worry. Here we are creating a new member. So now we have two members. We have a method, which is called main, and then we have a string, which is called x. And this string is an example of a property, by the way. So we have methods, and then we have properties. Methods usually do something, so in this case it's printing to the console. Properties just store some value. For example, I could store the value hello. And just to run this, make sure I don't got any issues. Yeah, it's still working. So you can see this nesting concept in our code. So for example, for this statement right here, we have this system class, and then inside of the system class, we can access its members using this dot. And one of those members is called out. And out has a member print line, which is a method. So you can see how you just have to understand that the structure consists of classes which contain members, and those members can be properties or methods. All right, so now I'm just gonna get rid of this and kind of go back to how we had it at the beginning. Okay, so what about this public stuff? Well, these are known as access modifiers, and there's some different options. So for example, we could put private, which that's actually not gonna work. So we get an error when we make it private because every single executable Java program needs to have a public method called main. But just so you know, for future development, we can change this access modifier to different things. And basically this determines who can access this method or who can access this class in this case, because this class is public. So when we have a really complex Java application, we're going to have multiple classes, and these classes will interact with one another, and you can control that access by using these different access modifiers such as public or private and so forth. Another thing you guys should understand is the use of these curly braces. When are we supposed to use curly braces? And Eclipse is kind of cool because if you click one of these curly braces, it's going to make a box around the matching closing curly brace. So you can kind of think of it, if I just got rid of all of this, here is our class structure, and then everything inside of these curly braces is part of this class. Then we do a similar thing inside of here with the method, and everything inside of this curly brace and this curly brace is part of that method. And just by convention, we indent everything that's inside of curly braces. And when I say convention, I just mean that it's very, very common. Everyone does it, but it's not necessarily required. Because I could go in here and I could not indent all of this stuff here, and I can save it and I can run it and it still works. But the issue is that it's not clear what's going on here, because developers just know that, hey, this is in a class, this should be indented. So if it's not, you're going to introduce confusion. And the only other thing I wanted to talk about in this video is this static keyword. And this is one of those things that's a little bit more hard to explain without a lot of the back knowledge of object-oriented programming. We're going to dive into object-oriented programming deep in this series, but just so you guys know, Java is an example of an object-oriented programming language. In an object-oriented programming language, we basically will create instances of classes. So you can consider a class like this blueprint. It's like a factory that makes these objects. And this probably is like making absolutely no sense if you've never really gotten into object-oriented programming before. But all this static keyword is saying is that, hey, we don't actually have to create any instances to use this method here. So if we created a different method, let me just copy paste this, and we'll just call this something really creative. And I'm just going to get rid of this here. We'll talk about that soon too. And I'm going to get rid of this static keyword. And we're just going to make this say, hello there, tacos. If we wanted to run this tacos method or call it, we would have to do it like, so by doing this, we're creating an instance of that class, and then we could say x.tacos like that. And now when we run this application, it says, hello there, tacos. So this whole concept of this new and then putting your class name, well, this is creating an object. But this main method has this static keyword. And what that means is that this step does not have to happen. And that's similar to this print line method, because we're not creating an instance of this. We're not saying new system and then giving it a variable name and then calling print line on it. We're just calling it directly, and that's made possible because of this static keyword. So I'm going to get rid of this. Actually, I'm just going to get rid of all this. All right, and also if you guys didn't realize this, you can put 2 forward slashes to make a comment. This is going to be ignored and it's not going to execute anything. So I'm going to use comments to sum up this video and say all of the key terms you guys need to know. So the first thing is a class. A class contains everything and has members. The examples of members are methods, which do something, and then properties, which store something. These things can be given an access modifier. In this case, they're public, So that's this right here. This defines what code can use this. And then lastly, we had static, which means no instance of the class is needed, which brings up the term object, which is just an instance of a class. And these last few here can be a little bit confusing without first learning some basic Java. So we're gonna get into these a lot more in the upcoming videos. So before I go, I just wanted to say that we have created this main function. So this means that we created this section of code that someone can call and say, hey, we want to run everything inside of main. And then it's going to go through and execute all of the statements. And a statement is just telling the computer to do something. So we've defined this main function, but how exactly does it get called? Well, the way it works is that the main function always gets executed automatically when we execute our program. That means if we change the name of this thing to something totally different and then tried to run our program, it's not going to know where to start. It says right here, please define the main method. So that means every single program at some point is going to need a main method. And there is an exception to that, which is if you're just creating some code that can be used by other programs, so like a library, well then you don't need a point to start executing. You can just basically make all these resources for people to use. Okay, so in the next video, what we're gonna do is we're gonna talk about what this is right here. And these are known as arguments. And in the next video, we're gonna talk about how we can use these arguments to make our program a bit more dynamic. So hopefully by the end of that video and maybe a few more videos in, you have a really solid understanding of all the foundational Java content. So let me know what you guys think. Was this video too much? Did you like getting everything up front, or do you think it'd been better to space this content out over some more videos? Like I said, we're gonna go back and we're going to touch on each one of these topics in a lot of detail. So don't feel like you have to have everything memorized or understand every piece of it. Just get the basics and understand that this is the foundation of a Java program. If you've enjoyed the series so far, I just ask that you would consider subscribing, as well as checking out the description for a link to the crash course, the blog, and our sponsor Pramp for some interview practice. Thanks, and I'll see you guys in the next one. Yo, what's up everyone? In this video, we're gonna be talking about this right here, as well as this here. So basically, in the previous video, we talked about the foundation, you know, like what in the crap is going on with all this code here. But now we're gonna be talking about arguments, and this is an example of an argument. So anytime we call a method, which is, if you guys remember, a method does something, and we have these parentheses, when we put something inside of these parentheses, this is an example of an argument. So hello there is an argument. And this main function that we're defining here, this main method, is expecting an argument that is of type string array. And we're going to talk about how we can use this. So what we're going to do is we are going to, in the Package Explorer, right-click our file, and we're going to click Show In, and then say System Explorer. All right, so this is going to open that Java file in a window. And then what we're going to do is we're going to basically back up a couple of files. So if you don't see this icon right here, what I want you to do is customize toolbar by right-clicking and then find the path and just drag that down, drag it up here to right here. Okay, cool. Once you got that, I want you to back up to the project folder. So the Hello project is right here in the Package Explorer, and it's right here in our file system. So there's two folders here that you'll see, the source folder and the bin folder. The source folder contains our source code. The bin folder contains our object code, our compiled code. So what we're gonna do, we're going to open a terminal. And here's what we're gonna do. We're going to basically, in the terminal, change to that directory by using the cd command. And then I want you to basically drag that bin folder to the directory, and it'll type out the location of that. And then press enter. So now when we say ls, we should be in the same folder as my sweet program.class. All right, now what we can do is we can run this application from the terminal by saying Java and then just saying my sweet program. But you don't put the .class, you just leave it my sweet program. And then press enter. And you can see the code executes. So that is how you run a Java program from the terminal. So that's pretty cool. But now, what we can actually do is we can make our application a little bit more dynamic by passing some extra info in there. For example, what if we wanted our application to say, "Hello, Caleb"? Well, we could actually come in here and add another argument and say, "Hey, my name is Caleb." Whoops, can't even spell my own name right. But you can see when we do that, nothing happens. It just says hello there. So what in the world is going on? Well, the reason nothing's happening is because we're passing in an argument into our program, but the program's not actually doing anything with it. So if we wanted to actually say, "Hello, Caleb," what we need to do is we could actually go in here and say, "Hello," and then put a plus sign, and then say, "args of 0." Just like that. Now when we run this in the terminal, you can see it says, "Hello, Caleb." So that's pretty cool. We basically just created our first dynamic program. And this basically is the foundation of all programs. Our goal is to not make applications that do the same thing every stinking time. What we want to do is we want to make an application that's interactive. You know, it says our name and it allows us to type in things and do different things depending on what we want. We want to make our application dynamic. So what we just did here of passing an argument with our program name, it's actually not super common. And in the upcoming videos, we're going to be talking about how to do different things like asking the user their name. And then we don't have to worry about passing in the username right here. We can just call the program and it's going to work just as expected. Because right now, if we don't put that in there, we're going to get an error. Oh, exception in thread main. By the way, guys, this is an example of a runtime error. So we were able to run the program, but what happens is that the program crashes. So we didn't get a compiling error like we did over here in this example. For example, if we go in here and we type something wrong and we try to run this thing, well, actually, I'll go back to the terminal here. If we try to run this here, well, now we get a compiling error. Those are two different things. Compiling errors are good because they allow us to fix our code before it runs. Runtime errors are bad because they crash our program and we don't always catch them before it's too late. So I'm going to go back in here and fix this. And I'm going to save. I'm going to go back in here and run our program like normal. So you understand how to use a command line argument. But just so you guys really understand what's going on here, when we say Java my sweet program, we are basically saying, "Yo dog, we want to run the main method of this class, my sweet program." So it goes in here, looks for that method. Oh, here it is, main. And here's what we're going to be doing in that method. And then this thing right here, string brackets args, this is what it's expecting as arguments. And it doesn't have to take any, but we can pass arguments. So we could pass multiple arguments. We could say Caleb and, I don't know, Sally. And we're not using that second one here, so it doesn't really matter. But in this situation, we're using that first argument, and the way we get the first argument is with this bracket 0. And this is array syntax, and don't get overwhelmed with that if you've never used arrays, because we're going to be talking about that. The main thing you guys need to understand from this video is what an argument is and how to use command line arguments. Arguments are going to be used all throughout coding, so it's really important to understand. Anytime we call a method, such as this print line method, well, we're passing in an argument. We're passing this entire expression here. So we get hello plus whatever the first array element in this args is. So that's another example of using arguments in our code. So another thing you might want to add in here is arguments. And this is what you pass to a method. Now another term you're going to hear a lot, and I gotta get rid of this error, it's driving me crazy. I'm just gonna run this. So you can see we get an error here, and that's because we didn't pass in a command line argument, because when we hit this play button, we're not passing any arguments in. So I'm just gonna go back and just delete this. All right, so now it should run. Okay, now what I was saying, another term you're going to hear a lot is parameter. And what is a parameter? A parameter and an argument are very similar, but they're not the same thing. You'll often hear them used interchangeably, but I would say if you want to be a really good developer, you'll definitely want to understand the difference. So an argument, as we learned, is what you pass in to a method. So we're passing in hello to the print line method. A parameter, on the other hand, when we define a method, is the variable that's going to store that data. So for example, this main method, we're saying, hey, we want to store the arguments in this right here, a string array called args. So this thing here is expecting an argument, but what this thing is known as is a parameter. And the distinction between those two will become clearer once we start defining methods. But basically, we're defining this main method here because we're doing all this prefix stuff, but we're just calling this print line here. We're not defining it. It's already defined somewhere. So when we define a method, we give it parameters. When we call a method, we give it arguments. So these are variables to store arguments. They're part of the definition of a method, and the arguments are part of the calling. And when we say calling, all we mean is we're saying the name and putting these parentheses, which is going to execute the code inside of this method using the argument hello. Now, oftentimes you're going to be using other methods that have been created, and you're going to need to know what kind of arguments they need. So when you call a method, so let's say we wanted to print something else, and we say print line, you can see there's all of these different signatures here. The signature is basically just the structure of the method, and you can see there's a lot of different options. So we don't just have one print line, we basically have an overloaded version with a bunch of different options for arguments. One of them takes nothing, one of them takes a Boolean, one of them takes a character array, a double, and so forth. The one we've been using is print line string, and that's because hello is an example of a string. And we're going to get into all these data types coming up soon, but just so you know, if you're not sure what kind of arguments the method takes, all you gotta do is just type it back out and it'll just give you some hints. So you put the dot and then the function name, and then you can go through here and get details about all the different versions. So that's pretty much everything you need to know about arguments and parameters for right now. I would even go so far to say that if you understand everything we've talked about up until this point, you are far beyond what most people understand in development. What we're going to do now is we're basically going to take a step back from all this deep diving of the concepts, and we're just going to go back and learn the language fundamentals. So all of the things we've previewed and talked about, we're going to go in all of those in more depth, so you can start understanding how to build more complex applications. If anything from the last 4 videos has been challenging, trust me, as you go on in these next videos, it'll all start to clear up. So don't worry about having a perfect understanding of everything. With that, I'll see you guys in the next video, and before you go, just please be sure to check out the description for a link to the blog, the Java Crash Course, as well as a link to our amazing sponsor, Pramp, who will drastically change your life. Thank you guys, I'll see you in the next one. Hello everyone, welcome back. This video we're going to be talking about the basics of a Java program, and we're not talking about like the conceptual garbage we've been talking about for the last 4 videos. We're going to start doing some hands-on work, getting some user input, creating variables, etc. It's going to be a lot of fun. So here is how we get output. So you can write stuff to the console here. We've seen that in the other videos, no big deal. But one thing that's going to become very useful for us is getting user input. And unfortunately, Java's way of doing this is just a little bit more complicated than some other programming languages, but it's not tremendously over-the-top complicated. Just for now, follow my code and you'll understand it soon. All right, so what we're going to do is we're going to say scanner. And then we're going to basically create a scanner and give it a name. So we could call it scanner with a lowercase s. And this shows something important, that Java is case sensitive. So scanner with an uppercase S and scanner with a lowercase s are 2 separate things. Then we use this equal sign, which is known as the assignment operator. We'll talk about that in a little bit. And then we say new scanner with a capital S and put some parentheses. Inside of these parentheses, we're going to say system.in. And you can see we have an error with scanner having this red line under it. And if you hover over, you'll get these suggestions. So it's saying, yo dude, your scanner doesn't exist. You're going to need to import that in order for it to work. And there's all these different options. And the one we're going to want is this java.util. So click that. And you can see if we scroll up, we got this new import statement. This import statement has to do with packages. Java code is this is a terrible word to use, but it's packaged inside of these things called packages. So even our class over here, My Sweet Program, inside of our package explorer is inside of this default package. We could go and create our custom packages. It's basically just another way to organize your code. So just how we have a class with a bunch of stuff in it, well, now we can have a package with a bunch of classes in it. And you're probably wondering, like, dude, why does this have to be so stinking complicated? Well, the reason we have these packages is because, like we saw, if I undo this, we hover over scanner here, you can see that there's numerous different versions of scanner. So if we didn't have these packages, we would have naming conflicts, because if we wanted to use this scanner here and this scanner here and this scanner here, we wouldn't be able to mix all of those together if they were all in the same container. We have to have a way to organize them and say, hey, this scanner is from java.util and this scanner is from com blah 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 blah. So it's just a way to organize our code one step more. For now, we're not going to be worrying about creating packages. We're just going to be using the packages that are given to us. And the way we can use them is just using these import statements and saying what package we want to use. So we want to use java.util.scanner. Now, when we do this import, all that it is doing is making our life easier, because now it knows what scanner we're talking about. If I were to comment this line out, just keep it there for a second, we would have to say java.util.scanner. And then it would work. But over here, we'd also have to say java.util.scanner. So now there's no errors, but it's just a lot more verbose. So what this import statement is it just makes our life easier, because we no longer have to fully qualify the entire name. So the word fully qualify literally just means putting the dots before it and saying exactly where the class is coming from. Scanner is coming from java.util. So obviously typing all these extra words is going to kill us, so we don't want to do that. So we want to get rid of all those prefixes. We don't want to fully qualify our name. My puppy's here to say hello.
You want to say hi, Kavi?
You want food? Now we just got to uncomment that and we should be good to go. Okay, so that was basically a really super long explanation of how to create a scanner. Now let's talk a little bit about this syntax here. So we've talked about this a little bit, but basically what we're doing is we're creating this variable scanner. And this is the name of the variable, the identifier. Every variable in Java needs a type. So the format's going to be like this. It's going to be type, identifier, assignment operator, new, type, semicolon. So this is the structure to create a new object. So correlating that to the scanner, the type is scanner, the name is scanner with a lowercase s, then we use the keyword new, and then we say the type again, which is the same as scanner. And then we have these parentheses, which we'll call the constructor of this class. And we'll get into all that later, but for now, all we have to know is that when we put new and then the name and then parentheses, we're calling a constructor to basically give us a new instance of this class scanner. So we're creating our own scanner. So just like we're creating a class here, My Sweet Program, at some point someone created this scanner class. And now all we want to do is we want to say, yo, I like this scanner class. Can I basically use it as a blueprint to create a new scanner? And we're going to name that scanner lowercase scanner. And then we're passing an argument in here, system.in, which is basically just a way to say where we're getting our input from, which is going to come from the console. So that's how you do that. Now that we got all that stuff underneath our belt, let's actually try to get some input. So the way we're gonna do that is we are going to basically make a string. So we're gonna say string, give it an identifier. For example, we could call it name, and then we can assign it a value from the scanner by saying scanner dot next line, just like that. Gosh, there we go. Like I said, it's a little bit complicated, but this is how we get some input. So what we're gonna do is we're gonna print out and say, what is your name? And then what we're gonna do is we're going to greet this person by doing a system out. And here's a little shortcut. If you type sys out, hold Control and press space, boom, there you go. That's how you do it on a Mac. I don't know how to do it on anything else, sorry. We're just gonna say, hello, put a plus sign, and then name. So the whole structure, we're going to ask for the name, we're going to create a new scanner object and use that to get a new line, and then we're going to output it like so. So let's run it. Yes, save. What is your name? Dog, my name is Caleb. Hello, Caleb. Sweet. So now we've created a dynamic program, but we no longer have to pass in command line arguments. We can just execute it. So that means if we're in the terminal, we don't have to say my sweet program Caleb. We can just say my sweet program and it'll ask for my name and it works. Here is the syntax for output and here is the syntax for input. Now you're welcome to go to the next video, of course, after you check out all the links and content in the description, but I did want to just go on a little rabbit trail if you're just looking for some extra information. If you remember from earlier videos, we talked about the concept of something being static, and basically that means, hey, you don't have to make an instance of something. Well, here's something that's not static. This scanner.nextLine is not static. And the reason it's not is because we have to create a new scanner object. If it was static, it would look like scanner.nextLine with a capital S, because we'd be calling it directly on the scanner blueprint rather than on an instance of the blueprint. So that's just a little side note, and we're going to talk more about that once we get to object-oriented programming. But that's all I got for you guys on user input and output. Hopefully that was helpful for you guys. And of course, I will see you in the next video, because you are going to go to the next video, right? You're not going to quit. You're going to be like the rest of the world, are you? All right, I'll catch you there. Peace. Welcome back, everybody. In the previous videos, we created this app that would ask someone for their name, get their user input, and then print out their name. So that is where we are so far in our Java programming, but we really need to understand some more of the basic concepts in order for us to build more complex applications. Well, so far, we have all this code here, and I think as we eventually build more complex applications, we'll start modulating our code, making it more like small individual pieces versus just putting everything inside of this main method. It's not really the best practice. So the main method is more just like this place to start, but eventually you're going to break out into your own methods and just keep everything real organized. But as we're going through some of the concepts of Java, we're not going to necessarily break out into all these methods, just because I want to go through some really simple examples and just talk about the basic fundamental concepts of Java. So with that, we're going to be talking about variables. So we've created variables. So here you can see we created this scanner variable. It's of type scanner. And we then use this scanner variable later when we want to get a new line. So we get next line. So that's an example use of a variable, but there is a lot more stuff we can do with variables. The point of a variable is it allows us to store information in some name so then we can easily refer back to it later. Another example we went through earlier is that we can create a string variable like so. This is a string. In this example, we call this string constructor, which will return us a string, and we assign it to this variable named string. So anytime we want to reference it, we can just do, let's say we want to print line, we can just reference that string variable here. And when we execute this, all right, so it says this is a string. So it's printing this string variable right here. And we're referencing this by name. So rather than taking this here and putting that inside of this print line like this, which is okay, you can do that. That is just not as clear and simple as using variables once we start getting into more complex coding. So one thing I wanted to mention is that variables can be used in what's known as an expression. So an expression is basically just when you combine values. So for example, I could say string plus and then put a smiley face, for example. And I'm going to get rid of all this stuff here. And now you can see that this expression is evaluated. So we have the first variable string, which has this value, and then we're basically concatenating, which is the technical word of combining two strings. We're concatenating, it's a hard word to say, this smiley face to this original string. So this thing here, this is known as an expression. So just for some new vocabulary, we have a variable which stores some value, and then we have an expression which evaluates to a value. So far you understand how to create objects. We created this string object, and then you know how to use the variable name inside of an expression. So what about this plus sign? This is known as an operator. And what an operator does is it will work on operands to produce a value. So the operators make the expression possible. So if that makes absolutely no sense, basically the plus symbol is going to take one piece of data known as an operand and do something with it with another piece of data, an operand. So two operands being worked on together by this thing called an operator. So the other term is operand, and this is the thing, I don't know how to define this, or the things the operator works on. As we start making some sweet apps, we're going to find that, hey, building these strings this way is like a huge pain in the butt. Like, dude, I have to type string like 3 times and 4 times if we're using it in the string. It's just really complicated. So Java has created a more simple way to create strings. And the way this works is you just type string. You still need that data type, and then you give it a name. I don't know what to name it. Easier. And then all you have to do is just put the value of the string in quotes. Wow. So much easier. These ultimately work the same way. There's nothing different about them. It's just the way we define them is just a little bit different in the syntax because we're using a shorthand version here. So now I want to talk about what kind of things can we assign to a string. In this scenario, we're assigning what's known as a literal. So that's another word for you guys. In case you haven't figured out, if you're new to programming, there's a lot of vocabulary. And honestly, that's just one of the biggest barriers. If you just learn the vocabulary, you'll be good to go. All right, so let's go up here. We can have literals, which is just the value. So for example, here's a value, here's another value. That is in contrast to a variable, which we talked about. So this is a variable, it's not a literal. So anytime we just put the value just like that, that is known as a literal. It's literally just a value, literally. It's really simple. So you can assign a literal to a variable. That's what we're doing in this case. We're assigning this string literal to easier, but we can also use expressions to assign to variables. So for example, I can come in here and put a plus sign after our string literal, and I can put a smiley face. Gotta love them smiley faces. We can save that, and then what we can do is we can print out that string right there, easier. And now let's run this sucker. Boom, there we go. So what we just did is we combined a string literal with another string literal. And when we combine two literals, that is known as an expression. What do expressions do? They evaluate to a value. So the ultimate value was just one string. Wow, that was easy. Not only can you use multiple literals in an expression, but you can also use variables here. So for example, I could say string, just like that. Okay, so now we're combining this literal here with the string variable up here. So if everything goes right, it should say, wow, that was easy. This is a string. Let's check it out. Yep, and it works. Now for each one of the things we've talked about in this video, there is a lot of information on. So for example, this operator, well, we can go in a lot of depth on operators. There's all different types of operators. Expressions, we can talk about, how expressions are evaluated. We could talk about variables and the different types of variables. There's a whole lot more information that you can learn about this, but personally, I just think it's helpful if you learn the basics and kind of get the 1,000-foot view before learning all the super itty-gritty details. So what we're going to do now is we're going to go into the next video and we're going to be talking about, what do I want to talk about today? I think we're going to talk about something cool. So yeah, definitely go check it out. Also check out the links in the description. I'll have a link to a blog as well as the Java crash course and a link to the sponsor. So thanks guys. If you've enjoyed this content, please be sure to subscribe. It would definitely mean a lot to me. All right, peace out. Whoa, dude, this series is so awesome. I know that's what you guys are thinking, and let me tell you, you're right, because in this video, we're going to be talking about how to create even more awesome variables. So yeah, you've seen, hey, we can make a string, wow, that's fun, but now we're going to be talking about what are known as primitive types. It's basically a fancy word just to say more variables. All right, so far we've talked about creating string variables and how to create them using this string constructor, as well as this more sexy syntax right here. But you know, we're obviously going to need more than just strings, right? We can't build a whole application with just words. We need numbers, we need dates, we need more complex objects and all kinds of stuff. So this just requires me to go in a little bit more depth with Java data types. So what the crap is a data type? So a data type is basically, real helpful, the type of the data. How the computer interprets the data. All right, so for example, we could have the value 5 and then we could have the value 5. These are two different things, right? So this is a number and this is a string. Yeah, they're trying to represent the same thing, but the way the computer interprets it is different, right? So if you use this, the computer thinks, hey, this is a number. This can be added. This can be subtracted from. Well, if you use this, it's a string. So, hey, we can concatenate to this string and add content in this string, but we can't use it for math, right? So even though we're using the same number here, the data type itself is different. Java is known as a statically typed programming language. And what that means is we need to say what type our variables are up front. So we say, yo, Java, we're going to store a string value in this variable. So we basically need to say the type of all of our variables up front. And basically Java is just saying, yo, dude, in order for me to best work with your variables, I need to know what type they are. And with that, you need to define all of the types up front before we even compile. This is in contrast to different programming languages such as JavaScript, for example, which by the way is not related to Java in any way. In JavaScript, variables do not have types. They can store anything. That is not the case in Java. You can only store a string inside of this string variable. So that means if I go down here and say string equals 5, well, guess what? We're going to get an error. And it's going to say, bro, you need to change the type from string to int. So once you define the type of a variable, it's permanently that type. So yeah, that means we have statically typed, which means all data types up front before compiling. And in contrast, we have dynamically typed. And this means variables do not have types. And for statically typed, I should probably say variables are given data types up front. Okay, so I admit I kind of went off on a tangent. It's really not what I wanted to talk about in this video, but that is useful information. What I wanted to talk about is just the way we can break up different data types. So there's actually different categories of data types. And you know, guys, anytime you can categorize things, this is really good because it helps you memorize things, which is why I categorize languages into statically typed and dynamically typed. There are primitive types, and then there are objects. Anytime we call a constructor like this, or anytime we use a string with this fancy syntax here where we don't need that constructor, we are creating an object. So somewhere there's defined this string class that defines the way a string works. And what we're saying is, hey, we like this implementation. We want to make an instance of this blueprint that you're defining in this string class. And we're going to name it easier. So an object is just an instance of a class. And the class is the data type, by the way, just for clarity. So in this case, string is the data type. It's also the class name. For primitive types, there's a limited number of possibilities. When we're talking about objects, well, hey, there are tons of classes out there and anyone can create their own classes. So there's essentially unlimited object types. So here are the 8 primitive types. We have Boolean, Byte, Char or Car, short. For some reason I was thinking short, which doesn't even make sense. Int, long, float, and double. All these tell Java to treat the data in different ways, and we're going to get into these types and how to use them, but now I just want to look at data types from a conceptual view. So when we create a primitive type, the way we create it is different. So we do not do this new stuff here. We don't do that. So for example, if I wanted to make an integer, all I would say is int x, and then I use the assignment operator and give it a value. So this is how we create a primitive. Now, for every primitive type, there is a way to create an object similar to this type. And this is what's kind of confusing, but I'm just going to get over this right at the beginning. So we can create an object version of the integer using a capital I and spelling out integer, and giving it an identifier, and then assigning a value to it. So you could assign a value to it just like this as well. You're not always going to be able to do that, but for strings here you can, and for these primitives you can, because this is basically going to be, this value is going to be converted to an object. Okay, so this is an object. And by the way, that conversion to an object is called autoboxing. Okay, so what in the world is going on? Why do we have a primitive type and a class type? Well, sometimes you're going to need to use the primitive, and then other times you're going to need to use an object created from the integer class. 99% of the time we're going to use these primitive values, but just so you know, there is a class equivalent, and the way these work are fundamentally different, and that is something we're going to get into throughout this series, and that is how primitive values are different than object values. In general, we can use them in the same way, so I can come down here, I can print X, I can print Y, and it should work. Yep, they both print 5. Nothing out of the ordinary here. The difference between primitives and objects really shows up more when we're passing data around to other variables or as arguments to methods, and you'll see that when we get to it. So I'm just going to clean this up here. That covers everything I wanted to talk about in this video, so now you should have a pretty good understanding of the primitive types as well as how they're created in comparison to objects. So at this point, consider you're learning the Lego pieces of a Lego set, and eventually you're going to start being able to put these Lego pieces together to build, like, you know, some crazy spaceship or something. So stick with it. Don't quit. I know this stuff can be a little, what's the word? Boring. But trust me, it gets funner. Alright, I'll catch you guys in the next video, and please be sure if you've enjoyed this content to subscribe, as well as check out the links in the description. Alright, peace out. Yo, what's up everyone? This video we're going to be talking a little bit more about variables and how to work with them, specifically assignment, initialization, all that good stuff. Alright, let's get started. So we have been working with variables and we're understanding the basics for the most part, but now I just want to go a little bit more in depth on how we create variables and just the different options. So I'm just going to clear out all this junk. Okay, so we can create a variable like this in x equals 5. We just created a primitive type variable because it's of type int, and there's 8 primitives. We talked about those in the previous video. Well, this is actually a 2-step process, and we're just doing them both at once. So here's how we create a variable. Step 1 is we declare a variable, and then step 2 is initialize a variable. So when we do this, we're actually doing both at once, but we could break this out into 2 steps, and that's what we're going to do now. So if I go in here and I said int x and just put a semicolon, that would be one statement, and then we would say x equals 5. That would be a second statement. So yeah, that's all I got for you guys. No, I'm just kidding. We're gonna go in a little bit more depth. So why would you ever want to do this? Why would you declare a variable on one line and then initialize it on the other? Well, you might be in the situation where you're thinking and saying, oh, I really need this variable x, but I don't exactly know what the value is going to be right now. So what we're going to do is we're just going to declare it up here, and then later on when we get the value that we need, we can assign to it using an initialization. And what that'll do is if we create x in the right spot, well then x will be available throughout our program. And that'll make more sense once we start talking about variable scope, but it's really super important where you declare your variables, because where you declare your variables determines where you can access and see these variables. So later on when we talk about like if statements, if you define a variable int x inside of here, where are these curly braces right here? Well, now we're going to get an error because x is not defined outside of these curly braces. So you might be in a situation where, hey, you know you're going to need the variable x inside of all these different scopes, so we might declare that variable outside, and then inside we can assign to the variable. And that means we could go down here and we could still reference the variable x. So in here it's assigned the value 5, and then we reassign it a value 10. So that wouldn't be possible if we defined the variable inside of here. So if we did it like that, Well, now this is going to be an issue because x isn't defined out here once again. So all of the rules on where to define variables, that'll be cleared up once we talk about blocks and variable scope. But for now, just know that sometimes it's important to declare the variable as a separate statement than initializing the variable. And here's another thing. If you declare a variable on one line and then assign it a value, this is known as the initialization. But what we can actually do is we can actually reassign values to this variable. So like I showed in the previous example, we can say x equals 10. So when we do this, we're not creating a new x, it's always referring to the same variable x. And this simple thing is important because once we get into some more complex operators and stuff, there's things we can do with the variable x that will basically reassign values to x or change the values of x. Basically what I'm trying to say is that x can be changed. It's not constricted to just storing one value and never changing. That's because it's a variable. You see what I'm saying? Variable, because it changes. You know what I'm saying? Okay. The other thing you can do is a constant. Now, if you want to make a constant, you can prefix the declaration with the keyword final. So we can say final int, and then just by convention, you can name it just like any other variable, but by convention, when we create a constant, we use capital letters. So we could say final int y equals 5. And now if we go down here and say y equals 10, we should get an error. And it says y cannot be assigned, obviously, because it's a constant. So this can come in handy if you want to create a value that you know is never going to change, like pi, for example. So you could go in here and create a variable pi, and you can go in here and give it a value like 3.14159. And this will actually not be an integer because you can't have anything with a decimal point. So if you wanted to do that, you could change this to double or float. We'll get into those data types soon. And then we can just get rid of this line here. Now, sometimes you'll see variables like this created outside of this main method, like this. And you'll also see some differences. You might see public static final, for example. And basically, we're just creating a global variable, which, by the way, I'm not saying this is recommended. I'm just saying it's possible, and you'll often see this. We're just creating a global variable pi that has a value that can be used throughout the program. Static, once again, means we don't have to create an instance of this class. Then if you wanted to use this variable pi inside of here, you could just use it like that. But if you're actually inside of a different class later on, you could say my sweet program.py, and that'll give you the value 3.14159. And obviously this is giving an error right now because we're not doing anything with it, but just to show you that it works, you could assign it to another variable like so. So now the error goes away. And the reason inside of another class you could do this is because it's labeled public, which means any class can access this member pi. All right, so now I briefly mentioned whether or not this was a good practice. My rules that I generally try to follow for myself is that if I'm gonna have a global variable, I'll try to make that thing final, so that way it's not getting changed throughout different areas of my program. So I try to keep things final, meaning that the value can't be changed just for things like pi that aren't going to change. Or what I'll do is I'll actually make this private, and then I can make what's known as a getter and setter for this variable to basically restrict how this value can be changed. So to summarize, you can declare a variable and you can initialize a variable. Wow, I probably could have made this video like 30 seconds long. So if you've enjoyed this content, please consider subscribing, as well as checking out the links in the description for the Java crash course, the blogs, and the sponsor, of course. Thank you guys, I'll see you in the next one. Hey, what's going on, guys? Today we're going to be going in a little bit more depth on the primitive data types and how to use those and the different versions and so forth. And that's going to be really cool because then we're going to understand one side of the data type spectrum, then the other side objects we're going to be getting into throughout this. So the ones we've talked about so far are int. I'm pretty sure that's all. And I think we use double too. So you can declare these things really easily. The difference between an int and a double is that the doubles can use a decimal with the value after that. So you can have fractional values inside of a double. There are actually 6 other primitive types we haven't talked about, and they are right here. We got Boolean, Byte, Char, short, int, long, float, and double. All right, so let's declare each one of these. So a Boolean is true or false. And when you give them the values, you just use the value true or you use the value false, but you don't put it in quotes. That's a string. And like we talked about in previous videos, something in strings and something outside of strings are two separate things. So these are not the same values. This is a Boolean false, and this is a string that happens to say false. So make sure you don't put the quotes. Next, we have byte. So a byte in computer science is a sequence of 8 bits, and a bit can be either 1 or 0. So for example, we could have this. This is an example of a byte, and you don't really have to understand this in order to use this byte data type. It's basically just a really small data type that can store a very small range of numbers. You can also store characters in here. So for example, if you want to store a character such as the letter C, you use single quotes, and then you just put the value of C in there. And how exactly can you store numbers and characters inside of the same data type? Well, the reason that works is because this is all based on the ASCII table. So if you guys haven't seen the ASCII table, let me show you. Okay, so here's the ASCII table. And basically, there's a bunch of stuff that's super overwhelming. But the important thing to look at is this decimal number right here, this column right here, and the actual character right here. So for example, if we wanted a capital C, that would be right here, and it would have the decimal value 67. So the two values are kind of interchangeable, meaning the value C and the value 67 are going to be stored exactly the same way in binary, but whether or not it's a C or a 67 just depends on the interpretation of that binary. So the next one is char, and this works the same way. So we could say char C equals, what do we want to give it? Let's give it capital Z. And going back to the ASCII table for a second. So this gives us a pretty good range of characters. You know, we got all the numbers, we got all the capital letters, all the lowercase letters. And this is usually suitable for small English applications. But if you want to start supporting different languages and different types of characters, then you're going to need a bigger list than this. And that's where Unicode comes in. Here is the Unicode list of characters. And you can see it gives us much larger range of characters. So we can do all kinds of different things. So with that, the char data type allows us to store Unicode, which means we could store different language characters inside of this variable. Next one we have here is short. Short is similar to char in that they're both 16-bit, which is double that of byte, but short is used for numbers. So we could put in here 32767, for example. And then that's the highest number available. Or we could use the negative version. We can actually go negative, and then we get one extra value there. Don't worry too much about the ranges. Just know that short is for small numbers. Next up, we have int, which, you know, really steps up the game. This is a 32-bit number. So we can put some pretty darn big numbers in here. And note that you don't use commas or periods inside of these numbers. So you don't space them out like this. And if you're not from the US, you don't use dots either. So you wouldn't do something like this. It's not acceptable. You just leave it plain like that. And then lastly, we have long. And this is the same thing as an int. It's just twice the size, 64-bit, meaning you can store bigger numbers in here. So you can see all the ranges here on this table. But usually I don't worry about it. I know that if I use an int, it's going to cover most cases. And then if I know I'm going to be working with something huge, well then I might want to use a long. All right, so we've covered all the integer categories, and integers and characters are kind of swappable in the sense that the way they're stored in binary can be interpreted as a character or an integer, just depending on the context. But once we get into floating point, that's a little bit different, and that's what we're going to be talking about now. You'll also notice here that I'm getting an error, and the reason that is because when you create a literal value like this, a long, and you want to specify, hey, this is a long, you have to put a capital L right there. So when we hover over this, it says it's out of range for an integer because it thinks we're trying to create an integer. But if we put that L there, it should work. Now, if we're in the situation where we have a really small number, and it's not outside of the range of a normal integer, then we don't need to put that L there because it's just going to get converted to a long. So if you just want to be on the safe side, just keep an L on your values. It's clear because when I look at this, I know that, hey, we're trying to create a long value, not an integer, which are two separate things. And this can take some time getting used to if you're new to programming, because in real life, we just think of numbers as like one thing, but there's actually different categories created by these data types. So the next thing we're going to learn about is float, which similarly we need to end with an F, just like that. And then we have the double version, which works the same way, you just don't need to put anything right here. So the difference between a float and a double is that a double is 64-bit and a float is 32-bit. So what that means is the float can't represent numbers as precisely, meaning if you're really particular on the math and you want to get as precise as possible, you'll want to use a double. And I would argue that there's almost never a case to use float at all. Just use double in all circumstances unless there's a specific reason you need to use a float for something. Usually that'll be the case if you're like super restricted on memory, but you're usually not going to find that when you're programming in Java. Maybe if you're doing something in C, but for Java, double is going to work 99.9% of the time. Now when you put a decimal point followed by some numbers, but you leave off the F, it just assumes it's a double. So if I tried something like this, where I say 20.5, I'm going to get an error because it's assuming this is a double and it's not going to let us convert. The other way is okay. So if I did double dd equals 20.5f, we're not going to get an error. And there's something important you need to understand here, and that is the float is a smaller container than the double. Think of them as backpacks, right, that you can put stuff in. In this first scenario, we're getting an issue because we're trying to store a giant backpack's worth of stuff in a small backpack float. The other one is not giving us an error because we're trying to store a small backpack's worth of stuff inside of a larger backpack that can store twice as much stuff. So we only get errors when we're trying to store larger things in smaller things. Now all of these data types can be used within expressions. So let me just put that F back in here so we don't get that error. So for example, I could say double X, and then I could set that equal to dd divided by S, for example. So we can mix the data types inside of expressions. This here is a double, whereas S is a short, and it's not giving us any issues. That's because, like I said, we're storing it in a bigger container, right? The double is a 64-bit container. But if we did something different, such as making this a float, well, hey, now we're getting an issue. Cannot convert from double to float. Now there is something called typecasting, which will basically force it, but this is going to put us at risk for a loss of information. Meaning if you're trying to store 2 backpacks worth of stuff into one backpack, you're going to not be able to put it all in there, and you're going to have to leave some of it behind. That's not always going to happen though, because we might just be storing some really small value inside of this double, and then it's able to fit inside of that float. So what I would recommend, if you want to learn more about these, go through this document here, or just look up primitive types in Java. There's a lot of examples here on how to do casting and so forth. So if you want to get a lot of information, you can go check that out. Or you could just keep watching this series because I'm going to be using these kinds of primitives all throughout. So the main takeaways from this video is if you're just trying to work with literal values, these extra characters are important. F for float, capital L for long, and that when you're going from data type to data type, you can only store smaller things in bigger things without an explicit cast, like right here. Also, all these yellow underlines, those are not errors. It's just saying we created this variable, but we're not using it anywhere in our code. So if you've enjoyed this content, please consider subscribing. That would really help out my channel. I'm trying to, take over the internet and whatnot. You can also get the link for the sponsor in the description, as well as a link to the crash course and the blogs. Thanks guys, I'll see you in the next one. Welcome back everybody. This video we're going to be talking a little bit more about how to get user input. In the previous examples, all we did was get string input, but now I want to talk about how to get input of these various types. Alright, so the previous video we talked about all these primitive values, and I'm going to get rid of this just so we can have a clean slate. Now if you guys remember how to get user input, what you need to do is you need to create a scanner, and then you can name it whatever you want. I'm going to name it scanner with a lowercase s. And set that equal to a new scanner, which we'll call the scanner constructor, and give us a new scanner object. Inside of the parentheses, you need to pass system.in. Now to get a new line, all we have to do is say scanner dot and then next. And there's all kinds of different options in here. The one we did originally was next line. This will return a string. So when you press the dot and then type out the function name or the method name, By the way, function and method are basically the same thing. Just the only difference is a method is attached to an object. And since we're in an object-oriented programming language, these are technically called methods. But enough of that. If you look at this, you can see a little bit more about what the method does. This one's not super clear what's going on, but basically this is going to get us a string. If you look at a different one, such as nextInt, it's a little bit more clear. The int scanned from the input. So let's start with next line and just see how that works. So what this is going to do is it's going to get a line and return it. And what that means is it's going to give us back an output. And we need to do something with that output. So typically we're going to store that in a variable. So we could say string x equals. Now we can output that with system.out.println. And it really super bothers me that this one's print line with like a lowercase ln and this one's line with a capital L in the full word. But what are you gonna do? We can pass x into here and now let's run it. And then it'll expect an input and then it will output what we just put in. All right, so that's how you do it with strings. Now let's try some other data. Let's say int y equals nextInt. Let's run that. And then what we can do is we could output that as well. And then my age is 5, it prints 5. The cool thing here is that this is typed as an integer, typed as in data type, not like typing on a keyboard. And what that means is we can use that inside of an expression. So I could say int a equals y plus 10, for example. And we're gonna talk a bit more about mathematical expressions, but for now, let's just go with this. And I'm gonna comment out this one so it doesn't keep asking me for input. All right, so now we can just pass in 20 and we need to print the new variable a. All right, so we pass in 20 and it prints the original one, then it adds y and 10 and assigns that to a. So now a contains 30 and it prints 30. Cool. Now, if you want to get any of the other data types, there are different methods for that. So let's go scanner.next, and now let's just look at some of these. So one of these is next big decimal and next big integer. These are two data types we never talked about because they're actually classes, and we've only really dived into primitive types. But if you guys remember the float and double data types, they allow decimal values. Well, this big decimal also allows decimal values. So you could store something like 10.1. But the difference between big decimal and float and double is that big decimal is trustworthy when it comes to precision. So float and double are known as floating point numbers, and this is a fixed point number. So if you're intending on working with something like money where you need it to be exact, you're definitely going to want to use a big decimal. And that would look something like this. So you could say big decimal, and we can say money instead of, oops, money instead of equal to scanner.next big decimal. This method here is going to return a big decimal, so we need to store it inside of a big decimal, which requires us to import this right here, java.math.bigdecimal. So that's how you could get a big decimal from the user. There was also one for big integer, which is slightly different than a normal integer. So if that's something you guys want to learn more about, you can research that. Anyways, let's look at some of the other ones. So next Boolean, that can be used to get a Boolean value. And it says here that it'll throw an exception, which is just an error, if it cannot be translated into a valid Boolean value. So let's try it. And I'm going to get rid of all this stuff here. And we're going to store this in a Boolean variable like this. And then we're going to output it too. Let's put the value true, and it works. We put the value false, and it works. We put something like 27, it gets an error. So basically it threw an exception, meaning that our program was not able to execute because there's an input mismatch. All right, let's see what else there is. And then there's this next byte with a radix. So what that is the base of the number. So we count in base 10, but if you're looking to use hexadecimal or octal, for example, you could check that out. There's also one for the next integer with the radix and next long. So if you're working with larger hexadecimal, octal, or even binary or whatever the base is, if you're working with those, you want to use one of these with this radix here. So let's just try this out. Let's say we want to get an integer using this radix, and let's say we want to pass in 8. And then let's store this back in an integer. We'll just call it x, and we'll system out this x. Okay, and now let's run this. So let's just put in the value 10, and this input is an octal, base 8. And what that means is this is going to be interpreted as 8 in decimal. So when we output it, it's outputting in decimal, we get the value 8. If that makes no sense to you guys, that's fine because we didn't really talk about it much. You can definitely go check out my videos on octal, hexadecimal, and binary, which will clear all that up for you. But most of the time, you're not going to need that. You're just going to be using the one with no arguments. And now it'll work like decimal. So I put in 10, it gives us 10. And then, of course, there's ones for double and float and long and short and all the different variations. So that covers how to get input of different types. Another thing you may want to know is just about casting. We talked a little bit about this. So for example, we might be getting an integer, but then we might cast that by storing it into a double. In this situation, it's automatically behind the scenes or implicitly converted to a double. But in some scenarios, let's say we got next double and we're storing that in an integer, we might need to cast that manually by using this parentheses int. So in this situation, if we run this and we put in the value 30.5 or even 30.9, it should just print 30. And there you go, you get 30. So that's how to get input of different types. Hopefully that was helpful for you guys. Please be sure to subscribe if you've enjoyed this series. Definitely helpful to me, and be sure to check out the description for some good links for you guys. Thanks guys, I'll see you in the next one. Hello everyone, congratulations on making it this far in the series. I am going to challenge you to get through the rest of it. Are you going to accept that challenge or are you going to let me down? Yeah, you better accept it. What we're going to be doing in this video is we're going to be talking about the numeric data types in more depth and just some cool things you can do with them. So we talked about how to create a primitive int, something like this. So this is known as a primitive because it's not an object. You can also create an object version by doing integer y and setting that equal to something. So this is going to be stored as an integer object. And I mentioned this in previous videos, most of the time you're going to want to use this. There are some rare occasions when you need to use the object version, but the majority of cases you're going to just use the primitive. Once we get into generic lists, this might come up, but until then, we're not gonna have to worry about it. But the reason I bring this up is that I wanna call out this integer class. This actually is very valuable to us because it's a class just like the class we're making here, and it has members inside of it. Just like in this MySweetProgram class, we have this static method called main. Well, inside of the integer class, there are some static methods we can use. So for example, we could say integer dot and see all of the members inside of this class. So the first ones up here, these are properties. Properties are just another name for variables that are attached to a class. And one of these important properties is min value and max value. So if you ever need to reference the absolute minimum value of an integer, you can use that min value here. Let's try it out. Just like this. And there you go, there is the minimum value for an integer. We talked in an earlier video how different data types are different sizes. So you can see that here if you do dot and then click size, this is going to return an integer here, which will be printed out. And you can see the size is 32, and that is 32 bits or 4 bytes. So that's pretty cool, and there are also a lot of methods attached to this class. So you can look through these and see which ones might be useful for you. We're not gonna get into these quite yet because I want to talk about how the different data types have the same properties. So for example, I can go to double, and then I can put max value right here. Let's see what the max double size is. All right, so we have some exponential notation, pretty huge number basically. With a double though, only a certain number of digits are considered trustworthy. So like up here, it's more trustworthy, and then at some point, you can no longer trust it. A double is a 64-bit number, and typically it has 15 digits of precision. So after you get 15 numbers in, you can't really trust it anymore. There's also something very interesting with the double that you should know about. And this is across all programming languages, it's not just a Java thing. There's going to be a few special values. The first one is going to be infinity. And there's actually two infinities. There's a positive infinity and a negative infinity. So for example, if we wanted to print positive infinity, it just says infinity. So those are two properties you might want to know about. There is also NaN, which stands for not a number. And this is a special value of double that literally just means it's not a number. There are occasions when certain expressions evaluate to something that's not a number. For example, inside of the math class, there is the square root. And we could take the square root of -1. And what we're going to do is we're just going to system out this, like so. And when we run this, we get not a number. The first not a number is the one we're printing right here, and then the second one is doing the square root of -1. Inside a double, there are methods to test for this. So for example, we could say is nan, and there's also methods for is finite and is infinite, which will, the is infinite will test for the positive or negative infinity. But we can just show this double is nan and pass in the math.square root of -1. And then we're just going to output this whole thing. So it's going to get a little complicated here with the parentheses, but we can do it. And we can see that it outputs true. So the way this is set up is pretty interesting, just so you guys can see how things get evaluated. This math.square root gets evaluated first, and then that, whatever the result is, the return value of that gets passed to this double.isNaN, which is right here. And then the answer of that is passed to the print line. So math.square root -1 gives us not a number. Not a number is passed into is not a number, and it's evaluated to true. And then true is passed into the print line. Just like certain expressions can give us NaN or not a number, there's certain expressions that can give us infinity. So for example, I could do math.pow, and I could take, you know, some really large number here, like 99999, raise that to the tons of power. And then we're just going to, oh, got an issue here. Let me just bring that down a little bit. There we go. It just has to be in the range of an integer. And now I want to output this to the console, and it prints out infinity. You could do the same thing by passing in a negative sign, and then we get negative infinity. So that is your introduction to the numeric data types and just some of the special values that come with the double data type. Hopefully that makes things super crystal clear, and the cool thing here is that the whole concept of infinity, negative infinity, and not a number is not just a Java thing. You're going to get this in JavaScript and other programming languages as well. That's because the double data type is based on a standard IEEE 754 or 754. So if you want to learn more about the double data type, you can check that out. But that's all I got for you for now. Please be sure to check out the next video and subscribe if this has been helpful for you. In addition to that, please check out the description for a link to the Java crash course, the blogs, as well as our sponsor, who has been tremendously helpful in creating this series. Thank you, and I'll see you in the next one. Welcome back, everybody. Throughout this series, we've been throwing around the word expression, like, oh, here's an expression, or just throw an expression in here. And we've been also talking about operators, but we haven't really gone through the process of defining these in detail and explaining them in a little bit more depth. So that's what we're going to be doing today. Well, the first thing I wanted to talk about is there are some concerns when you mix data types inside of an expression. So for example, let's say int x is equal to 5 divided by 2. So in this situation, we have an integer 5 and an integer 2, and we're storing it in an integer x. So there's no blending. Oh, come on, Claire, seriously? It's been like 4 years. So there's no blending of data types here, they're just integers. What you should expect to get is the value 2, and it helps if we output it, right? All right, so we get the value 2. Now, the thing you need to know is that if we were to switch this to a double, we're still going to get the value 2, it's just gonna be stored with the .0 at the end, 2.0. And the reason that is because we are doing math with an integer and an integer. So this division is using integer division. So imagine you can only use whole numbers. So I always think about it, hey, I have 5 slices of pizza. I have 2 people to split it amongst. So I hand each person 2 pieces of pizza, and that leftover one, well, we can't split it in half, right? That's just bad. You just don't split pieces of pizza, right? So you have to throw it away, right? And as a result, each person only gets 2 pieces of pizza. So if you wanted to get 2.5, which would make sense, there's 2 ways you can do that. You can go in here and put a .0. So what's happening now is we are taking a double and dividing it by an integer. And what's going to happen is it's going to use double division. So now you can cut that last piece of pizza in half and split it amongst the people. And as a result, you get 2.5. The second way to do this is to put the keyword double right before it, just like that. And that'll be helpful if you have a variable. For example, you might have int a equals 5, and you might have a variable here, right? But you can't do a.0. That doesn't make any sense, and you're going to get a compiling error. So instead, you just need to put that double right in front. There we go. And we get 2.5. So the important thing to know here is that double is an example of an operator, similar to like the plus sign we've used. but it only works on one operand. So if you do something like 5 plus 5, well, this is going to take one operand and add it to another operand. So it uses two operands. This one is only going to use one, which is the thing directly to the right of it. So the A. So the operators that use two operands are known as binary operators. The ones that use one operand are known as unary operators. So this is a unary operator, and it's important where you put this thing. For example, you might think, oh, hey, we could just use double division for this whole thing. But it doesn't really work that way, because what's going to happen is you're going to get 5 divided by 2 using integer division, and then it's going to be cast into a double. It doesn't work that way. So you get 2. Bummer. So yeah, you got to keep it like this. So my rule of thumb, just for safety, is I always try to make sure all the operands are of the same data type as the result I'm trying to get. In general, I mean, I'm not like super strict about it, but if I'm trying to get a double as the end result, it's probably best if I just go in and make all these double, even if it's not even necessary. Because I'm still going to get the same result, but now I know that I'm not going to make any mistakes. This really only matters if you're doing something like division. Like, for example, if I'm multiplying here, it's going to be the same exact thing if I use the 2 or the 2.0, right? So there's no sense in me going in there and putting in dot zeros or casting everything to doubles. Now, the next thing I wanted to talk about are some of the other operators we could use. So we've talked about some of them. I'm just going to make a comment section, and here's how you do that. We have the addition sign. We have the minus sign. Oh, this isn't gonna work, dang it. Plot twist, I can't put a / because then it ends the comment. Anyways, you need the /, that's the division. And then we have the asterisk, which is multiplication. So find all those characters, make sure you understand which one's which. And then we have a special one, which you may or may not have heard of, the Modulus Operator. And what this is going to do is it's going to give us a remainder. So if we go back to that example we had, which I probably shouldn't have deleted it, but it's all good. We just say int x equals 5 divided by 2. This gives us the result 2, right? Because it's doing integer division. So there's actually a remainder if you think about it. Because, you know, one person gets 2 slices of pizza, the other person gets 2 slices of pizza, and then we have to throw the 5th one out. So if you want to get that remainder, instead of using this division, you use the modulus operator, which is capital 5. This should give us 1. And there we go, we get 1. This seems kind of useless, like why would you ever need that? But there's actually a lot of useful things you can do with the modulus operator. It's kind of quite magical, honestly. Now when it comes to precedence, this is the order in which things get evaluated. The division, multiplication, and modulus all have the same precedence, meaning they get evaluated first. So if you have 5 plus 3 divided by 2, this is going to get evaluated first, and then whatever that result is going to get evaluated with the 5. And it's from left to right, so if we have a multiplication right after that, well, this one's going to get evaluated, and then this one's going to get evaluated. So if you need to force precedence, you can use parentheses. So if I need this addition to go first, we could do that there. And sometimes it's helpful just to put the parentheses there even if they're not required, because that's totally okay too. So if I needed to add some extra parentheses in here, that's fine too. After that, the addition and the minus come up in precedence. So once all the division, multiplication, and moduluses are evaluated from left to right, then we go from left and right again for addition and minus. Now the next thing I want to talk about is the increment and decrement operator. So I'm going to get rid of all this junk, and we're just going to create a variable and give it the value 5. And what we can do is we could say x plus plus. And this is going to increase the value of x by 1. So if we output this, we should get the value 6. And we do, yay! The same thing can be done by decreasing the value using x minus minus. And let's output this. It should be back to 5 now. So the important thing to note here is that when we use the increment and the decrement, it changes the variable value. The other operators we talked about didn't change anything. For example, if I do double x and cast it to a double, well, that's just changing the value in the expression. It's not actually changing the variable because, as we mentioned, Java is a statically typed programming language, so that means it's always going to be an integer. Same thing if we do addition, if we do x plus 5, well, this doesn't change x, it just changes the expression. So if we're assigning this to something, the value will be 5 higher, but x always stays the same. The increment and decrement are different in that the variable value is changed, and that is super important. Now there's another variation, which is the prefix increment and decrement. So I could do plus plus x, and minus minus x. In this situation, they work exactly the same way, so it's just a preference here. Now the difference comes up if you're using them inside of arguments or inside of an expression. So for example, let's just start fresh, all right? And we're going to create a new variable a and assign it the value x++. Now we're going to print out both of these, just like that. And let's run it. So we get 6 and then 5. So you can see the value of x is incremented, but the value of a gets the original value of x, which is 5. So what's happening is first this x gets assigned to a, it gets the value 5, and then x is increased. The opposite happens with the prefixed versions. So if we run this, we get 6, 6, because first x gets incremented to 6, and then the value 6 gets assigned to a. So we print 6 and then 6 again. Awesome, and now the last section of operators I want to talk to you about are assignment operators. So you can see the most basic one right here. 5 is assigned to x. This is the assignment operator. Well, there's actually some different versions. So for example, I could say x is plus equal 1, and this is going to increase the value of x by 1, similar to the increment operator. And what's going on here is we're basically just saying x is equal to x plus 1. So this is a shorthand for this. You can do either one. This is a little bit more flexible than the increment operator because I can change the value here. So I could increase it by 20, I could increase it by 200, I could decrease it by 200, I could even multiply it by 200 or divide it by 200. I can even do the modulus to assign the remainder to the variable. So those are some different operators you can try out. I encourage you just to experiment, see what kind of values you get, and see if they were what you were expecting. That's all I got for you in this video. Please be sure to check out the next video. Don't quit your learning process. I promise you that everything in this series is going to be very valuable for you in the future. If you've enjoyed, please subscribe. Also check out the links in the description to the Java Crash Course, the sponsor, and the blogs. Thanks guys, and I'll see you in the next one. Hey, welcome back everybody. This video we're going to talk about some of the important methods on the integer object as well as possibly some methods on the double object as well. Okay, so what we're going to be talking about are some methods. Methods, if you remember, do something. So we can use the integer class, and inside of this class there are some methods we can use which are shown right here. Now the important thing to realize is that these are static methods. So that means we can call them directly. We could get this max method, for example. And in here we can pass in a value and another value. And these might be variables. You might not know the values ahead of time because obviously in this situation, we can tell you that, hey, 20 is going to be larger, but you might have it to where it's like this. And you get this x from input, and then you have y, and you get this y from input. We could say x and y. So this is a static method, meaning we call it directly on this integer class. We don't have to create an instance of this class. If it wasn't a static method, we would have to do something like this. And then give it a value like so. And then you would go in here and say my int dot whatever. So this technique is an instance method. This technique is a static method. We run it and we get the value 20. So you can use max to give you the bigger of the two numbers. Another important one is the compare method. So you can go in here and type compare. And you can see that it takes 2 arguments because one would be assigned to the parameter x and another would be assigned to the parameter y. And the return is an int. The integer that it returns has 3 possibilities. The first is that it's 0. If that's the case, they're equal. If it's less than 0, then x is smaller. And if it's greater than 0, then x is larger. So for example, if we go in here and we say x and y, and let's say we just want to output this value, like so. We run this, and we get the value -1. So that's telling me because the output is less than 0, that x is smaller. So this compare method is a little bit more dynamic than this max method. You could use the max method if it works, but the compare method could be used for more scenarios. Later on the road, once you learn about if statements, you can go in here and throw this inside of an if statement and branch depending on if they're equal, one's greater than the other, or one's smaller than the other. So what else do I need to know? Well, an important one to know is if you scroll down here, honestly, there's a ton in here that you should probably just go through and look through because I'm not going to go through all of these. One I'm going to talk about though is this value of, and then we're also going to talk about this parse int. So what these two methods are for is taking a string value and converting it to an integer value. So let's say we have some string and we pass in that value right here. And now let's output that. These should both print the same thing. Oops, I got an error. We have to capitalize the string because it's a class, and that class is capitalized, and we need to make this a string. All right, let's run this. So they both print the value 300. So then what is the difference between these? Well, you can actually see if you look at the description of the methods. So this value of, you can see that it returns an integer, capital I, the full word. Whereas the parse, this returns an int, lowercase I, not the full word. So if you guys remember, the difference between those is that one is an object and one is a primitive. So that means if we wanted to get rid of these outputs here, and we wanted to store these values, what we would store them in would be different. So in this scenario, we could store this inside of an integer, like so. But if we wanted to store this one, we would store that inside of an int. So if you're in this scenario where you need to convert a string to an integer, it depends on what you're trying to do. Are you trying to work with primitives, or are you trying to work with objects? I would say most of the time you're going to be doing this one, but there may be situations when you need it as an object. Double has some similar methods, so we can look at some of those real quick. Double dot is finite, for example. These are methods that can test a value to see if it is a finite number or if it is infinite. I think we talked about this briefly, as well as is not a number. There's a similar method to get the max value and the minimum value. There's a parse double, just like there's a parse int. And there's a value of, just like there's a value of for integers. So you can see there's a lot of similarities between the methods. The main difference is that we're going to be getting a double value rather than an integer. So hopefully after going through this, you have a pretty good understanding how to use some of the common methods with integers as well as doubles. It should be fairly similar throughout the different numeric data types. So now that you understand the integers, it shouldn't be too hard to pick it up for the doubles and the other ones as well. So that's all I got for you guys on numeric methods. Hopefully that was helpful for you. Please be sure to subscribe if you've enjoyed this series. And as always, don't forget to check out the description for a link to the Java crash course, the blogs, and our amazing sponsor. Thank you guys. I'll see you in the next one. Now, let's start talking about the string data type. The very first thing you need to know is how to create a string. If you've watched this series up until now, it should be pretty simple. Something like this. And you should also notice that we don't have to say new string, although that is possible. So I could say new string, and then inside of these parentheses pass a string literal like hey, for example. Java has just made our life a little bit more convenient in that we don't have to do this here. That's not always going to be the case when working with objects, but strings are one of the exceptions where they just make our life a little bit easier and we can just keep it simple like this. So in this scenario, the constructor method is going to be called behind the scenes. It's going to work exactly the same way. And we can work with X just like we would if we said new string and put the value hello. So what you need to notice is that string is actually started with a capital letter. That is in contrast to the primitive values like int or double. And that is because we're not creating a primitive value. String is not a primitive, it is a class. So what we're doing is we're making an object, an instance of a class. It's fundamentally different than a primitive type, but in general, working with the variable works similarly. So string is similar to integer in that there's static methods as well as instance methods, where anything called on the variable is an instance method because we have to create an instance of string, also known as an object, and then the statics are called directly on the string class itself. Now, when you create a string, you're going to use double quotes. Some other languages allow you to use single quotes, like so, and this is not going to work in Java. When we use single quotes, we're actually saying that this is a different data type. The single quotes are reserved for characters, and a character is only one of these letters, not all of them. So H is a character, but even still, we can't go and assign that to a string automatically. So languages like JavaScript or SQL might allow you to use the single quotes, but in Java, you're not going to be able to do that. So I'm just going to get rid of that. You can work with the individual characters of this string, and in order to do that, you need a special method. In order to do that, you need a special method, which is char at. And then you pass in an index. The index starts at 0, so this character has the index 0, this one 1, 2, 3, and then 4. So if we pass in the value 0, we should get H. And let's just sys out this to prove it right there. So let's run it and we get the value H. Awesome. Now, if you go out of the bounds of the array, you get an issue. You can see that when we run this, we get an exception, which means there was an error while we were running our program. So this is a runtime error and it says string index out of bounds exception. So later on, we'll talk about how we handle exceptions, but for now, just know that you shouldn't do that. This also just kind of shows the strictness of a language like Java. This is unlike something like JavaScript. If you go out of the bounds of a string in JavaScript, well, it's just going to give you the value undefined and nothing's going to happen. Now, inside of a string, you can have special characters. So for example, one special character is a \n. Let's run this. Actually, let's put a couple of them here. And then we'll say cats. I don't know. And then we're going to output this and run it. And we get hello, and then we get a new line, another new line, another new line, and then the value cats. Because each one of these \n's is a special character that gets rendered as a new line, or think of it as the equivalent of pressing enter. Here are some of the other special characters you can use. The one we just did was new line, but you can do similar stuff such as rendering a backspace or a tab or a \ itself. The reason we need this \ one is because when we use a \, it's assuming we're going to use a special character, but we're not. So in order to say, hey man, we don't want to use a special character, we need to escape that \ by using 2 backslashes. So now it knows we just want to print 1 \. So that's pretty cool. Hello cats. The next thing I wanted to talk about is how you can concatenate strings. So if you're outputting something, you can put strings in here like X, and you can use the plus sign, which is going to concatenate 2 strings. And concatenate just means combining one string with another string. So I could say and dogs. And I'm just going to put a space here and just kind of clean this up just a little bit. So let's run this, and it says hello cats and dogs. This one is just printing the original value. Don't worry about that. And the important thing to know here is that this concatenation does not affect the variable X. If we were to do something like X plus equals and puppies, well now, what we should get when we output this, we should get hello cats and puppies, because this is actually going to change the variable X. So let's run this, and we see we get hello cats and puppies. So that is in the variable. The one hello cats and dogs is not actually changing the variable. The only thing that's happening is we're creating a new string here, and that string is getting passed into print line. X is not affected. This system of concatenation with this plus operator does work for some scenarios, but there's actually another way you can do this, and which one you prefer is totally up to you. The other way is to use string.format, which will allow you to kind of templatize your string and fill in variables in different spots. So to do string.format, you just say string.format, and then in here you pass a string which defines that format. So for example, I could say hello %s, and then this %s is going to be another variable. So let me just clean this up a little bit. So we're going to say we have a string name and set that equal to Caleb. And then what we can do is we can fill in the variable Caleb to this %s by saying name like that. All right, and then what we need to do is we need to print this thing like so, and then run it. Okay, I got an error. Oh, I got a little bit too many curly braces there. I was scrolled over so I didn't see them, and I thought I deleted them, but they were just sitting there. All right, let's run this. All right, and you can see it says hello Caleb. So that's the basics of the string.format. It can get a little bit more complicated though, so if you really want to know, just look up string.format if you're trying to make some more complex strings. Which way to do it is totally up to you. The last thing I wanted to mention to you guys is just how to get the length of a string. So for example, if I do name.length, and this is a method, it's going to return an int of how many characters is in this string. So if we're getting name.length, it should return 5. Let's just output it and see if that's what we get. And you can see we get the value 5. Awesome, so that will come in real handy when you need to tell people how many letters their names have. No, but seriously, later on we'll probably use something similar to this when we want to basically indicate how long a string is so we don't go past it. So we could say, hey dude, the length of the string is 5, so you don't want to go past the index 4 in the characters, else you're going to go outside of the bounds of the string, and the computer's going to explode, everyone's going to die, and it's going to be really bad. So definitely know that length exists. We're not going to use it for right now, but it might come up in the future. It's definitely a very common method, and you'll definitely want to know how to use it. In Java, this is a method. In some other programming languages, it's just a property which would just be accessed without those parentheses. But just a side note, you're going to want to keep those parentheses there. So those are the basics of strings. Hopefully that helps you guys just get up to speed with working with strings inside of Java. Obviously I can't cover everything, so keep going through this series and we'll just continue to work on strings as well as a bunch of other stuff. So please be sure to check the links in the description for a link to the Java crash course, the notes, and our sponsor. And with that, I just ask that you subscribe and go on to the next video. Cheers! Hello, my sweet YouTubers. Today we are going to be talking about string methods. Now, you can see I have this beautiful string here, my oh my, chicken pot pie. It was the first thing I thought of, honestly. I don't even know why I thought of it, because I literally hate chicken pot pies. Like, I think they're the most disgusting food in the world. And with that, I would like to introduce my sponsor, Banquet Chicken Pot Pies, giving people nearly a half a day's worth of sodium in only one serving since 1953. No, I'm totally kidding. Guys, it's only 39%. That's not even nearly half. The first two methods we're going to talk about are kind of stupid, but I'm going to teach them to you anyways. Okay, I guess the first one's kind of important, and that is char at. Now, this is where you pass an index, and it's going to give you that character. We talked about this briefly in the previous video, so if you are watching the series from the beginning, you probably already know how this works. So what we're going to do is we're just going to get the first character, and it's going to be an M. And we can put in a different index here. And now we get H. Now, spaces are considered characters, so if we're going to get the 10th index, it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is H. If you wanted to get the last character, you could actually go in here and get x.length minus 1. And you want to make sure you have that minus 1 because the length is always going to be 1 larger than the last index because the indexes start at 0. So run it and we get E, which in fact is correct. Now this next method is kind of stupid, but we're still going to learn it. All right, so this one's concat, where you can actually add a string in here, such as now with 20% more chicken. And this is going to return a new string. So we actually need to output the result of this. There we go, there's our entire string. If we wanted, we could assign this to a new string. So we could say the full add is this. So this method might be useful for you, but more than likely you can just use the plus operator. So for example, we could say x plus this string right here. So I'm not really sure what the use case of that method is there, but it's good to know that it exists because you might see it in code and you should know how it works. So we can sys out this new full add and it should be the same exact thing. Yes. Now moving on to some more useful methods. The first we have is contains. So we could say full add dot contains. It'll return true or false depending on whether the string contains whatever we pass in here. So for example, we could say chicken. And now let's sys out this. And you can see the result is true. So that is a very simple method for a binary yes or no. If you're looking for something a little bit more complex, there is a method you could use. That method is the index of method, and that's going to actually tell us where it was found in the string. So we're going to go through another example. Let's say full add dot index of. And if you look at the options here, we could pass in a character, but we can also pass in a string. So we can call this method and pass in my, for example. And my is the first thing in the string, so it should return back 0. I think I had one too many parentheses there. Let's run it. And we get the value 0. Now this method actually has another option. This is known as an overloaded function because there's more than one possible way to call it. So we can pass in another argument, which is the index to start at. So for example, I could put in 3. And now what it's going to do is it's going to count 0, 1, 2, 3, and it's going to start right here. So the value should return 4. What? Oh, bologna sandwich. So it's going to count 0, 1, 2, 3, and it's going to start right here. And my should be index 4, 5, 6. So the value it returns should be 6. And we get 6. Awesome. Now here's a trick for you guys. If you want to skip the first occurrence, but you don't know what index it's at, you can do that dynamically. So for example, let's just say yum. Now, we're just putting that there just so it doesn't start at 0. It makes it a little bit more fun. All right, so now what we can do is the second argument here, we can pass in another call to index of. So we could say full add dot index of, and the value we're going to pass in is the same thing, my, but then we're going to, outside of the function call, add 1 to that. So basically it's going to find my, it's going to hit it, and then it's going to add 1, and it's going to start the search right here. So it's going to skip that first occurrence. We run it and we get 15. There might be 400 my's in here, so I'm not really sure how to scale this to grabbing like the 39th, for example. There is something you could do to grab the last occurrence of my, and that's actually its own method. So we can go over here and try that out. So we could say full add dot last index of, and same thing, we could be searching for a character or a string, and we can optionally pass in a from index. So if we look at this one, it'll search backwards starting at the specified index. But let's just first grab the last occurrence. What are we looking for? We're looking for my. Run this. Got an error. Had a little typo in the method name. Run this and we get the value 15, which is correct because the first one we skipped and then we found this one earlier, which is 15. It's also the last occurrence of my in the string. Similarly, you could pass in another argument if you wanted to skip the last one and get the second to last one, and so forth. So those are some basic string methods. I'm gonna get going because I really gotta go eat some chicken pot pie now. I am starving. So thank you guys. Please be sure to check out the description for links to the Java Crash course, the blogs, and the sponsor. And if you're enjoying the series, please consider subscribing as that definitely helps out my channel. All right, peace. Good morning, it's a new day here, and today we're going to be continuing our discussion on string methods. If you're not familiar, string methods can be used to manipulate strings. By understanding how to use some of the most popular string methods, you're going to advance your Java skills and your development skills in general. Now let's move on to string methods. We're just going to go through some examples to see some of the most common methods. We have this string here, which is called full add, and it's just an advertisement for chicken pot pies. And if we were to put this ad on TV or something, it's really not going to work unless we're screaming the ad the entire time. So in order to do that, we need to put in all uppercase letters. So to do that, you can say full add dot to uppercase and run that. And you can see now it's in all capital letters. You know, but this method of advertisement might not work if you're doing online advertising, for example. So you might want to actually make everything lowercase. So for example, if we had some capital letters in here and we wanted to bring everything to lowercase, very similar, you just use two lowercase, just like that. The next method we're going to talk about is used to remove extra spaces in the beginning or at the end. And this might be useful if you're asking a user for something. So like, let's say we want to get their username or their password or something, but we want to make sure they don't put extra spaces at the beginning or end. We might just want to clip off the beginning and end any white space. So to do that, we just do full add dot strip. And when we execute this, it should just be the normal string. And if you wanted to see what it would be like without the strip, you can see that white space is printed. Now, if you go in here and put a \t, which is a tab, or a \n, which is a new line, and then we do the strip, well, when we execute it, you can see that that also goes away. So white space includes spaces, tabs, and new lines. There might be a situation where you want to do this, but you only want to do at the beginning or at the end. So to do that, what we could type in is dot strip, and then you can see there's leading and trailing. So the leading is going to be at the beginning. Oh, okay, Claire, you're gonna start sending me emails too? Seriously. Oh my goodness. So if we do the strip leading, you can see that it gets rid of the white space at the beginning, but there's actually some white space here at the end. And trailing works in a similar way, it's just at the end. I'm sure you guys can figure it out. The next method we're going to talk about is substring, and this can be used to get a section of the string if you don't want to use the entire thing. So for example, we can go in here and call substring, and then we pass in an index to start at. So let's just clean this up just a little bit. Let's say this is our string, and we want to start at this my oh my. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So index 9 is going to start at the my. And if we run that, we should just get the rest of the string starting at my. If you want to stop at some point, so for example, if I just want to get my oh my, then we need to pass in the ending index, and that last index is not included. So we want to actually grab this index. So if this one's 9, we need 10, 11, 12, 13, 14, 15, 16, 17. So if I go in here and pass 17 in here, you can see it gets my oh my, and there's no space at the end. So the beginning one is inclusive, it includes that character. The last one is exclusive, it does not include the character at this index. Another cool method that honestly I have no idea what it's for, but I'm gonna teach it to you guys just for fun, is this repeat method. And basically you can put in a value here and it'll just repeat the entire string. So I could say 300, you know, why not? And you can see it's going to print that string 300 times. So yeah, why would you want to do that? I don't know, but it's cool. So for example, if we went in here and put a \n for a new line, now it should print them all on a new line. And there we have 300 occurrences. So that's an interesting way to make sort of like a loop in a string, if that's something you're into. I'm probably never going to use that method again, so moving on to the next one, which is equals. And here you pass in another string, and it will return true or false depending on if the values of the string are the same. So for example, if I pass in hello here, well, I can definitely tell you that hello is different than this whole string up here, so it should return false. And you can see I was right. I know, I'm pretty smart. Why would you want to do this? Well, later on, we're going to get into conditionals. So basically, you could make some kind of condition. For example, let's say we had a password, and that password is let me in, which is by far the worst password ever. You know, because people will be like, what's the password? And they're going to be like, let me in. All right, that was a stupid joke. Okay, and then in here, what we could do is we could say password.equals, and then inside of these parentheses, we could put a value that the user guessed. So if we were to get user input here, which I guess we could just do that real quick. So we get a new scanner object and we pass in system.in. And then all we have to do is say scanner.nextLine right here. And what we're going to do is we're going to store this inside of a string. We'll call it guess. So now it should ask the user for the password. Maybe we can give an output just so they know what to do. So we could say guess the password. And then we can put this guess value inside of this equals method. And if the guess is equal to the value of password, then they win. Otherwise, they lose. So let's just run it. Guess the password. We're going to guess let me in, and it returns true. Let's try it again. Guess the password. Taco Bell is legit. I don't even like Taco Bell. Pizza, we get false. So that covers some of the main string methods. Yes, there are more. If you want to see some of the other ones, you could just put a string in here and look at all these methods. Obviously, I don't want to go through every single one because this is not a reference. This is designed to help you guys learn how to use these methods. So thank you guys. Hopefully that was helpful, and hopefully you have a good understanding of string methods. If you've enjoyed this, I just ask that you would subscribe. When you subscribe, that makes me happy. So if you want me to be sad the rest of my life, don't subscribe. Also, be sure to check the links in the description for a link to the Java Crash Course, the notes, as well as our incredible sponsor. Thank you guys. I'll see you in the next one. Yo, what's up everyone? This video, we're gonna be talking a little bit about classes and objects. Now, this is not the start of our deep dive of object-oriented programming. This is considered an introduction so that we can start talking about some more complex programming concepts, because basically we've been working with a lot of methods and a lot of objects, and I just want to make sure that you have that fundamental knowledge needed to really understand why we're coding things the way we are. Hopefully this video will help progress your understanding of object-oriented programming, which is a huge piece of software development. This will often come up in interviews, so it's really important to know. We see the basic structure of object-oriented programming already just from what we have here, and we actually don't even need this line here. So we have a class, and in this class we have a method. So we're going to basically copy this format here, but a little bit different in a brand new class, and classes are often used to basically set the structure for something you might want to represent. So for example, you might want to represent people, you might want to represent users, you might want to represent transactions, you might want to represent animals. Whatever it may be, all of these things can be represented inside of a class. If you have any experience with Excel or databases, you can kind of think of a class as the column headers, right? It kind of defines the structure of each row, and then an object is going to be an instance of that structure. So an object would be the equivalent of each row with individual values. So the best way to see this is to just go through an example. So let's create a new class. Over here on our application, we can right click, hover over new, and click class. We're going to name this user with a capital U. By convention, class names start with an uppercase. When we created our first class, I told you to check this public static void main. In this situation, you're not going to check that. That's because you only want one main method per program. That's where your application starts. So just keep it as user and click finish. So inside of here, we can put all of the members of this class. These members are usually going to be methods and properties. And there's some details that once we get into object-oriented programming you should know about. For example, there's fields and then special methods called getters and setters for these fields, and there's constructors and all kinds of stuff, but you don't need to get into all that. The main thing you need to know is that when we create a variable inside of this user class and make that publicly accessible, it's known as a property. So I can go in here and I could say public string name, just like this. In the outside world, we can create an instance of a user and set the name property. So let's do that. Let's go back to our main method. In here, we could say user, give it a name. We'll just call it user with a lowercase u, and then say new user, just like that. And now we should be able to access this property name and set that equal to Caleb Curry, for example. So the process we just went through of creating a new user will become second nature over time, but you may just want to practice it. So practice creating a class, instantiating a class into an object called user in this case, and then setting the properties to some value. So that is an example of setting a property. Now let's go through an example of a method. So inside a user, what we're going to do is we're going to say public, and this is going to return a string, and it's going to be get full name. And then you're going to put parentheses and then curly braces. Now whether you put these curly braces like this or like this, that's totally up to you. Just try to be consistent. All right, now we're going to break up name into first name and last name. So I'm going to have first name, and then we're going to have another one for last name. Okay, cool. So now back in our sweet program, we need to change this to user.firstname. Okay, cool. Back to user. Inside of this method, we could say return first name plus last name. This will combine them, but it's not going to put a space between them, so you might want to put a space string like that. So now we can call this, we could say in our main method, we could set our last name, so we could say user.lastname equals Curry, and then we could call that method, and we're going to put it inside of a system out because it's going to return a string. And then we just say user.get full name, just like that. And we run the program and we get Caleb Curry. So that is the basic process of creating properties and methods. It can get very complicated, so don't be overwhelmed. Basically what I wanted to show you is this is the comparison to the methods we've been calling on strings, for example. So when we do something like string x equals hello, and then we say x dot whatever it may be, well, this is the equivalent to user dot whatever it may be. So just like we have a method on user get full name, we have x dot char at, and this is going to return a character, just like ours is going to return a string. The actual act of creating it, well, we're going to get into that in a lot of detail in the upcoming videos, so I wouldn't worry about that too much. But basically the main things you need to understand is that these need to be public in order for us to change them in another class, and our get full name needs to return something because we're putting this string here, which is saying, hey, we're going to be returning a string. These here I called properties. You may also hear the term field, which is just a private variable. So if I did string say food, for example, well, in this scenario, this would be a field, not a property. And we're going to get into all the details of object-oriented programming soon, so don't worry about that too much. That's all I got for you guys. Hopefully that was a good introduction to creating properties and methods inside of classes, how to instantiate those classes into objects, and then how to change the values of the properties and call the methods. This might be a little bit of a deep dive into programming for you, so if it's a little bit challenging, just watch this video again and just go through the coding exercise with me, and it'll be all good. In the next video, we're going to take a step back and learn some more of the basic programming structures, so definitely check that out. And if you've been enjoying the series, I just ask that you subscribe. It truly helps out my channel, and I would be really appreciative. Thanks guys. Also check out the description for links to the Java crash course, the notes, and our sponsor. Thanks, and I'll see you in the next video. Welcome back everybody. In this video we're going to be talking about string comparison, and we got a taste of this earlier when we did this dot equals in a previous video, but now we're going to go in a little bit more depth and talk about some of the gotchas that you need to know in order to do string comparison. So let's take a look at our code. We have an app that has a password, and then we ask the user for that password and compare to see if it's correct. So when we run this, we can guess a password I know it's let me in, so I'm going to put that. It returns true when this comparison happens. So we're basically just checking to see if the password right here is equal to what the person guesses. This is the proper way to compare the value of two strings. So it's going to compare this value let me in versus this value let me in. And you can see that each character is exactly the same, so it evaluates to true. Really soon we're going to be talking about comparison and branching with if statements, and oftentimes you're going to see something like this in some Java code, where we have password and then two equal signs, guess. These two equal signs are known as the comparison operator. It's different than the assignment operator. So basically it's going to compare this string with this string, but it's not actually the recommended way to do string comparison. And the reason why requires some deeper knowledge of how the data types work in Java, but the main thing to know is that primitives, this will work. But for objects, this does not work. That's because the values that objects contain is actually a reference to the object. So for example, think of this guess variable as a container that points to the string. If that doesn't make sense yet, that's totally fine. It will soon. All you really need to know is that primitives directly contain the value that they're storing. So if we do something like int x equals 5, well, x directly stores the value 5. When we create an object, such as a string, and we could use the string constructor, for example, this is an object. Strings are not primitives, so the way they're stored is a little bit different. And when we do comparisons with objects, it's not comparing the values, such as this string here, it's actually comparing the memory location. So it's asking if it's the same area of memory. So you can see how that could be pretty confusing. So to see this in action, let's give it a try. I'm just going to clean some of this up. And what we're going to do is we're just going to output this comparison, like so. And when we run this, well, first it's going to do this system out right here, and this is going to actually compare the string content right here, and this one should return true if we get the password right. This one down here, though, is going to compare the location of memory, and these are not referring to the same exact strings, so it's going to return false. So when I say let me in, you can see the first one says true, and then the next one says false. So to sum up everything I just said, you'll want to use this technique versus this technique. One problem though is that sometimes this will return true. For example, let's say we create two variables, string A, and we'll set that to high, and then string B, and we'll set that to high. So these have the same exact values. And then what I want to do is I want to compare these. And we're going to say A compared to B. And this is probably going to return true. You can see the final output is true. So what in the heck is going on here? This actually tripped me up for a while because I couldn't figure out why sometimes this comparison worked and other times it did not work. Because clearly these are two different strings, right? So why exactly is it coming out to be true? And in my wisdom, I figured out the answer by searching Google. So inside of the Stack Overflow question, we're talking about string interning. And it's basically a process that goes on behind the scenes. So if I scroll down to one of these answers that was really helpful to me, you can see this catchy interview question here. So this is actually some good stuff to know. Looking at this code, it's a similar thing where we have two exactly the same strings, but they're in two different objects, yet it evaluates to true and it prints equals. And this guy explains how the test string value is interned for you by the compiler. And I haven't studied this a whole lot, but I basically understand it as some sort of caching. So if I scroll up again to this question here, this guy explains how doing string.intern on a series of strings will ensure that all the strings will use the same memory. This can save memory because if you have the value John 1,000 times, the end result is that you only have one John, and it's only allocated one time in memory. So this is really going into the deep end of Java, and I'm honestly not sure it's important to know all this. As long as you're doing the right technique of comparison, you should be good. But it can definitely help to know that there are situations where the strings are automatically interned, such as in this case here. Basically, Java is seeing these string literals and saying, hey, these have the same exact value. So we can save memory by having these two variables point to the same area of memory. Sort of like an optimization thing, except the result is that sometimes when we do these comparisons, we're not getting the results we expect. So to conclude, looking back at our code, you'll definitely want to use this dot equals. We can avoid that interning if we were to go like new string with this constructor. And for some reason, this will say hey, these are not string literals, we're trying to make string objects, they're not the same thing. And then when we run this, the final result is false when we do this equals equals or the comparison operator. So that's how the comparison operator works with objects, but just for completeness, I'm going to show you an example with primitives. If we have two variables such as int x equals 10 and int y equals 10, when we compare these, we should get the value true. X equals y, run this, the final value is true. Primitives are different than objects in that they contain the value directly, so when we do this, we're comparing the value 10 to the value 10, which evaluates to true. It's kind of funny because at this point you probably have a pretty good understanding of string comparison, more than the average developer on strings, but we haven't even talked about some of the most basic structures in Java development and development in general. So what you need to do is you need to stick with this course because we're going to go into all of that. I just want to be sure that you guys have enough depth to be a really good Java developer. So thanks guys, please be sure to subscribe if you've enjoyed this series so far, and check out the description for links to the crash course, the notes, and our very generous sponsor. I'll catch you guys in the next video. Welcome back everyone. In this video we are going to be talking about control flow statements. So most of this junk we had from the last video we're just going to get rid of. But we are going to keep this much. So if you don't have this, you might want to write it out, but basically we're just getting input from the user to guess a password, and then we're comparing to see if that password is correct. So by the end of this video, you should have a pretty good understanding of if statements and branching in our program. By now you probably have a pretty good understanding how this output works. We basically pass an argument in here, and it's going to print out to the console. And because this is evaluated to true or false, we've been getting these outputs false, true, and so forth. But usually we're not just going to want to print true or false, we're actually going to want to branch our program depending on what the value of some expression is. So by calling this method on this string, we either get true or false. Now the way we can branch in our application is using the if statement. So the structure for this is if, and then parentheses, and then curly braces. Now inside of these parentheses, you're going to have an expression. And we're going to type out the expression here right now. It's just going to give us an error. Inside of the curly braces is our code to execute, if true. So if this expression evaluates to true, we're going to execute the code inside of here. So instead of printing this here, we could actually take that and we could put that in this if statement, and it will evaluate to true or false. And then for the code to execute, well, we could just output something for now. Say your guess was correct. Awesome. So let's run this. Guess the password, let me in, which is stored right here in this password variable. And we get the value true. And because it's true, this if statement is executed and we get this output that says your guess was correct. If we try it again and we put in the wrong password, it's always so hard to come up with stuff. I was trying to say apple crisp, but yeah, definitely didn't mean to put crisp there. You can see that this statement prints false, and this expression here is evaluated to false, so we just jump right over the if statement, and the execution begins here, and obviously there's nothing left, so the program just ends. If we were to put something after the if statement, it's always going to run. So when we run this, let's say we say, it still executes that, and if we do put the correct password, it still executes that. So basically after the if statement, the code just continues on line by line. Now there is a way, if you wanted to stop the execution of the program if this is true, you can do that using the return keyword. So you could just put return and then a semicolon, and now this is not always going to run. Because if this evaluates to true, it's going to print your guess was correct, and then the program's going to end. The return keyword is just a keyword to end whatever method you're currently in. So it's going to basically say, yo dog, we're done with this main method. We can be done executing code. So let's try running this thing. Let me in. It says your guess was correct, and then it does not print this. That's one way to end the program. There is another way you could do this, and that's with the else clause. So if you go down here and say else, and then put more curly braces, this is going to evaluate if it's false. So I could take this code here, place that inside of the else statement, and we could say this is false, for example. So now one or the other is going to execute, but never both. So if we get the password wrong, it says this is false. If we get it right, it says your guess was correct. So that's the else clause. There's one more thing you need to know about, and that's the else if. So for example, in this scenario, we're checking to see if the password is let me in. But what if we wanted to check if it was let me in or don't stop believing, which is the second password? So you can only get into this secret application if you got one of those two passwords. So I could go down here and create another password, like password 2, for example, but I'm actually going to show you a different way you could do this without the variable. So in order to make an else if, we're just going to move that else down here, and we're going to say else if, another set of parentheses, and another set of curly braces. So it's going to look like this. And I tend to put the else on the same line as the closing. It's totally up to you what you want to do. All right, so inside of here, we're going to put another expression that could be evaluated to true. So this first expression is seeing if our guess is equal to the password. Well, now we want to check against a different password. So let's say that different password is don't stop believing. And then you can just put the dot right on that string. Equals, and then we can put the variable guess, which is going to be stored from the scanner.nextLine. So that is another way you could use this equals. You can just put it directly on a string literal. So in this scenario, we can do a different output and say you got the second password, for example. All right, now let's run it. So if we say let me in, it's going to execute the first one. Your guess was correct. If we say don't stop believing, you got the second password. And then lastly, if we get the password wrong, it says this is false. One thing you might want to do is compare with lowercase words. So if you wanted to do that, you can go in and append another method here and say .to lowercase, and that's going to return a string, which we can then call the equals method on. So this is a concept known as method chaining. So basically we're taking this first method, and that's going to execute and return a new string that's going to be all lowercase, and then it's going to compare against guess, which we could also put to lowercase. So it's a little bit more complicated, but if you really want to make sure people aren't messing up just with their casing, then you can go through this process. So .to lowercase, dot equals, and then we're passing in guess to lowercase. Awesome, so that is all of our code. Now, if we go in here and we say, let me in, it says your guess was correct. This other one says false because it's not doing that to lower, so you can see how the comparisons are different. So I'm just going to get rid of that so it doesn't confuse us. In Java and basically every other programming language, strings with different character casing are not the same thing. So let me in with these capital letters is fundamentally different than let me in with all lowercase letters, like right here. All right, so my dog's coming upstairs, so I'm going to get going before she makes a bunch of noise. So thank you guys for watching. Please be sure to subscribe if you've enjoyed this video, and check out the links in the description for a link to the Java Crash Course, the blogs, as well as our generous sponsor. Thanks guys, and in the next video we're going to be talking about some more cool stuff. Ain't that right, Kava? So yeah. No? Oh, okay. Hey everyone, welcome back. This video we're going to be talking about logical and comparison operators. Alright, so back to what we were talking about. This video we are going to be talking about comparisons just like the previous video, but now we're going to make them a little bit more complicated. So what we're going to do is we're going to ask someone how old they are and what their favorite type of animal is, but they're only going to have two options, cats or dogs. And I just decided to go with a clean slate just so you could follow along and it'd be nice and clean. So first thing is we need to do an output so they know what we're asking for. And then we're going to later ask them another question, so I'll just put that out here while we're here. Cats or dogs? All right, now after we ask how old they are, we need to get system input. So we're going to create a scanner, pass in system.in, and then all we have to do is say scanner next line. And we can store this in a variable, and it's going to be of type int now rather than string because we're getting a number, so like that. Now we're going to get a little issue here, and the issue is that we cannot convert from string to int. And the reason is because this scanner.nextLine method is going to return a string, but we're trying to store that as an integer. So this is where one of those methods we learned earlier comes in. If you remember, I think it was called integer.parseInt. And then we can just pass in a string into these parentheses. And because this next line method is going to return a string, we can just use that inside of this method. All right, now we're going to ask them if they like cats or dogs. So we're going to say string animal and set that equal to scanner.nextLine. Now I want to go through some of the different conditionals we could make with these variables. So we could first restrict the app by age. So we could do something like if age is greater than 12. So hey, you have to be at least 13 to access this app. Well, then we could say sysout welcome. All right, so you can see we have this new operator and it's greater than. This is an example of a comparison operator. This is a comparison operator that will see if two things are equal to one another, and it's known as the equality operator. This is the greater than operator, and there's a bunch of other ones, so we're just gonna write them out for you right here. First, we have the equal, which is the equality operator. Then we have not equal to, which is the opposite of equality operator. I forget what it's called. Inequality, that's what it is, yeah. So this is the inequality operator. Yeah, I think it's inequality, but you'll probably just hear not equal to. And you'll probably hear here equal to. Next we have less than, greater than, less than or equal to. This one's interesting because you might be used to seeing like a line underneath the less than, but in programming you have to put the equal sign after it. And then greater than or equal to. So these are the comparison operators, and basically they're always going to return true or false. So for example, age greater than 12 is only going to return true if age is 13 or higher. So to see this, let's run the application. How old are you? Dog, I'm 15, man. I like cats. I actually prefer dogs, but whatever. You can see we get access to the app. The next thing you need to know are the logical operators. Logical operators allow us to compare multiple things at once. So for example, let's say we wanted to say age is greater than 12 and your favorite animal was a dog. Here you could put two and signs, which are capital 7s, and say animal dot equals and pass in dogs. All right, so now let's run this thing. If we say we're 15, but we say cats, we don't get access. But if we say we're 15 and we say dogs, we get access. So now they both have to evaluate to true. This has to be true, and this has to be true. The other logical operator you should know about is the OR operator, which is two of these pipes, which is right above the enter key. Now, either of these have to be true, but not both of them. They can both be true if you want, but it doesn't have to be. So now I could say, hey, I'm 11, but I like dogs a lot, so I get access. So let's write out the logical operators. We have and, which means they both have to be true. Then we have or, which means either can be true or both. And then there's one more you need to know about, and that is the not operator, which is just an exclamation mark, which basically will just inverse, I don't know, the Boolean. So if it's true, it's going to be false. If it's false, it's going to be true. So if I wanted to say, hey, you can like any animals except dogs, what we could do is we could say, hey, you have to be over 12 and you can't like dogs. So now, if I say I'm 15 and I like cats, I get access. If I say I'm 15 and I like platypuses, I get access. If I'm 12 and I like T-Rexes, well, now I don't get access because this one didn't evaluate to true, because it has to be over 12. That covers the basics of the comparison and logical operators. There is another thing you should know, and that is if you put these ands and ors inside of an expression together, it can be a little bit confusing how it's going to evaluate. So whenever you do that, you're going to want to use parentheses to specify which ones you want to evaluate first. So you can just go into an expression, put parentheses around anything, and that'll force that one to evaluate first. In this situation, it's not going to do anything different, but you definitely should know about that. And my recommendation, honestly, is to never mix and signs with or signs in the same expression. So you can research that more if you want. Just look up logical operator precedence and maybe throw in the word ambiguity in there because it's not super clear what's going to happen. But when it comes to precedence, this has higher precedence. And we're going to talk about operator precedence later, but for now, just know that you shouldn't mix these in the same expression as a general rule of thumb. All right, thanks guys, that's all I got for you. If you've enjoyed this content so far, please consider subscribing to my channel as that really helps me out. Also check the description for a link to our Java crash course, our notes, and a link to our incredible sponsor. So thank you guys, I'll see you in the next one. After doing like 20 videos, it's kind of hard to figure out how to start each one. Like, I just feel like I want to be creative, you know, and like make each video very interactive and fun, but it's really hard to do that when you're doing a 100-part series. So we've been working with the if statement and some of the basic data types, but you know, I really thought I'd switch things up and learn a little bit something new here. It's funny because it's a joke. Get it? Because we're going to be talking about the switch statement. So what we're going to do is we're going to ask the user for their name, and then we're going to make different cases depending on what their name is on what's going to happen. So the functionality is similar in nature to the if statement, and now we're able to branch our application based on different values of this variable or this input. There are some differences between an if statement and a switch, and we're going to talk about that in this video. First thing, we need to get user input. We are going to store their input in a variable called name and call scanner.nextLine. Now the structure of the switch statement, you first put the keyword switch, and then in parentheses you put the variable we're testing against. So we want to see what the person's name is. And then you put these curly braces, just like an if statement in structure, but functionality is a little bit different. So one difference here is you just put the variable name. You don't put equals equals or greater than or less than, just the variable name. And then inside of here, you're going to have different cases. I feel like this needs to be indented, but for some reason, Eclipse does not indent them. It drives me crazy. Maybe it's because I have my curly brace down here. Let me try it. So I'm just gonna go in here, type in case. Oh, nope, it still does it. Dang it, it's so dumb. Anyways, after the case, you put the value you are looking for. So I could say Caleb here. And then you put a colon, not a semicolon. So just the 2 dots. And then on the next line, you're going to put break. Now in between these two is where your code goes. Okay, so it's a little bit of a different syntax, you might not be used to it, and you have this weird break keyword. We're gonna talk through all of that, but basically, you're just saying, yo man, if the name is Caleb, then do this code, and then break out of the switch statement. That's what the break keyword does. So we can also have additional cases in here. So for example, I could say case equals Claire, and then here we could have more code, and then we're going to say break. The break after each statement is important, and we'll see why soon. Alright, so if the person's name's Caleb, we're going to give them access to the app, right? Because anyone named Caleb is obviously a good guy, right? Claire, on the other hand, well, you can go away. We all know Claire is the source of all evil, so we're just going to say go away. If by chance your name is Claire, please don't take it to heart. Alright, let's run this. What's your name? Well, of course, my name's Claire. It tells me to go away. What's your name? Caleb? Welcome, my man. So you could probably figure out how to do something very similar to this with an if statement, and that would be totally fine. Generally, switches are good if there is a discrete number of values that we can choose from. Did I just use a big word? So if statements are really good if you have ranges. So if you want to say, hey, your age is greater than 12, or you want to say it's less than 50, for example. That same kind of thing does not happen with the switch statement. The only thing we're going to do with a switch statement is get exact values. So that means the switch statement is not as broad in its usage, but it's also more specifically used for individual cases, so it might be a little bit clearer once you get used to the syntax, what's going on. If you're going to write this as an if statement, you'll probably have a lot more syntax, some more operators, a lot more stuff to deal with. It's not as clean, it's not as clear. Lastly, there's going to be a default case, which is optional. So we could say default, try again later, for example, and we're still going to put that break keyword here. All right, let's run this. What's your name? Billy. Try again later. So the default acts as a catch-all, in that anybody who's not named Caleb or Claire is going to go to the default case. Now, what do these break keywords do? Well, it prevents something called fall through. Honestly, the way this works is kind of stupid, but if we leave out this break, what's going to happen is if we put the name Caleb, it's going to execute this, and then it's going to continue executing all the other case statements until it hits a break. I don't think there's ever a good use for this, so you should always leave that break in there. So just to show you guys, if I put in Caleb, it says welcome my man and then go away. Definitely not what we're looking for. Why it does that, I'm not entirely sure. I think it has to do with some kind of structure in assembly language that they were mimicking in C, and then it just kind of caught on that, hey, you have to have this break statement in here to prevent this fall through. but it's not really a functionality that we would see ourselves using on a regular basis. In general, I would say it is a bad idea and you should always have this break keyword here. In other programming languages such as C#, it requires this break keyword here or something similar such as goto. So I like that because it prevents the mistake of fall through. But Java is not the case, and we have to remember to put this break statement here. In the last one, the default case, why in the world do we put this break here? Well, mainly it's just a convention thing. For one, if other languages require break, then we're already going to have the habit of putting this break in this default. Another reason is, hey, we might decide that the majority of cases are going to hit this default, so we might just save ourselves some effort and put these up at the top. Well, if we forgot to put this break statement in, what's going to happen is, if we put something wrong in there, it's going to fall through. So just for safety, if we ever wanted to rearrange the order of our cases, I always put that default with a break. So I'm going to take that and put that back at the bottom. Now there is one other thing I wanted to show you guys, and that is having one thing execute for multiple different cases. So let's say we wanted to get rid of everybody named Caleb and we wanted to get rid of everybody named Claire. What we would do is we would just get rid of all the content inside of the case for Caleb and just have them one after the other like this. So now this is going to execute for both of them. So when we run it, Caleb, it says go away. If we put in Claire, it says go away. That's pretty useful if you want to do the same thing for numerous cases. That's how you do that. This is the only scenario where I can think of where you're not going to be putting a break for the Caleb. You're just going to combine the cases together, and this is going to execute for either one of them. That's all I have for the switch statement. I do give you the challenge, if you want to get some more development practice, try converting this switch to an if statement and post your solution in the comment section below. If you've enjoyed the content so far, please consider subscribing to the channel. This is tremendously helpful for me. Also check out the description for the link for the Java crash course, the notes, and a link to our sponsor. So thank you guys, I'll see you in the next video. And in case you're wondering what we're talking about, we're probably going to be talking about the ternary operator, or the conditional operator if you've heard it as that. Or we might just go into that video and I'll decide something else to talk about. So we'll see. Catch you guys later. Hey, what's up everyone? This video, my dog is going crazy right now. I gotta show you guys. All right, say hello to my doggy. Are you having a good time? It's a good time. Say hello. Alright, get out of here. Get out of here. So yeah, that's what I'm dealing with today. This video, we're going to be talking about the ternary operator, or the conditional operator as it's also known. So we've talked about operators throughout this course. For example, we talked about the plus operator, which will allow you to add two numbers. This is an example of a binary operator because it works on two pieces of data. The not operator that we talked about in the previous video, this is a unary operator because it only works on one thing. So if you did something like this, it would be false because it flips whatever the value is. If it's true, it's false. If it's false, it becomes true. Well, there's a third category of operators, ternary operators, and there's actually only one, and this operator works on three operands. So the way this operator works is you make some condition. So let's say we have someone's name. You could get this from user input if you want. The first thing is a condition, so similar to the expression inside of an if statement. So whatever you would put inside of these parentheses, you're going to put that first just by itself. The way the ternary operator works is it's going to take an expression similar to how inside of an if statement we can have an expression here. But instead of using this if keyword, we're just going to have the expression by itself. So for example, we could say name dot equals and say, hey, if this name is equal to Claire, well, then we need to do something. And you can think of this as a question. So is the name equal to Claire? Question mark. And that question mark is actually important. That's the next syntax that's needed. And then what you do is you can have an expression that happens if it's true and an expression that happens if it's false. And the operator will return one depending on how this evaluates. So we ultimately need to store it back into something. So let's say we have a Boolean and it's going to be called welcome. Then we set it equal to this ternary operator. All right, so name equals Claire. Yes, it does. And then you're going to put a colon, not a semicolon. Then you're going to put what's returned if it's false, which in this case we could just put false and end it with a semicolon. Okay, so it's a little confusing on the syntax. I think you get used to it over time. It's taken me some time. The whole thought of thinking of this as a question has helped me. And then immediately after that is the expression if it's true, and then a colon, and then the expression if it's false. We don't just have to use true and false here. For example, we could assign to an integer, and we could return, if your name is Claire, you get 5 points. But if it's not Claire, you get 10 points. And, we could name this whatever we want. So if you don't like the conditional operator structure, you could break this out into an if statement. Let's go back to the original case where we had true and false. If you wanted to convert this to an if statement, I'll show you how to do that. Just comment it out real quick. You would say if name.equals Claire, have the open curly braces. Outside, we could have a variable that would be a Boolean welcome. And we just declare it, we don't initialize it. And then all we would have to say is welcome equals true. And then the else statement would be welcome equals false. And I really need to get consistent with my curly braces. Let's go with that. All right, so this would be the same exact thing. And the reason we define this variable here rather than doing it here is because if we defined it inside of here, it's not going to be accessible outside of this if statement. So if we wanted to access welcome here, you're going to see welcome cannot be resolved, meaning the compiler doesn't know where this welcome is coming from. So if we define it outside of the if and then just give it the value on the inside, well then down here we should be able to see what welcome is. And you can see we're not getting that resolve error. So that is the ternary, also known as the conditional operator. It takes 3 operands, an expression, the result if true, and the result if false. It's definitely not required because you can see you can do the same thing with an if statement, but it is good to know. But if you did enjoy the content, consider subscribing as well as checking out the description for a link to the Java crash course, a link to the blogs, and a link to the sponsor. Thanks guys, I'll see you in the next video where we're going to be talking about, you'll just have to come see. I really don't know, that's why I said that. Heyo everyone, this video should just be a real quick video because I just wanted to talk about one more variation with the if statement before we move on to something new. Alright, so in the previous video we talked about the ternary operator and how it could be easily converted to an if statement. There's one other variation of an if statement that you might see, and that is a single line if statement. One thing though is that we're not going to be able to have an else statement. But instead of setting welcome equal to true or false here, what we could do is we could assume the person is not welcome and then only make it true if they are welcome, which in this situation their name must be Claire, which why would Claire be welcome? That doesn't even make sense. Yeah, I guess we'll make an exception. Claire, you're going to be welcome for this one video, but after that, you're no longer welcome here. Alright, so this is pretty cool, if the person's name is Claire, which it is, which you could eventually get this name from user input, which we've done in earlier videos. If this person's name is Claire, we can check if it's equal to the value Claire, and just to be safe, we could even put it to lowercase, like so, and then put another dot. So this is method chaining. We're going to get this method, which will return a string, and then we're going to call dot equals on the result of this method. All right, so this is going to work. It's just going to set welcome to true if the person's name is Claire. At the end, we're just going to sys out welcome just to see what the result is. So we run this, we get the value true. If we change the value of Claire up here, maybe we could say Claire with a capital C, it should still be true. And if we mess it up and put a couple too many E's, well, we're going to get false. One variation though is you might actually see this without these curly braces, so you might see something like this. And this is actually a legal thing, and it's going to work the same way. So when we run this, we should get false, and if I change this to Claire, we should get true. There we go. The one thing you need to know here though is that you can only have one statement. So if I wanted to say, we're going to welcome Claire because we're really nice today. We run this, and you can see it says welcome Claire, and it evaluated to true. But if I change the name to something else, and we run this, you can see it still says welcome Claire. That's because when we don't put the curly braces, only the first statement is part of that if statement. So even though this is indented, it's not part of that if statement, which is a very common flaw. It will come back and bite you in the butt. It'll reap your soul. Sorry, I just got Diablo Reaper of Souls, so it's on my mind, you know. So technically this should not be indented if you're going to follow convention. That's a little bit more clear, but it's still not entirely clear. So my rule of thumb is whenever I'm going to have a one-line if statement, I'm going to put the statement on the same line as the condition. And this is a pretty well-established convention just for safety, because now if I wanted to also output something, well, this just doesn't seem right, you know, because once I see that this one's on this line, it's going to indicate in my brain that this is a single line if statement, and I'm not likely to make that mistake. So that is the single line if statement, nothing too crazy, just wanted to keep it real simple for you guys. If these videos have been helpful, please consider subscribing to, support my channel and whatnot. Before you go, please check the links in the description for the Java crash course, the notes, and the link to the sponsor. And with that, I'll see you in the next video. Welcome everyone. This video we are going to start our discussion on loops. Loops are very cool because they allow us to do something in code over and over and over and over again automatically. In order to repeat something in code, we need 3 pieces. And I remember these using the acronym ICU. So let's just make some comments here. The first thing we're going to need is an initialization of some variable. And we're going to use this variable to keep track of where we are in this loop. The next thing we're going to need is a comparison. And then lastly, we need an update. So to translate this into English, we're basically going to start some variable, often known as an iterator, at some number. So let's say we start at 0. And then we're going to say, hey, while this number is less than 10, for example, that's a comparison. While it's less than 10, we're going to do something, and then we're going to increase the value by 1, which would be updating the value. All right, so that probably still wasn't English if you're new to this. So let's just go through an example. The loop we're going to talk about today is the while loop. And it looks like this. Inside of these curly braces, we are going to put some expression, similar to an expression we would put in an if statement. This is where the comparison piece comes in. But you can see that's the second thing on this list. So the first thing we need is an initialization. So we might up here say int I equals 0. By convention, the iterator is often called I. You can name it pickles or tomatoes or salsa or cheese. You can name it whatever you want as long as it's some form of food. All right, now let's put a comparison in here. So we could say I less than 10. So while I is less than 10, we are going to do something. So here's where our code goes. At the end of our loop, we're going to update the value of I, which is this third piece right here. So we could say I++. That's going to increase the value of I by 1. So that is the structure of our loop. If we run it, you can see that it does absolutely nothing. It's because we're not actually executing any code. So we need to put in some code in here to do something fancy with this loop. So for example, we could say hello, and we could say that 10 times. Cool. Each time we go through the loop is called an iteration. So each iteration, we are printing the word hello and then incrementing the value. This I variable that we're using for all 3 of these pieces can be used within this while loop. So to see how the variable I changes, we could print out the value of I. So let's just print I there. Run this, and you can see it counts from 0 all the way down to 9. It's a total of 10 numbers. You can use this I for all kinds of creative things. For example, we can keep track of what iteration we're on. So to do that, we can start I at 1 and go up until I is less than 11. And then in here, we could say iteration plus I. We run this, and we get a list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is the foundation of the loops. We have the initialization, which we give a value to this variable. We then compare this variable to some number to see if this evaluates to true. More generally, this could be condition. It doesn't always have to be I is less than something or I is greater than something or I is equal to something. We don't always have to compare. We just have to put some kind of expression in here that is only going to evaluate to true on occasion. So condition would probably be a better word there. Most of the time though, it's going to be a comparison. Then we put our code, then we update our iterator, which is a name you might hear for this variable here that goes through these pieces. Now let's go through an example of how we could use a while loop to make something cool. Let's try to get someone to guess a password to get into an application. So what we're going to do is we're going to have a string, and this is what they need to guess to get access. Now we need to get some input. Make sure we include scanner, which is in java.util. So that will put a new import statement up here. Then what we need to do is create a new variable to store the value that they type in. So we'll call that guess, and we'll just do scanner.nextLine. All right, you guys have probably seen that 1,000 times if you've gone through the series. Now what I want to do is I want to keep asking them for a password as long as the password is incorrect. So let's say they go in there, they type in chicken nuggets, it's false, and then it says, oh, nope, not right, guess again. So what we're first going to do is we're going to print guess the password. And then in this while loop, we could basically say, hey, while the guess is incorrect, and in order to do that, we're first going to check if they're equal and then invert it using the logical not operator. So we say guess.equals and pass in password and then put an exclamation mark at the beginning to negate it. So basically we're saying while they are not equal, then what are we going to do when they're not equal? We're going to ask them again. So we're going to print this out again, and then we're going to get another scan, but this time we're just going to use guess. We're not going to put the data type there. So guess equals scanner.nextLine. Then after they get it right, we could say congrats. All right, let's give this a try. Guess the password, tacos, chicken nuggets, pencils. What could the password be? I don't know what the password is. Goodness, let me in already. All right, there we go. So that's fun. One of the downsides of this loop we have here is we kind of have some repeating code. Like we have this thing twice. And basically anytime we have something repeated twice or more, that's a bad sign, and there's usually a better way of doing things. I also just noticed I got this warning here, which I've never actually addressed here. So when you open a scanner, when you're done using it, you'll want to do scanner.close, and that will free the memory for that scanner. Worst case scenario, we just make some huge memory leak and our program never works, so not a big deal. So that is your introduction to loops. Once again, we got the initialization, the condition, and the update. Check out the next video because I'm going to be talking about how we can get rid of this redundancy with this line being in here twice, as well as how we get this guess twice here. So hopefully that video will be awesome. It's called the do while loop. Definitely something you need to check out, but you also need to check out the links in the description for the Java crash course, the notes, and the link to the sponsor. If you've enjoyed this content, please subscribe and consider checking out the next video. Yo, what's up my boys and girls? Today we're going to be talking about the do while loop. Now this is very similar to the while loop. The only thing is it's more what's the word? Compulsive. It's kind of like me when I go to the store. I'll go in there, I'll buy something, and then try to figure out if it was a good idea after the fact. All right, so the do while loop is going to do something, and then it'll have the condition on whether or not it should continue to do it. You know, so it goes in there, buys a $350 pair of headphones. I tried doing that this week, and my wife was like, nope. And then it's like, you know, let me do my budget. Oh, I should probably stop. Such a terrible explanation, but I'm going to go with it. You can see in the code we have from the previous video, we have a lot of repeating stuff. We have this guess the password twice. We scan the next line twice, here and here. Like, why do we have all this extra code? Shouldn't we be able to condense this a little bit differently? Well, here's what I'm going to do. I'm going to make a do while loop, and it's just going to ask the person for the password at least once. And then if the person's right, it'll keep doing it. So the difference between a do while loop and a while loop is that the do while loop always executes at least once. A while loop doesn't have to. For example, if I run this code here and I get the password correct, let me in, it just jumps over the while loop altogether. So here's what we're going to do. We're going to change this to a do while loop. And here's the structure. We're going to have do, and then we're going to have curly braces. And then after the curly braces, we're going to have while. I'm going to structure it like this, and the condition goes here. So it's the same thing. We still have the initialization, the condition, and the update, just the structure is a little bit different. So we're going to cut this line here and put that in the do while loop because we're going to execute that at least once because we always want to ask the person for a password. We'll define the password up before the loop just so it's always there for us. Oh, and another thing, after the while loop, you're going to want a semicolon. It's really easy to forget because when you do a normal while loop, you don't put a semicolon here. But when you do a do while loop, you need to put them at the end here. We're also going to take the scanner. We're going to move that to the top. Oh, Kava. Gosh, you scared me. I don't know if you guys heard that, but my dog's freaking out now. We're going to move that to the top as well. All right, and then we're going to move this guess to inside of the do because, we're going to get a guess at least one time, but we're going to define it outside of the while loop. So we're going to say string guess, and then we'll just assign a value to it inside of the do while loop. And the reason we're going to do that is so we can use it inside of the while here. Because if we define the variable inside of these curly braces, it's only going to exist inside of these curly braces. Definitely not what we want. Now this expression is going to stay the same, so I'm just going to cut that, paste that right here. And now these two lines, we no longer need those, so we can just get rid of this while loop altogether. All right, now let's run it, make sure it works. Guess the password. Let's get it wrong. It keeps asking us. Can't spell. And then once we finally get it right, it works. If we defined guess in here like this, well then inside of this while section, it's going to say that this is undefined. It's not able to resolve this identifier, meaning it doesn't exist. So you definitely need to define anything that you're going to use inside of the while piece outside of the do section. And then you don't redefine it in here, you just leave it as guess. Because when you say this, well, that's not going to work because we already have a guess in scope here, so it's saying, dude, you have a duplicate variable, we're not going to let you run this thing. Some other programming languages would let you do this, it would just mask this variable, but it's not going to do that in Java. You can't create a variable and mask a variable that already exists. So no redefining variables, guys. Keep it like that. So to go through this from beginning to end, we first set up the basics, what we're going to be using throughout this loop, which is the definition of what the password actually is. We create a scanner object, then we declare a guess variable, which we're going to assign to later. Inside of the do section, we ask the person for what we want, we get that value, and while that value is not equal to the password, we keep doing the do section. And then once you're done, it'll go down here and start printing this stuff down here. And then it'll close the scanner. Hopefully that's crystal clear for you guys. Make sure your shopping does not look like this. Because if you do this, what's going to happen is you're going to buy too much and your budget's not going to be okay. Alright, that's all I got for you guys. Hopefully this video was helpful. Please consider subscribing and check out the links in the description for some cool things and stuff. So check it out. Alright, peace out. Welcome back to your Java programming series. Wow, you guys have been on me about finishing this series. I could literally post on social media, guys, I have 3 days to live, and I swear you guys would say, that's nice and all, but are you going to be finishing your Java series? Well, here you guys have it, the rest of the Java series. I'll be uploading it this week. So it has been some time since the previous Java video, and we're kind of getting into a new section. So what I'm going to do is I'm just going to finish our discussion on loops real quick, and then we'll be shifting our focus into a new part of Java. So what we're going to do is we're just going to start from scratch, create a Java project. If you already have the one from the previous videos, that's fine. Don't worry about it. I'm just going to create a new one. I think the previous one I called it like hello or something, but this one I'm going to call it YouTube, like that. And then I'm just going to click finish. This module thing, when it pops up, I just click don't create. Now over here in the package explorer, really tiny, go and right click on source and new class. Awesome, so here is where you're going to name your file that has the main method in it. I'm just gonna call it my sweet program. And then I'm going to click public static void main, so it's gonna put that main method in there, and then I'm going to click finish. Sweet, now I can zoom in a little bit and get rid of some of this other junk, and we should be pretty good to go. So in the previous videos, we've talked about while loops and do while loops. These are the basic loops used to basically do something numerous times. Another popular loop that you need to know about is called the for loop. And I know what you're probably thinking, what's it for? Well, that's what I'm gonna be showing you guys. Well, it does exactly the same thing as the while loop. It's just syntactically different. So it's kind of like just a different way of writing the same thing. So let's do that. We're just going to clear this out, and we're going to write our first for loop. So the syntax is for, and then you put the parentheses, and then you put the curly braces. And I'm also going to move this first curly brace to the same line. That's the convention I'm going to be trying to follow in for the rest of this series. So we got the shell for the for loop. Obviously there's a bunch of red lines, so it's not happy. That's because we have to fill it out with some more information. So inside of here, we're going to put the 3 pieces of a loop. So that's the initialization, the condition, and the update. So the 3 pieces of the loop are nice and visible right here, one after the other, and they're separated by semicolons. So we start with the initialization. We can say int I, set it equal to 0. Then we can do a comparison, I is less than 10. And then lastly, we can do an update, I++. So this is a very basic loop that's going to run 10 times. So it's going to start with I being 0, and it's going to go all the way up until I is 9. Once I is 10, this no longer evaluates to true, and the code block is not going to execute. So let's just give it a try. What we're going to do is just output the value. So we can say sysout, hold control, and press space. You guys have been asking a couple times how I do that. That's how I do it. And then we can just print the value of I. Executing this thing, check it out, guys. You can see all the numbers down here, 0 through 9. That's 10 iterations. So that's a basic for loop, but you can of course modify it. You can do a different condition in here. I always like to keep it less than. I think that's easier to read for me, but you can certainly do other stuff. So for example, you can use less than or equal to if you wanted. That would include 10. So saving this and running it, you can see down here we get the value 10. But I'm going to keep it to less than, and that's just my convention. If I wanted to have 10 in there, I would just say less than 11, but however you guys want to do it. So I'll go back to 10 here, and we'll also show you guys a loop where you can count down. So we'll set I to 9, say as long as I is greater than or equal to 0, we're going to subtract I. Running this, we get 9 all the way down to 0. So that's how you can count down. You can do more complex stuff inside of the for loop, but this is the basics, and this is what you should be familiar with. Now, I is just a convention here. You can go ahead and name that variable whatever you want, but most people call it I. So that's the for loop. Now what we're going to do is we're going to be talking about nested stuff, so it's going to be pretty cool. Be sure to check out that video, and if you are excited that I've released this video, just do me a favor, hit that subscribe button, and maybe go share this video with one of your friends, because as you guys are probably realizing, the more you learn about programming, the more empowered you become in your career as well as in your person, because you learn all these new skills. And that's something we can't hold back from sharing with the rest of the world. So go share this video. Thank you guys, and I'll see you in the next one. Peace out. Welcome back to your Java programming tutorial 27, baby. This one, we're going to be talking about how to nest things inside of code blocks. So this is going to be useful if you need an if statement inside of an if statement, or a loop inside of a loop, or an if statement inside of a loop, or whatever kind of nesting you want. There's all kinds of creativity allowed here. So what we're going to do is we're going to first show you an if statement inside of this for loop. This is kind of like the foundation for some of the more advanced stuff we're going to get into, such as traversing through 2D arrays and so forth. So make sure you pay attention, don't be a noob, keep your eyes focused, and just listen to what I have to say here. So what we're going to do is we're going to say if, and we can compare this I to some value to see if it's like a certain one if we're looking for something. So we can say if I is equal to 5. And we can do something special if that's the case. Oh, also that shortcut I just did, sysout. I'm on a Mac. I don't know if it's any different on Windows. I mean, it's something similar. We can just look it up if you want. So just control and space on the Mac. So I is available to us because we're still within these curly braces here. If we tried to access I outside of these curly braces, that's not going to work. So I is scoped to these curly braces. All right, so let's say we find 5. We're just going to do something special. We're just going to say we found 5. Very special, I know. Run this, and look at that. Once we hit 5, it says we found 5. We can also nest if statements inside of if statements. So for example, we could say inside of here, we can go up here and put another if statement. And what we're going to do is we're going to put this print line inside of that if statement. Like so. And what condition are we going to look for? Let's say if additional logging is true.
So what is additional logging? It's just something I made up in my head like 2 seconds ago. But pretty much what we're going to do is we're going to set that to true up here. So we'll say additional logging, and we'll give it the value true. And what type is this going to be? It's going to be type bool for Boolean. Boolean. There we go. All right, so why am I doing this exactly? Well, I'll show you guys. See, when we run this, we get this additional information, and we could sprinkle that throughout our code, but then what we can do is we can go in here and we could set this to false, and then that's going to get rid of that additional logging, and it's going to change it throughout our entire program. Sweet. So those are some simple examples. That's all I got for this video. In the next video, what are we going to be doing? We're going to be talking about for statements. Within for statements, this is a cool way to iterate through things as well as create some cool pyramid shape printing things. Like some people are just interested in that. I'm not really sure why, but check it out. It's going to be cool. It'll be fun. You'll probably learn the most you've ever learned in your entire life. So go check that video out, and I'll see you then. Hey, what's going on, everybody? Welcome back. This video, we're going to be talking about nested for loops. So this is really important if you have some sort of 2D array or a similar data structure. Anytime you need to iterate through something that's a little bit more complex than just a straight line. The other completely practical purpose of nested for loops is to create cool pyramid or triangle shape structures. So yeah, that's actually a thing. I've gotten a lot of messages from people saying, "Oh, please, you gotta teach me how to do this. I can't figure it out." Why? I don't know, but if you go on the internet, you'll find lots of examples of this. So just to prove I'm not crazy, you can find tons of examples. This one's really nice and simple. It's just a triangle shape, but a lot of people want to do the pyramids. And here's another one. It's on the side, which is a lot easier. The ones with the spaces here, that's going to be a little bit more work because you got to worry about the spacing, but I'm sure you guys can hack something together after watching this video. All right, so let's get back into this. How are we going to create something like that? Well, first things first, let's just get rid of this output. That's just going to clear the state. And what we're going to do is run the application, prove that nothing's happening, and you can see, voila, nothing happened. So what I want to do is I want to do another loop similar to this one where we count down from 9 all the way down to 0. And that's going to happen 10 times, one time for each iteration of this outer for loop. So it's going to look something like this. We'll create that body here, and then inside of the parentheses, we're going to initialize a new variable. By convention, it's often called K or J. I like K. I don't know. Something about J's they just mess me up. I don't know. K is where it's at. Probably because my name's Caleb, you know, even though my name starts with a C, but the feeling of the K just is much better. So if you're looking for a convention on which one to use, I'm sure there's millions of debates online, but it really doesn't matter. We're just going to go with K, and we will set that equal to 9. And similar thing, we're going to say as long as K is greater than or equal to 0, and then we'll say K minus minus. And then each iteration of this, we're going to output the number. So we'll say sys out, but we're going to make one modification. We're not going to use print line because that's just going to spam a bunch of garbage in our console. We'll just use print and we'll pass in the value of K, but we're also going to pass in a space. Now when we run this bad boy, check this out. We get even more spam, but now it's all in one line. So we definitely improved our code. I'm just kidding here. We need to go down here and we need to add another line. We're just going to say sys out and leave this empty. Run this and look at that. So we're basically getting 10 iterations of 10 iterations. So each one of these is an iteration, and then for each iteration of the outer loop, we get a copy of that. So hopefully that kind of makes sense. This loop here, that's what's making this. Then the outer loop is doing each one of these. So hopefully that's nice and clear. Maybe just get some practice writing out some of these yourself. If you're not typing this out yourself, you should probably go do that. All right, so now if we want to do a triangle shape, we can definitely do that. So for example, if we wanted to count down as we go down, so instead of just having 9 every time, we wanted to be 9, 8, 7, 6, 5, 4, 3, 2, 1, we could do that as well. So in order to do that, we can set K equal to the value of I. And you can see I starts at 9, but then it shrinks down to 8 and so forth each iteration. So when we do this and we run this, we get this cool triangle shape. So the first iteration, we start at 9, next one we start at 8, and then we start at 7 and so forth. So anytime you have this staggered effect, the way people do that is they reference the outer variable inside of the inner loop. So that is how you do the most simple triangle structure. It's also going to get you some practice with working with nested for loops. So hopefully that was helpful for you guys, and be sure to check out the next video because it is going to be awesome. It's probably going to change your life forever, so please be sure to go check it out. And you know what? You better be subscribed to this channel and enable notifications, because if you haven't even done that, you're just being ungrateful. You know, I put my lifeblood into this. I'm just playing, guys. It's up to you. All right, I'll see you guys in the next video. Peace out. All right, looks like you guys are back for some more, so you're not tired of me quite yet. Unless this is your first video, and in that situation, welcome. We do Java tutorials, but we also do all kinds of tutorials on programming, so be sure to check out my channel and hit that sub button. But enough advertising for myself, because I have other people to advertise for. So we're gonna be talking about nested while loops in this video. So right now we're doing nested for loops. We're gonna do the same exact thing. We're gonna switch them to whiles just to get a little bit more practice and see what that might look like. I think you'll find that it doesn't look as nice, and it's definitely done less often. But again, while loops are nice for those situations when you don't necessarily know when a loop is going to end. Then it's more visually appealing. All right, so here's what we're gonna do. We're just gonna push these for loops down so we can reference them rather than just trying to change them, because that's just gonna be a mess. I just know it. So we start with while, and I just like to make the bodies first. So we're definitely going to need this structure here. We have a while loop, and then inside of that while loop, we have another while loop. And we're going to have the same stuff, it's just structurally different. So up here, we're going to establish the value of I, so that's the initialization. Then the condition goes inside of these parentheses, so as long as I is greater than or equal to 0. And then the update, in this case, the decrement operator, that always happens at the very end if you want to match the for loop exactly. So we'll say I minus minus. And you'll see an issue down here now. We get this red line. That's because we already created I up here, and it's still in scope when we reach this for loop. So it's saying, yo man, you can't redeclare this I variable. You're gonna be breaking something. So if you needed both of these and you wanted to reuse that I, you would need to get rid of this int here, and it's just going to reassign the value 9 to I, and it should work just fine. But that's a story for another day. Let's just get back to what we're doing. Inside of here, we're going to create that k variable. So we'll say int k and assign it the value of I. Then we'll say k is greater than or equal to 0. Oh, that's not what I want to do. Ooh. Okay, paste that in, yeah, there. All right, cool. And then at the bottom of this while loop, we're going to say k minus minus. Now the actual code for stuff we want to do, so this here, that is going to go right here. So the code goes in the while, but before that final update. This one here, that is in the outer for loop, so that is going to go right here. All right, let's see if it works. I'll just comment this other junk out by using this multi-line comment. There we go, and let's run it. We get 0, so that is your guide. Thank you guys for watching. I'll see you in the next. All right, what in the world's going on here? Oh, duh. This needs to be 9, not 0. I don't know why I'm so dumb, but it happens, you know. The great thing about software development is it helps you realize how often you're not paying attention to the details. So this is definitely a good practice on focus, which we could all use. Oh, a butterfly. All right, let's run this, see if it works. And there we go. That's the output we were looking for. All right, so sorry about that little bug there, but you know, bugs happen and it's authentic to leave them in at sometimes, as long as it's not a disaster. You guys probably think I'm like all polished, but really I record these videos like 10 times because I can't get it right. All right, so that is the end of version 37 of nested while loops. Thank you guys for watching. Be sure to check out the next video where we're gonna be talking about variable scope in the context of nested control flow. So if you have no idea what that means, that's why you should probably check out that next video so you can be enlightened. Thanks, I'll see you then. Hey, what's going on, everybody? This video, we're going to be talking a little bit about variable scope in the context of nested control flow. So translating that into English, where can we create variables? How long do they exist? And when are we going to get variable conflicts? And so forth. So it should be pretty fun. Hopefully you've picked up on some of this throughout the series, but I just want to set it straight, make sure we're all on the same page. All right, so we had an issue in the previous videos where I created this I variable, and down here, if I uncomment this and want to do this stuff again, we have this error because it says I is a duplicate local variable. So what the crap does that mean? Well, essentially, the I we created up here is still in scope when we get down to line 15. And in Java, we cannot declare the variable more than once if it's still in scope. So we can't go in here, we can't create an I variable in here, we're going to get an error. See, duplicate local variable I. So when we get down to line 15, this one's still in scope, so it's going to be like, nah brah, you can't do that. So when does this variable go out of scope? Well, let's look at the curly braces it's defined in. So it opens here, the main, and it ends all the way down here. You can see that little box around it. So when you click one of the curly braces, look around, you'll see a little box. That is the closing brace, assuming all your code is right and it can compile and run. So that means we're not able to create another variable with the name I anywhere between these curly braces. Now, if we create a variable in a more nested scope, it'll eventually go out of scope and we can reuse that variable again. In this situation, we could only use the I inside of another method. So right now we're in main. If we created another method down here, so if we made it a custom method here, we could use an I variable inside of it because I would no longer be in scope. Hopefully that makes sense. Let's go through another simple example with a new variable. If we're inside of this while loop right here, and we just say int pizza, set it to the value 5, that's fine. And that's okay, but we can't go inside of this while loop and create a pizza because it's still in scope. But outside of these curly braces, we can. So look at this, we can say int pizza and give it the value 5, and we're not gonna get any errors there. That's totally okay. That's because this pizza went out of scope at line 14. That's just something to keep in mind when you're working with multiple loops inside of the same scope. So in this situation, we have these nested while loops, and then we have this for loop, the nested for loops down here. We ran into this little issue with this variable. So what I'm going to do is I'm going to get rid of these pizzas here, and we'll just take a look at this. When we create the variables inside of the for loop parentheses like this, they are scoped to these curly braces. So that is a nice way to keep our scopes clean. These variables are not defined in a wider scope than they need to be. And that's a general rule. You never need to create variables in a scope larger than where they're used. So that's the whole issue with the concept of global variables inside of computer science. Anytime we have a global variable, something we can change anywhere, that thing is in like the biggest scope possible and it's available to everyone. So it's very likely to cause naming conflicts. You're likely to either overwrite it or get a compiling error because you're trying to use that name. And it really depends on the language. Some languages, you're not going to get that compiling error. It's just going to replace it or mask it. But anyways, I'm rambling. The whole point of this thing is just be very clear about where your variables are defined and don't define them in a larger scope than necessary. So for example, if I went up here and said int I equals 9, and then for this first iteration, all I did was leave that blank, this code would still work, assuming this wasn't already used up here. And that would be fine, but then this I is going to persist down here. So I exist down here. That is only fine if you need to use the variable I at the end, and sometimes that's going to come up. Mainly just be really careful about where you're creating your variables and just pay attention. And I'm just going to put that back. There we go. And again, I'm going to comment this out because we have that naming error and we don't really need these for loops. All right, cool. So hopefully that was helpful, guys. Thank you guys for watching. Be sure to check out the next video. We're going to be talking about the break and continue keywords in the next video or two. So those will be really helpful if you want to build more complex applications. Thank you guys for watching, and I'll see you then. Oh, and don't forget to hit that subscribe button. Hey, what's going on, everybody? Welcome back. This video, we're going to be talking about the break statement. But before we get into anything, I just wanted to say a couple of things up front. If you're pretty new to programming, I would recommend you get a little bit of experience in some other programming languages. That way you just kind of broaden the skill set you have and you get a better picture of programming. So if you're looking for a programming language to learn and you don't want to have to learn a ton of new information, you might want to try C#. Why do I say this exactly? Well, because Java and C# are so similar, you can pretty much learn them together. So for example, take a look at this program. We have the static void main, we have 2 while loops, and we get this cool triangle output. Well, here's the same exact program inside of C#. Take a look. Almost everything is exactly the same. Yeah, the curly braces are in different spots. We don't have a public behind this static void main, but other than that, you're going to have a pretty much similar program, very easy to learn both at the same time. So I just wanted to throw that out there. If you're interested in learning C#, I do have series that go along with this series, but instead of Java, the code is in C#. So check that out on my channel if you're interested in that. Okay, so what are we talking about today? The break keyword. So what is the purpose of the break keyword? Well, it's actually going to break out of a loop when the keyword is hit. So right now we have these nested while loops, and then we also have the nested for loops down here. Personally, I prefer the nested for loops, so I'm actually going to go back to that just because it allows us to really focus on the break keyword rather than all that other junk floating around. So let's get rid of these comments, and now let's run the program just to make sure everything is good. And it seems to be working. Now, if there's a certain situation where maybe we're searching through something, or we need to break out of the loop, we literally just use the keyword break. So oftentimes that is going to be inside of an if statement, so when a certain condition is met. So I'll show you what I mean. Let's say we want to output the value of k, but once we hit a certain value, we want to break. So we'll say if, and let's just say if k is equal to, let's go with like 6. Then we just say break. Now running this, watch what happens. The first iteration, we get 9, 8, 7, and then it stops when it hits 6, and it jumps outside of this for loop, prints that new line, and then it goes to the next iteration of this for loop. Next one, it goes 8, 7, and it still doesn't print 6, and it's going to do that for the whole thing. This line, we don't have any output because the first character was 6, so it just breaks out of it and goes to the next iteration of the outer for loop. So that is how the break keyword works. It's only going to break out of the inner loop, so if you're in a nested loop, it's going to just continue to the next iteration of that outer loop. We could also put one in the outer loop if we wanted. So for example, what we'll do is we'll just say if I is equal to 3. What are we going to do? We're going to break. So what is this going to do? It's going to break out of that outer loop once I is equal to 3. Give it a run, and you can see we do all of the output. So this loop is executed, and then we get to this if statement, and it breaks out of it. If you wanted to stop before it outputs this, then you can move this up above the for loop like so. Then just format a little bit. Oh, right there. All right, so now when we run the thing, you can see it doesn't give that output. Hey, welcome back everybody. This video, we're going to be talking about the continue keyword. It's a good follow-up to the break keyword, so if you didn't check out the previous video, you might want to go check that out and become familiar with that. Alright, so the continue keyword is similar to the break keyword in that it's going to affect the loop. But the difference is that while break will completely exit the loop, continue just exits that iteration. So it's a way to jump to the next iteration of the loop. So a simple example is if we wanted to output all of these numbers each iteration, but we wanted to skip the number 5. We could do that by using the continue keyword. We could say if k is equal to 5, continue. So what's going to happen, the only difference is it's not going to do this line here. So if there's any code after the continue, when this is true, it's not going to be executed. So let's run this, see what happens. Here we get 9876-43210, and so forth. You can see each time it skips the number 5. So continue is very useful when you want to treat a special case special. We might do something similar in the outer loop if we wanted to skip the iteration that starts with 6. So that might look like this. If I is equal to 6, continue. Running this, you can see it goes from 7, and then this one is actually 5, but we skip 5 here, so that's why it looks a little bit confusing. So 9, 8, 7, 5, 4, 3, 2, 1, 0. So the counting works exactly the same way, just the iteration where I equals 6 is skipped. So hopefully that helps you understand the continue keyword. Be sure to check out the next video where we're going to be talking about something completely brand new. Well, maybe. I mean, it depends on how much experience you got, but new to this series, I'm pretty stoked. We're going to be talking about arrays and collections and all that good stuff. So please be sure to subscribe and check out that next video.
Yo, what is up everybody? In case you're new to this channel, this is the face behind the beautiful voice of these tutorials. Welcome. We're doing something a little bit different than what we've been doing up so far in this series. Basically, as we get into more complex stuff, I'm going to take a video to basically go over the concepts for a particular thing, and then we'll go hands-on with that concept in the following video. So for example, today we're going to be talking about arrays. You're going to get the information needed for arrays, and then we're going to go through it again in the next video. So it might be slightly redundant, but it's definitely useful for those of you who like to get a little bit more context about what you're learning. So hopefully this is helpful for you guys, and if it's not, then just go ahead and skip to the hands-on video. But you're not going to want to do that because I need that watch time. So be sure to subscribe and watch the entire video. Alright, so we're going to be talking about arrays. And basically you can think of an array as a type of collection. What's a collection? It's a group of things. So when you need to put numerous things together in a group, you can use an array. Think about if you needed to store 10 grades for a student's grade report, like their report card or whatever, maybe the assignment grades they've gotten for a particular class. You might have something like this. You'll have int grade 1, int grade 2, you'll assign values to these, and you have all the way down to grade 10. And as a side note, again, my handwriting is literally the worst, as well as my spelling, so just to prepare you guys. So why would you not want to do this? Well, you're going to end up with 10 variables. And then if you needed to do the same thing for another student, you're going to have 20 variables total, and you're going to have to keep track of all this information, and it's just a giant pile of garbage. You don't want to do that. Hey, Aaron? Aaron? Mom? What? Do you have any old shirts I can use? Just shirts to wipe off my chalkboard? I can't use an eraser. Wouldn't it be nice if we could just put all of those pieces of data together in one data type? Well, we actually can do that, and it's going to look something like this. You're going to say int because we're storing integers, and you're going to use square brackets. This is how we indicate it's an array. Then we give it a name, so we can say grades. And there we go, we just declared an array. But the thing is, the array also needs a size, so how many elements you can store inside the array. So to do that, instead of ending the semicolon here, you can actually assign a value to it and say new int square brackets and then a size. So that's the syntax to create an array. Usually it's on one line, but I can't fit it. So just basically the data type is an integer array. This is the name of the variable, and this is what we're assigning it. We're assigning it a new integer array of 10 elements. And that's what the things inside of an array are called, elements. So it's going to look something like this. So we have one structure with 10 spots in it. Each one of these is known as an element, and each one has an index. So this one's going to have index 0, this one's going to have index 1, 2, and so forth. So it starts as 0. So it's a 0-based thing, which means the last element here is going to have index 9. So the last element's index is always going to be 1 less than the size of the array. In this situation, the size is 10. The last index is going to be 9 because it starts as 0. You can get that size of an array using the array name dot length, which is a property. So it's going to look like this. Grades dot length. No parentheses, just the name. Now you don't use the square brackets when you're referring to the array. You're only going to do that when you're creating the array with the type up here. Sometimes when you're declaring the type, you'll see it as this instead, with the square brackets attached to the variable. Both are legitimate ways of creating the array, but this is the preferred way of doing it, as it clearly says this is an integer array right here versus having to look at the variable name. It's just a preference. If you're coming from C, this might be more comfortable, but if you're new to Java, you want to probably do it this way. Then, after this point, when you want to refer to the entire array, you just use the name with no square brackets. If you want to access a particular element in the array, that's where you use the square brackets. So I'll show you that in a minute, but just to finish up here, grades.length, this is a type integer. So anywhere that's expecting an integer, you can use grades.length. If you want to access a particular element, it's going to look like this. Grades, square bracket, and then you put the index. So for example, 9. That's going to grab the item with the index of 9. In other words, it's going to grab the 10th element. So hopefully that's nice and crystal clear for you guys. What we're going to be doing now is going over some practice with arrays, so please be sure to check out that next video and hit that sub button. Thanks for watching, and I'll see you then. Yeah!
Hey, what's going on everybody? Welcome to your hands-on practice with arrays. This is going to teach you the basics of arrays, so how to create them, how to fill them with elements, and throughout the next couple of videos we're going to learn different things we can do with arrays. So pretty soon we'll be talking about using arrays with for loops, some special methods with arrays, and so forth. Alright, so to create an array, you say what type of information you want to store. So for example, int, and then you put square brackets. That's how to indicate it's an array, and then you give it a name. So for example, we could say grades. And then you can end it with a semicolon. Now this is going to declare an array, but we're not actually creating the array. We're not initializing it yet. So this is the equivalent of saying int x when we're working with integers. We actually haven't given x a value, we haven't initialized it. So if you want to give it a value, what you can do is you can say equals, and then say new int, and then square brackets, and inside the square brackets, put a number. So this is the number of elements you can store in the array. You could do 100, you can do 10. We'll just go with 10 just so we have a nice, reasonably sized array. Now, first thing you might want to know is that you can also put the square brackets over here on the left beside the variable name. So you might also see it like so. This is more of a C style of doing arrays. I think most people prefer to put it on the data type. That's what I'll be doing, but it is kind of cool that you can do either one. Personally, the reason I like to put it over here is because it's clear what data type it is. When you just see int, you might be confused thinking it's an integer, and then you'll later on see that it's an array. So maybe that's just something I would do, but that's why I personally like the square brackets on the data type. It's just really clear up front. Now to access the elements, you have to use indexes. So we can say grades 0, and we can assign it a value such as 10. So the first element starts with index 0, and it goes up from there. So the last spot in the array is going to have index 9. That's a total of 10 spots, 0 through 9. And then we can output this just like any other integer. We just say grades of 0, and then we run, and look at that, we get the value 10. Java has a shorthand way of filling an array with values, and what you do is, let's just get rid of this here. And what we're going to do is we're also going to get rid of this new int size 10 and replace it with curly braces. Now inside the curly braces we can put the values. And however many values you use is how big the array is going to be. So in this situation we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So the size of the array should be 10. Running this, it should give us the exact same output because index 0 still has the value 10. But you can easily see when we change that it's going to update. So this is my preferred way of giving arrays values. The downside here is you have to know all those values up front and they have to be hard-coded like so. If you don't know the values up front, you're going to have to think of a more dynamic, creative way of filling this array, such as using a loop. You can also, at this point, update a particular index. So for example, you could say grades of index 1 and assign it the value 900. and then we can output the index 1. You can see there's no compiling errors. We run it and we get 900. So basically we updated index 1 here and changed the value to 900. The only thing we can't do is go beyond the size of the array. That's going to be an issue. So for example, if we go in here and access index 10, well, this has index 9, so index 10 doesn't exist. So watch what happens when we run this. Oh, we get an exception. Exceptions are when we have a runtime error and there's no code there to deal with it. So this is a problem. If you really want to fix this, you can say try and then catch something like this. Running this, we see we get the exception outputted into the console. But we haven't really talked about that, so don't worry about that for now. Just don't go outside of the bounds of the array, or you will get pwned, you'll probably get fired, and then you'll lose everything you own, and you'll be homeless, and your loved ones will probably like abandon you and whatnot. So going outside of the index of the array is a big no-no. It's the top bad thing to do in all of computer science probably. So don't do it. Later on we'll talk about how to make it dynamic so you can have a collection that resizes. That's going to be a lot better, but we need to learn the array fundamentals. So awesome. Thank you guys for watching. I'll see you in the next video. Hey, what's going on everybody? Welcome back to your Java series. Specifically today, we're going to be talking about how to easily print arrays. Now, when you learn this, you're probably going to be researching for loops and all that junk, but I'm going to be teaching you a super even easier way. So if you just need to get the value of an array, check it. It's going to be easy. All right, so check this out. If you try to print this array, you just throw grades in here. Watch what happens. What is this mumbo jumbo? That's not what I wanted. I wanted this information. Well, it's actually really easy to do that. All you have to do is use this code right here. Arrays dot toString, and then in parentheses, oh, not deep toString, just toString, right there. And then in parentheses, you're going to put the array name. So we will put grades. Awesome. Now check this out. Run this, and we get the value of our array. So that is how you do it. Now another useful method actually popped up earlier, deep toString. But when we run this, watch what happens. Nothing, we get an error. That's because deep toString is actually for arrays of arrays. So check this out. I'll show you guys real quickly how to do that. If you add another square brackets to the data type over here, we can actually make some of these arrays themselves. So here's an array, and here's an array. Now, when we output this, we get the array of arrays. So we have one array here, and we have one array here. If you just did the toString, watch what happens. Run this. Again, we just get this stuff right down here, which is not what we want. So although this might be useful if you're looking for the address of the array, we want the actual value. So make sure if you're working with arrays of arrays, you need to use the deep version, like so. All right, there you go. That's how you quickly and easily print the values of an array without a loop. Thanks guys, I'll see you in the next video. Welcome back everybody. This video, we're going to be talking about how to iterate through an array. There's two good purposes for this. One, if you need to work with each value of the array individually, and two, if you need to fill an array one value at a time. So hopefully you guys are excited. I'm super excited. All right, so let's first start with an array of, let's say, size 10. So what we'll do is we'll just say new int, and then inside the square brackets, we'll just say 10. So that's how many elements there are, and then a for loop might look something like this. I also, if you guys didn't see the for loop tutorial, if you need more experience with that, you can go check that out earlier on in this series. So we'll say int I, assign it the value 0, and then we'll say I less than 10, and then I plus plus. This will give us 10 iterations, and the I will actually line up with the index value, so it's really nice and easy. So all we gotta do is say grades index I, not 9, I. That is going to reference each position in the array, each iteration. And what we'll do is we'll just assign it the value 5. And then at the end, we're going to output the value of the array. So we'll just say sysout arrays dot toString, and we'll pass in grades. Run this, see what happens. You see we get an array of 10 5s. If we took this line of code and ran it up here, check this out. You can see we just get a bunch of zeros. So we went through each iteration and gave it the value 5. So we can actually get this value from user input if you would like. So that might look like this. Let me get rid of this line here. And we can say scanner, call it something equals new scanner. Hover over that and import scanner. I think it's java.util, hopefully. All right, so there is the import. And then for right here, all we have to do is say system.in. And then inside this for loop, we can create a variable. We'll just call it x. And we'll get this from input by saying input.nextInt. So this is going to get the next integer in input and assign it to this variable here. Then what we can do is we can take this value and we can assign it to the value of the array. All right, let's try it. Let's see if it works. Run this, it's asking for input. Let's just put some stuff in here, put in some values, and look at that. It fills the array with what we typed in. So that is pretty awesome. Another thing you can do is you can also use scanner input to determine the size of the array. So if you want to see that in action, watch this. We'll take this scanner and we'll put it above the array declaration, and we'll create a variable. We'll just call it size, and we'll get it from input.nextInt. And then we'll put in the size variable right here. So when we run this, it's actually going to be asking us for the size. We'll just say 3, and oh, there's actually a bug in this code right here, because this for loop goes up to 10 every single time. So instead of typing that in there, we should have used a constant to declare the size everywhere and then just have the value in one spot. Or you should reference this variable here, which is what we'll do. So we'll change that to size and we'll rerun this program. So now we can determine the size 3. Now we should get 3 iterations of the loop. So we'll go with 5, 10, and 15. And look, that's what the array is filled to. This might not seem that crazy, but this is actually really cool because not every programming language allows you to dynamically size the array by getting user input. So that's pretty awesome. Now the challenge for you, which shouldn't be too hard, is to output the array values using a for loop instead of this right here. Let me know the solution in the comments below, and thank you for watching. Be sure to check out the next video. Yo, what's up everyone? Welcome back to your Java series. This video, we're going to be talking about how to iterate through an array looking for a particular value. So essentially how we can search an array for a value. Later on, you could extract this to its own method, basically make it a utility method so we could easily search an array. But for now, we're just going to be doing it inside the main method here, and that's totally fine. Now, if you're interested in algorithms, there are various searching algorithms out there. You might want to look that up if you're interested. This one's going to be very brute force technique. We're just going to look at index 1, see if it's the value. If not, go to index 2, and so forth. So we're just going to go all the way through the array. Alternative ways are sorting the array and then just grabbing the right position, etc. You can look all that information up if you want, but here I'm just hoping to get some experience with loops as well as iterating through arrays. So let's get started. So coming from the previous video, there's a lot of code here. If you want to keep it, that's fine if you like the way it works. But what I'm going to do is I'm just going to change it up a little bit. Instead of getting from input, I'm just going to manually put the values of the array like so. So that is how you can assign values to the array while we're declaring it. And then what we're going to do is we're just going to get rid of all this here. Hopefully you guys didn't start this video and type it all out and then realize I just deleted the whole thing. But what we're going to do now is we're going to start a for loop from scratch. All right, and we'll say int I is 0. I is less than, what you can do is actually grades.length and then I++. So that's how you can dynamically grab the length of this array. So this should say 3 essentially. So I less than 3. And if we add more elements in here, the code's still going to work just the same. So that's pretty awesome. And what we'll do in here is we'll do a case and we'll say if grades index I is equal to, let's say 72, then we'll output that we found it. So let's run it and you can see nothing happens. That's because the value 72 does not exist inside of this array. So what we can do is we can put that value in here, run it now, and there you go. Now, you might want to do some different things, such as say what index it's at. If you wanted to do that, we could just say found at index, put a plus sign to append or concatenate, and then put I. Running that now, it says found at index 3. Is that correct? Index 0, index 1, index 2, index 3. Awesome. So that is a very simple brute force way of searching an array for a value. There may be methods out there that you could use that already exist. There's also, for example, there's arrays.binary search. You can research that if you want to know how to use it. You see there's lots of overloads here and so forth. But hopefully that's a good introduction. Thank you guys for watching, and we'll be doing something else in the next video that should be pretty cool. So thank you guys for watching. If you can do anything to help me out, just subscribe to this channel. That would really, really be appreciated. And I'll see you guys in the next video. Hey, what's going on, everybody? Welcome back to your Java series. This video, we're going to be talking about how to take an array and get a sorted array. Yeah. All right, so this is actually really easy. So you could go and create a custom algorithm to sort the array. And there's a chance that might be what you're here for. And I'm sorry to disappoint, that's not what we're going to be talking about in this video, because usually I don't see the point in recreating something if there's already a solution to the problem. If you need really specific rules or some particular algorithm for sorting, you can definitely look up how to do that and try to code it yourself. But there's actually something that already exists. So you just say arrays dot sort. And then in here you put the array grades. Hovering over this, you can see that this is void. So what that means is it doesn't return a new array. It's actually going to modify the array you are working with. So grades will be modified. So let's output this just to see what happens. We'll say sys out, and then in here we're going to pass arrays.toString, and we're going to pass in grades. Running this, and we get 1, 2, 3, 5, 72. Awesome. So you can see we just sorted an array. There's also another one, which is getting rid of sort. We just say parallel sort. And this is also going to take grades like so. Running this, you see we get the exact same output. So hovering over parallel sort, we can get a little bit more information about this. So this is a parallel sort merge. It breaks the array into subarrays that are themselves sorted, and then they are merged together. So if you are working with a very large array, this might be the method for you when it comes to sorting your array. So those are two ways that you can sort an array. Very easy methods to use. It makes your life a whole lot easier. So hopefully that video was nice and helpful for you guys. Please be sure to subscribe if you've enjoyed, and check out the next video because we're going to be talking about some important array methods that you should know about. Assuming I don't change my mind by the next video, which usually happens, so we'll see. Thank you guys, and I'll see you then. Yo, what's up everyone? Welcome back. This video, what are we going to be talking about? We're going to be talking about some common methods that you might want to use when you are working with arrays. So stay tuned. I'm pumped. Hopefully you are as well. All right, so first thing, we're going to be talking about comparing arrays. So check this out. Let's say we create a new array and we just call this grades 2. We'll call the first one grades 1 just for clarity. And we're going to make it have exactly the same elements. So 1, 2, 3, 72, and 5. Now what I want to do is I want to say if grades 1 equals grades 2. And we've talked about this before, where this comparison is actually going to compare if they are the exact same entity, not necessarily the same value. So we'll print equal there just to see what happens, and when we run this, nothing happens. So let's try another version. We could say if grades 1 dot equals, and then pass in grades 2. So this is the way I've taught you so far, and let's see what happens with this. We'll put equals there, run it, and still nothing. What in the heck? So how can we actually compare to see if these have the same values? In this situation, it's actually going to check if they are the same array. They're actually not. They are two separate arrays, they just happen to have the same values. So that technique's not going to work with arrays, and just to prove that to you, watch this. We'll print grades 1 and we'll print grades 2. We'll put a plus sign there and a space. Running this, we get two different values. You can see this one ends in 1D and this one ends in EE. So it's basically comparing to see if these have the same value, and they don't. That's because they point to two separate arrays. So to actually compare if two arrays are equal, you have to say arrays dot equals. And it says here, if both arrays contain the same number of elements and all corresponding pairs of elements in the two arrays are equal. There's also deep equals. This is important for nested arrays. So basically it's going to make sure that any nested arrays also have matching values. But we're just working with simple arrays, so we'll just use equals. We'll pass in grades 1 and grades 2. Hovering over this, you can see this returns a Boolean, so you can put this inside of a condition, like so. Now what we're gonna do is we're gonna say equals. Run this bad boy, and look at that, we get equals finally. So that is how you compare for values. You can use this technique if you're comparing to see if they are the same object. So if you wanna see that, what we could do is we could actually assign grades 1 to grades 2. Now when we run this, we get all of these passed as equal. That's because they are actually pointing to the same exact array. Now another method you might see is fill. So what does this look like? First, let's get rid of this, and we'll say arrays.fill. And we're just going to put, well, what's it asking for? A is the array to be filled, and val is the value to be stored in all elements of the array. So this is how we can fill an array with a particular value. So we'll say grades 1. We can actually just get rid of the 1 since we just have 1 now. And the value we're going to put in is 72. We'll output the array just to make sure. And check this out, every value is now 72. That's useful if you're working with objects. So for example, let's say we have an array of string, and let's say we just assign this a new string array of size 5. We'll comment this out for just a second and we'll output it to see what we get. You can see we get null, 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 null. And maybe you don't want those nulls and instead you want an empty string. We can do that real easy just by throwing it into the arrays.fill and putting an empty string right there. Now when we run it, check this out. We get empty strings. You can't see them because they're empty. Now another cool method, and this might be more practical once we get into lists, but just trust me for a second. What you can do is you can say arrays.asList, and what this is going to do is it's going to return a fixed size list. So let's just give this a try. We'll pass in grades. So this returns a list, so we actually have to assign it to a list. So what's that going to look like? We just say list, and then in the less than and greater than symbols, we just put type string. We give it a name, we can just call it testing, and then we assign. So hover over list, and you will need to import list from java.util. And there we go. So if that has absolutely no meaning to you, that's totally okay. Basically, a list is just a different way of storing data. It's similar to an array, but it's a little bit more dynamic, and that's actually one of the things we're going to be talking about real soon in the next video or so. I think we'll talk about multi-dimensional arrays, so 2D arrays and maybe even 3D arrays, and then we'll talk about lists. So thank you guys for watching. Hopefully this was a nice and helpful video for you. Please be sure to subscribe if this has been useful, and I'll see you guys in the next video where you get to see my pretty face again, because we're going to be talking about 2D arrays in person. Catch you guys there.
Hey you, welcome back. This video we're going to be talking about 2D arrays. Alright, so we talked about 1D arrays, which look like a rectangle, but now we're going to be talking about 2D arrays, which look like more like a table or a square or a different shaped rectangle, like so. So now, not only can we store information this way, but we can also store information in these other spots as well. So whereas before we may have stored the grades for one student, maybe this can be the grades for every student, each row being a new student. So just to get some terminology up front, a row goes this way. A column goes this way. So that's important when we talk about indexing, how to get a particular spot on this 2D array. You need to know which is a row and which is a column. So with the rest of the video, we're going to be talking about how to create 2D arrays and how to use the proper indexing to grab a particular position. So here is how to create a 2D array. You say the type. So they all need to be the same type. Then you're going to put two square brackets. Two sets, I should say. Give it a name. And what you're going to assign to this is actually a new integer 2D array. And we're going to put the sizes here. So here is the rows, and here is the columns. So if we need 3 rows, we would put a 3 here. If we need 4 columns, we would put a 4 here. the shape that's going to make looks a little bit something like this. We're gonna have 3 rows, 4 columns. So that's the structure we just created. Now when we grab a particular element, we need to use both square brackets. So for example, student grades, 2 square brackets. Let's say we want to grab this one here. Well, let's first look at the row. What row is it? Well, this is going to be row 0, also 0 based. This is going to be row 1. So we would put a 1 here. What column? Column 0, column 1, column 2. So here's how we would reference that position. You could assign a value to it, just like this. You could put a value there, and that will fill in that spot right here. So let's just talk a little bit about types, just so we're all on the same page. So when we say student grades with no square brackets, what is this? Well, it's actually a 2D array. Now when we say student grades with 1 square bracket, this is actually an array. And you would actually put a number in here. So for example, 1, that would grab the row with index 1. And then lastly, if you use 2 square brackets like here, it would be an integer, because it would refer to this value right here. So when you're working with different methods or other things that need either a 2D array, an array, or an integer, just make sure you're passing in the right thing. But we'll get into that more as we go on into the advanced stuff. So if you've enjoyed this content, hit that sub button and check out the next video. Peace out. Yeah.
Yo, what's up everyone? Welcome back to your Java series. Today we're going to be talking about 2D arrays as well as some other cool stuff you can do inside of Java. So I'm stoked. Hopefully you guys are as well. So we're going to start by just creating a single dimension array, and then we'll convert it to a 2D array. So we'll start with int, we'll just go with grades, and we'll assign it a new integer array like so. And we need to pass in a size, so we could say there's going to be 5 elements. Well, if we wanted to convert this to a 2D array, all we got to do is put another square bracket here and another square bracket here. And this will actually compile even though we don't put a size here, but I'll be talking about that in just a moment. For now, let's put a size there. So this will give us a 5 by 5 table essentially, where this is the row and this is the column. So for example, we could say grades index 0, index 1, and that's going to grab the first row, the one with the index 0, and then the second column, which has the index 1. So it might be easier to visualize if we had a visual of this. So for example, instead of just assigning this here, we can actually give it values. So to do that, here's what we need to do. Use curly braces, and then we can put groups of curly braces inside and put some values in here. Awesome. So now, as an example, we might try to grab this 4. Here's how we would do that. We would say grades, grab the row with the index 1, because this one has index 0. So we'd say grades 1, and then column with the index 1 as well. Run this, and you can see we get the value 4. Now, if you just really quickly need to output the entire array, you can do that like so. All you gotta do is say arrays.deep toString and pass in the array grades. Running this, you can get that right in the console. But for now, we'll just get rid of that and just work with what we have here. The interesting thing though is that you can actually have arrays of various sizes. So you might hear of this as jagged arrays or ragged arrays, but essentially we can go in here and extend one of these, but not all of them. And this explains why earlier we had new int and we only had to put the size for the first square brackets, because we could go and assign arrays of various sizes to each one of the rows. So it does not have to be a square shape. I'm going to get rid of this and go back to what we had. And now we can go farther down here. For example, we can grab index 4. Running that, we get the value 3, which is right here. So you do need to be careful with this because we're not in a square shape, so it can be really easy to go out of the bounds. So for example, if we were on index 0 for the row, we're going to get an issue. You can see we get an exception. That's because this one does not have an index 4. Keep this in mind when you're iterating through these things. You can't necessarily just assume it's a table. Speaking of iterating through an array, that's what we're going to be talking about in the next video. So stay tuned. I'll see you then. Hey, what's going on everybody? Welcome back. This video, I'm going to be telling you guys how to iterate through an array, but not just a single one-dimensional array. We're actually going to be talking about 2-dimensional arrays, or in this situation, we don't have a nice square structure, we actually have a jagged array, and it's going to work pretty much the same way. So hopefully you guys are excited. All right, so the first thing I want to do is just take a minute to talk about some of the tools we're going to use when iterating through this. And the first one of those is actually going to be grades.length. So let's run this and see what we get. 3. We can use this value to dynamically iterate through the array without going out of the bounds, assuming we got our loop conditions all correct. But there's actually another length we should know about. Let's check it out. What we're going to do is we're going to say grades, and instead of just putting dot length, we're actually going to say grades and then throw an index in here such as 0 dot length. Let's see what we get here. You can see we also get 3. But the reason we're getting 3 is because we passed in that 0 index, and it's actually checking how many elements are in this array right here. So if we passed in index 1, we're actually going to get a different value. You can see we get the value 7. That's because this array has 7 elements. So these are 2 things we're going to need to use inside of our loop. So let's just create a for loop, and pretty soon we'll be talking about another type of loop you can use, but for now, this will do. We're going to need 2 for loops when we're working with a 2D structure like this one. And here's what we're going to do for the outer for loop. We're going to say int I is equal to 0, I less than grades.length, I++. And then for the inner for loop, we're going to say int k is equal to 0, k less than grades.length, and then k++. Now the index we're going to pass in, well, we can actually reference which row we're on by using the I. So the first time it's going to be 0, which would be this one, then the next time 1, and then the next time 2, and so forth. So just pass in I here, and then what we can do here is just say sys out and pass in grades, index I, index k. So that is the entire process. Let's run this, see what we get. Obviously everything's going to be out on a new line, but let's just see if we get the right order. So the 3 and the 7, those come from right here. I'll just comment those out because we're not going to be using those right now. And then we start at the beginning. So we got 1, 5, 3, 8, 4, and you can see it follows that same pattern down here. So it seems like it's going in the appropriate order. Now, if you want to make it more like this structure here, you just need to do a little bit of formatting. First, you can change it from print line to print and throw in a space here. And then after the inner for loop, we can just sys out a blank line here. So run this, and you can see we get that exact structure. If this is really confusing to you guys, it might be easier if you switched up the variable names to more accurately describe what we're talking about. So for example, I could be renamed to row, and if you want a cool way to do this, you can right click I and click refactor and then rename. What are we going to rename it to? We're going to rename it to row, and you can see that's going to change all instances of it here. We can do the same thing with K, and this one's going to be column. So there you go, guys. That is the proper way to iterate through a 2D structure, such as this 2D array. It's very dynamic because we can go in here and we can change the structure and everything works fine. There's just another example of what we can do. Running this, you can see it still works. Thank you guys, and I'll see you guys in the next video. Oh, and don't forget to subscribe.
Hey everyone, welcome back to your Java series. Today we're going to be talking about the array list in Java. Now, if you have experience with arrays and you want to move on to something a little bit better, then this is the video for you, because trust me, array lists are going to make your life a whole lot easier. So coming from arrays, you probably understand how they work, how you can index them, and so forth. But the benefit of an array list is that they can dynamically resize. So with an array, you set that size up front, or maybe you get that size from user input, but once it's set, you're done. You're not able to add elements beyond the size of that array. Array lists are different because if you add extra information to them, it'll actually resize as necessary to fit that information. So it's a much better solution for working with collections of data. It's just easier, all around better. So let's talk about the syntax for creating an array list. You're gonna have to import something, but we'll worry about that in the next video where we're doing the hands-on version of this. For now, let's just talk about the concept of array lists. It's gonna look like this. You're going to say array list, just like that, and then you're going to put the less than, greater than symbols, whatever they're called, alligator mouths, and you're going to put the type in here. Now, we'll talk about this in just a second, but first, let's finish out the rest of this. We're going to give it a name, and then we can assign it a new array list, and then parentheses. All right, so that's the whole thing. First, let's talk about the less than, greater than sign. So whenever you see this, it's what's known as a generic. So generic programming allows you to basically create a class that can work with various types. That's the syntax. We'll probably get into that later on in this series. Essentially, all you really need to know is, you see that those symbols, you're expected to put a type in there, such as integer. So the reason we have the uppercase I with integer spelled out is because it's actually going to expect a class here. If you go back and watch our videos on types, you'll hear a little bit more about int versus integer, but essentially it's just a wrapper around int. So we make it a class type, we're good to go. So that is the entire structure, and then to put stuff inside of this list, all you gotta do is say grades dot add, and then in parentheses you can put the value such as 5. That's going to push it onto the array list. To get an element, here's what you do. Grades dot get, and then in parentheses you put the index such as 0. That's going to return the value 5. If you want to update that spot, you can use grades dot set, where you pass in the index, give it a new value such as 10, and you're good to go. That's going to update index 0, and it'll replace the value 5. The list is also going to have a size method, which is going to give you how many elements are in the array. So just say grades.size. And this is a method here, so make sure you put those parentheses. That's going to return a value, so you can use that for the loops or whatever you're trying to do. Notice in here, we don't say what size this thing is. We don't have to worry about that. That's basically abstracted away from us. That's all done behind the scenes. So that's your introduction to array lists. Check out the next video because we're gonna get some practice with this, and I sure am excited. So please be sure to subscribe, and I'll see you then. Peace out.
Hey, what's going on everybody? Welcome back. This video, we're going to be talking about lists and array lists inside of Java. It's going to be pretty intense because we're going to be talking about a lot of new stuff if you've been following along the series from the beginning. So make sure you put your big boy pants on or big girl pants on. Buckle up because it's going to get pretty intense. So the first thing, let's talk about how we create a list. It's very simple. You just say list with a capital L, and then you put the less than and greater than sign, and you put the type. Then what we do is we give it a name such as grades, and we're going to assign something to it. Now, there are various types of lists in Java, but we don't necessarily care about the inner workings of how these lists work. Let's compare it to something we might understand a little bit better in the real world. When you are driving a car, you don't really have to worry a whole lot about the inner workings of the engine and all of this stuff. It is abstracted away from you. All you care about is the steering wheel, which you can use to turn, the pedal, which you can use to speed up, and the brake, which you can use if you're a wussy. That's similar to what's going on over here. All we're saying is that grades is some list. It doesn't matter what type of list. And then over on the right, we can be specific and say what kind of list we want. So this is where we get to pick our car style, our engine, and so forth. So to do that, we can say new, and the example we're going to use, our choice of engine, is going to be an array list, and similarly, we have to put the type inside of the less than and greater than sign. And we end it off with parentheses. So these have red lines under them because we have to import some stuff. So hover over list and import list from java.util. Hover over array list and import array list from java.util. There we go. So you can see no compiling errors, everything should be good. So on the left, we made grades very general. All we care about is that some type of list is assigned to it. On the right, we're very specific and we say we definitely want an array list. It might not be super clear up front why we're doing this, but the main reason is so that we can basically swap out the implementation without changing a whole lot. So for example, instead of an array list, we could have a linked list, and that's also going to need imported. So import linked list from java.util. And you can see this also compiles. All of this is basically giving you a taste of object-oriented programming and interfaces. So when we're going back to the illustration of the car, the steering wheel, pedal, and brake, that is known as the interface. It's how we work with the car. The internals of the car, the body style, all of that, that's known as the implementation. So when we're choosing a car, we don't necessarily have to worry about the implementation as long as the interface is the same, it's what we understand. and it allows us to easily swap out an engine or swap out a different paint style, and everything works exactly the same way. Now, enough of that stupid illustration with the car. Let's talk about this in code and explain what an interface is versus an interface implementation. So list over here, this is an example of an interface. Linked list or array list is an example of an implementation. So there's a good resource on the internet. So if you just search Java API documentation, you can click the Java API Oracle Help Center. You can get the right number if you need, but it's all pretty much going to be the same for this example. And what we can do is we can actually use Command F or Control F on Windows and search for array list. We can open that and we can see a little bit more about this class. And looking in here, you can see implemented interfaces, and one of these is list. So what this means is that an array list has met the requirements to be considered a list, and then that can be assigned to the list type, which we used in our code over here. So going back over here, you can click list, and you can see the things we can do with a list. So here are some of the methods that are available to us, and so forth. So this would be a good document if you want to get a little bit more in the details, but for now, I think we got a pretty good understanding of interfaces and implementations. So that's all I got for you guys in this video. What we're going to be doing in the next video is we're going to be talking about how to work with this list, some of the most popular methods, and so forth. It should be pretty exciting, and hopefully this gave you enough information to understand interfaces and so forth. Thank you. Be sure to subscribe, and I'll see you in the next one. Alright, welcome back guys. I just recorded this entire video and forgot to press record. So, the second one here is going to be either a lot better or a lot worse. I guess we'll have to find out. Alright, so what I wanted to talk about in this video is just some different things you can do with a list. Then in the next video, we're going to be talking about a shortcut to add elements to the list and how to easily print out the entire list with one line of code. Alright, so the very first thing, you can add elements to this thing one at a time using the add method. So inside of parentheses, we just put the value we want to add, and that's it. We can add a couple elements in here, such as a 5 and a 10. So to get those, what we do is just say system.out.println, and we can just say grades.get and pass in the index. So for example, 0, that should give us the value 5. Passing in the index 1, that's going to give us the value 10. But you can also add and specify what index you want to put something at. So for example, we could say grades.add, and if you get the pop-up to go away accidentally, you can go back and type add out again, or what you can do is you could just go in here, hold Control Shift and press space. There you go. I'm on Mac, by the way. Now you can go and see the overloads here. You can see one of them takes an index. So that's what I'm going to go with. And we're going to pass in the index 1, and we're going to pass in the value 7. So originally 10 was at index 1. So what's going to happen is it's actually going to go between 5 and 10. 10 is going to be shifted up to index 2. So now when we get index 1, we should get the value 7. And in fact, we do. So overall, here's what it looks like. Printing index 0, 1, and 2, we get 5, 7, and 10. Now if instead getting the index, now right now we're passing in the index, right now we're passing in the index and we're getting the value. What if we wanted to do the opposite? So we pass in the value and get the index. Well, we can actually do that. So let's back up and just say grades dot index of, and then all we have to do is pass in the value. So for example, we could pass in 7, and we should get a 1 as a response, and we do. Now if you pass something that does not exist, we'll get a -1. So that's how you can tell if something does not exist inside of a list, but there's actually a better method you could use, and that is contains. Here all we have to do is pass in a value we're looking for, such as 7. So the result is a Boolean, which is even more useful if you're trying to case. It's really simple because you don't have to do any comparisons. You can just say if grades.contains 7, and then you can put your code in here. You don't have to say equals true, as redundant. All right, cool. What else can we do? I don't know, what else can we do? Let me look. So another method you might be interested in is grades.isEmpty. So this is going to check if there's any values at all inside of this list. This might be a good thing to do before you start just grabbing elements out of it, because if you grab an index that doesn't exist, well, you're going to get an index out of bounds exception. So just to show you guys that, let's try it and say we wanted to say grades.get index 0. Commenting this out for a second. Running this, we get 5. But if we get rid of these adds for just a moment, this is the simplest version of an ad blocker. Now what happens when we run this? You can see we get an exception in main, index 0 out of bounds. So we could have checked if it was empty ahead of time by saying if grades is empty. We could even invert that with the exclamation mark. If it's not empty, then what we can do is we can get index 0. There we go, that's a little bit more safe. Running this and nothing happens, which is exactly what we want. This might be another tool if you're removing elements, you want to make sure there's an element there to remove. So for example, you could say .remove, pass in index 0. If it's not empty, then we're going to remove that index. And instead of an if statement, we could do this in a while loop even. So we can say while grades is not empty, we're just going to remove that. And this actually returns the element that was removed, so we should see it pop up in the terminal. But make sure we add some stuff first. So we can add these elements in there, and we get 5, 7, 10. But now grades is actually empty because each time through this loop, we removed one of those elements. Now, if you're wanting to just remove everything, you don't need to do it one element at a time. What you can do is just remove everything, and I'll show you guys how to do that now. All you gotta do is say grades.clear, and this is going to get rid of everything. And you can see hovering over this, this is actually void, so we don't want to put this in a print line. We just want to have it by itself. And there you go, that is how you can clear a list. So we just went over a ton of different methods with lists. Hopefully those were useful, but what we're gonna do now is we're gonna talk about how to add elements to a list quickly and how to print the entire list all at once. So that's what we're gonna be talking about in the next video, so please be sure to subscribe and check that out. Peace, guys. Hey, what's up everyone? Welcome back. This video, we're going to be talking about how to easily add data to a list and how to easily print a list in just one line of code. All right, so if you guys remember, working with arrays is really super easy to add elements up front. For example, we could create an int array, call it grades, and set that equal to some collection like so. And we could just pass those numbers in here like this. Unfortunately, we can't exactly do the same thing with a list. You can see we just get an error. And it says cannot convert from int array to list integers. So the solution here, well, there's various ways that people talk about of doing this online. You can go look them up if you want to see various ways besides this, but one that I think is the easiest is to just create an integer array in this case, and then convert it to a list, because there's actually a very easy method that we can use to convert an array to a list. So to see that in action, all we got to do is say arrays dot and then select as list. So what does as list do? You can hover over as list if you need more information, but you can see it returns a list and it takes the array by which the list will be backed. In other words, what elements do you want in the array? And then we'll just throw it in here like so, and boom, it doesn't work, man. Just pop them in there, separated by commas, end it with a semicolon, and you are good to go. So that's gonna make your life a lot easier rather than doing this junk or creating some loop to add information, which you might need to do in situations, but in this one, we know the elements up front, so we can just put it as is. If you're getting this from user input, we're probably gonna need a loop. All right, so now we talked about adding elements real easily. How do we print the entire list in one line of code? Well, if you remember a while ago, we talked about how to do this with arrays. All we did was say arrays.to, and there was toString and then deep toString. So here's the toString and then deep toString. Deep toString was if you had nested arrays, but we were working with just 1D in this situation, so we're gonna go with toString. And we're going to pass in our list. It's not gonna work, but it's a step in the right direction. So we'll say grades. So we're gonna get an error. That's because this is expecting an array, but grades is a list, and these aren't compatible. So we actually need to convert it back to an array. So yeah, it's weird, lots of conversion going on here, but this is the easiest way I could think of. So grades dot to array. That's going to convert grades to an array, and then it's compatible for this method, and we can output it. And we'll just cut this and put it in the print line, and we should be good to go. All right, so that was a process, but it should work. Let's run it and see what we get. And you can see it outputs the entire list. So that's what I wanted to show you guys in this video. In the next video, I'm going to be talking about iterating through a list, and we're going to go over some variations in the next couple of videos. So hopefully you guys are excited, because lists are pretty awesome and it's good to get some more experience with them. So thank you guys. I'll see you then, and don't forget to sub. Yo, what's up guys? Welcome back to your Java series. I've been cranking through these videos. It's now 1 in the morning, so I'm getting a little tired, so apologies if my voice is like, or something like that. Please be sure to check out our sponsor before we get started, because this video is going to be pretty awesome, and you know, yeah. Alright, so far we've talked about using these lists. We talked about how to print them, but you're not always going to want to just print the entire thing like this. You might want to iterate through each element so you can work with that element. So I'm going to be teaching you guys how to do that with the for loop, and then we'll go into, quote, for each loop, which we'll get into that in the next videos. So let's do a for loop, and this is what it's going to look like. I'm going to get rid of this line, and I'm going to get rid of this line. All right, so to iterate through this, we'll just start with a normal for loop, and the value we're going to need is actually grades.size, and this is going to return the number of elements in this list. This is going to be important for us because that's how we can dynamically tell the for loop to stop. So what we'll do is we'll say for int I equals 0, I is less than grades.size, and that's a method, I++. All right, so this is the basic way to do it, and then all you got to do is say grades.get, pass in the index, which is I. Then we can just put that in some output. Boom. That's how you do it. Let's run this, see what we get. And you see we have 53263, which is exactly what we have up here. Now, you're not always just going to use the for loop to get the values and output them. You might do something with them. So for example, you could say grades.set, and we're going to pass in the index of the element we're working with. And what we're going to do is we're just going to take that value and multiply it by 2. So it's going to get the value, it's going to multiply it by 2, and then it's going to set it to the position I, which is actually where it came from, so it should replace the original value. So a little complicated, but it should work. Let's run and see what we get. We get 10, 6, 4, 12, and 6, which is in fact twice this array. Well, at least each number is twice as large. All right, so that's some basic work with the for loop. You can do all kinds of crazy things with it. Let's see some creative you can do. Maybe put a cool thing in the comment section below. Thank you guys for watching. Be sure to check out that next video because we're going to get into a new type of loop, which you definitely want to know how to do. All right, I'll see you then. And don't forget to subscribe. Hey, what's going on everyone? This video, we're going to be talking about the for each loop in Java. So stay tuned, it's going to be flipping awesome. Oh boy, so what is the for each loop? It's basically very similar to a for loop, but instead of having all this indexing crap up here, we're going to get rid of that junk and make it a lot cleaner. So our goal is to do this exact same output, but with now this new loop. And it's going to look something like this. We're going to create the body just so we have the structure. Then we're going to create a variable of the type of whatever we're iterating through. So we're working with integers here. So we can just say int, and then we give that specific integer a name. And usually we'll just go with whatever the list is singular. So one particular grade. Then we'll put a colon and say where that grade comes from, grades. So that is the syntax. Now each iteration of this loop, this variable grade is going to contain one of these values. The first iteration will contain 5, then 3, 2, 6, and then 3. Now we don't have to use I anymore because we can just work with the value directly. So all we have to do is put grade here. We'll comment out this other output so it doesn't pollute it. Run it, and there you go. So that is how to create a very simple for each loop. Hey, what's up guys? This video we're going to be talking about using nested for each loops. So to do this, we're going to need some kind of 2D list. So what we'll do is we'll just create a list of lists. So to do this, we're going to change the type here to a list of type integer. So that means this list is going to contain numerous lists of type integer. And the easiest way to initialize this is probably just to use the add method. So what I'm going to do is on the right over here, first off, just push this down for later. We're going to use that later. I'm just going to use the same thing on the right side. There we go. And then prefix it with a new keyword, of course. And on the right side, we can't directly initialize a list because that is an interface. So what we need to do is we need to use a specific type such as array list. Now we can use the add method. So we can just say grades.add. And here's where we're going to use this. Cut that, paste it right there. Get rid of that semicolon, put it on the outside. And we can do that a couple times if we want to put a couple lists in there. Change up the numbers a little bit. And there we go, we got a 2D structure. So now inside of this for, we have an issue. You can see we have grades is not working. And that's because it no longer contains integers. Instead, it contains lists of integers. So we need to say list of type integer. And then on the inside, we create another one which works with the integers directly. So the naming here is a little unclean because this is called grade, but it shouldn't be because it's a list. So we're going to change the name of this to all grades. Change that down here as well. All grades. Change this one to grades. I'm just going to get rid of that for loop. We don't even need that. Make sure all the names are updated. And now in here we can work with an integer called grade, and that comes from grades. Then inside of here we can just output grade. And then after this entire for loop we can do a new line just to space it out a little bit better. Like so. Alright, do an output, let's see what we get. Alright, so each one of these is on a new line, so if we want to fix that we can just get rid of that print line and just use print. You might want to throw in a space or a tab or something in there though. Running this, we now get that structure just like we had up here. So this is the first one, next one, and the third one. So you can see everything is right. So that's how you do nested for eaches. Hopefully that's nice and juicy and helpful for you guys. Be sure to check out the next video because I'm sure it's going to be even better than all the videos so far, which I know is pretty hard to believe. So go check it out and subscribe. Hey, what's going on everybody? I just want to do a quick video teaching you how to take a list and convert it to an array. Now, I looked up how to do this, because I'm not just like some brilliant guy who knows how to do everything. And there's various solutions, but unfortunately there's not, from what I found, and a simple solution such as, every time I say simple solution, I think of like the cleaning stuff. But in this situation, you can easily convert an array to a list, but there's not the equivalent to take a list and convert it to an array. Kind of lame sauce, but whatever, we're going to make our own sauce. So my strategy, pretty brute force. We're just going to iterate through the elements and add them to an array. So we're going to create an integer array. We'll call it grades. All grades dot size. Simple as that. Then we're going to use a for loop. We'll say int I is 0. We'll go until I is less than all grades dot size, and we'll increment by 1 each time. Then we'll access grades index I, and we'll assign it the value all grades dot get index of I. And at the end we should have grades being an array with these elements. So we'll do a sys out, and then we'll say arrays dot toString and pass in grades just to see the entire array. Run this and you can see that's exactly what we get. So that's my solution. Let me know if you guys have a better solution in the comment section below, and I'll see you in the next one. Hi y'all, I just wanted to make a quick reference video teaching you how to use the tools available to us in Java to sort a list. So all you have to do is say collections dot and then type in sort, and you see there's various options here. We're going to go with sort down here, and we'll go with the first one. So all we have to do is pass in the list, all grades. Now hovering over the method, you can see it's void, which indicates you do not need to assign this to another variable. It's going to change the original list. And then we'll just print this list, make sure it's going good. Int grade from all grades. And then we'll do a sysout and we'll pass in grade. Run this, see what we get. We get 2, 3, 3, 5, 6. And you can see that is in fact sorted. So 2 is the lowest, then we get 3, 3, and then 5 and 6. Now there's actually a method to reverse if you want to put them in the opposite order. So that's just collections.reverse, pass in the list. And there we go, let's run it. And you can see now it's going descending order from greatest to least. So thank you guys for watching. Hopefully that was helpful for you, and check out the next video because we're going to go in person, talk about some new concepts, and it should be pretty fun, so check it out.
Hey, welcome back everybody. This video is going to introduce object-oriented programming, and essentially this is the table of contents of what we're going to be talking about in the upcoming videos. So we're not going to get super deep in this one, but in the upcoming videos you better get ready because it's going to be awesome. All right, so first thing, what is object-oriented programming? It's basically a way to design our programs into what are known as objects, and also we have classes. So those are two keywords you should know, objects and classes. Now we're going to talk about the difference between those two in the following video. This video is more focused on the why of object-oriented programming. Well, right now we're working with very simple programs, and usually we have to pretty much type out exactly what we want to happen. And if we wanted to create a larger application, we're eventually going to run out of willpower to keep typing every exact step that we want to happen. We've learned about a couple of techniques to make it easier on us. So we've learned about loops to basically repeat a process over and over again. And we talked about branching to go different ways. And we've talked about collections, which make it easier to store data. But all of these are just the basics. What really helps us is objects. So an object is basically a structure to represent something. So you can think of a car as an object. You can think of a file as an object. You can think of a person as an object. And basically we're going to learn how to create code that makes it very, very easy to create these objects. So if we wanted to write code for 100 people to represent 100 users or something, we don't have to manually create every single one by ourselves. We can do this programmatically. Now, if that doesn't really make sense, that's fine. We're going to get through all of the concepts in the upcoming videos, and then we're going to get hands-on creating our own classes and objects. This is usually a tipping point for people where they either decide to go all in and learn the material, or they back off and say, hey, this stuff is not for me. I'm going to encourage you guys to push through. This is one of those things where it can be challenging up front, but once you understand it, you can look back and be like, wow, it makes so much sense. Kind of like when you're super young and you're learning how to multiply. You're probably like, why do we need this when we could just add numerous times or something like that? But we don't realize the value that multiplication brings. I literally remember a conversation I had with my neighbor where he explained he was learning multiplication. And at this point in my life, I've never even heard of multiplication. And I was just so annoyed because I was like, ugh, there's more after addition and subtraction. Like, what are we ever going to use this for? But now looking back, I understand it much more. It's probably a terrible illustration, but object-oriented programming is similar in nature, and that once you get past the concepts and understand what you're doing, you can realize the value of it and how every single thing we do in coding is going to use object-oriented programming, at least in the tasks we're doing in these series. There are other paradigms of programming. So for example, there's functional programming, which kind of organizes things into functions. This is object-oriented programming, so we organize things into objects. So hopefully that's your good million-foot view. Now we're going to zoom in into like the 1,000-foot view and learn about classes and objects. So stay tuned, be sure to check out that next video and hit subscribe. I'll see you then. Peace out. Hey, what's going on everybody? Welcome to your video on classes and objects. This is the concept video. We're going to cover this material and then a couple of other things on object-oriented programming before we go hands-on and code this material on the computer. So if you're looking for the hands-on version, zoom ahead a couple of videos and you'll find that. But for now, let's just learn the concepts, try to get a good understanding before we type stuff out. Now in the previous video, I talked about what object-oriented programming was for. Well, it basically allows us to create very large applications without having to code everything manually by ourselves. So the way this works is we basically have a blueprint for how something might look. So for example, if we wanted to represent a person or some kind of user in our application, let's say we wanted to represent me. You might describe me and say, wow, he has stunning good looks, he's brilliant, he's hilarious. These things are going to basically be attributes that describe me. But now, if you wanted to build an application that supported tons of people, you don't want to have to go and figure out how to structure each person using basically a bunch of different variables. So instead, we create a blueprint for what a person might look like. So for example, a person might have a name and they might be able to talk. Well, we can represent these in code, so name can be a variable, talk can be a method, and we're basically defining the structure. And this structure is what's known as a class. Now, if we wanted to make numerous people, all we have to do is, quote, instantiate this class. So instantiate's one of those words you can use when you're hanging out with friends to impress them, pick up the chicks, etc. So make sure you remember this word. It'll help you. And this process will create what's known as an object. So the class is the blueprint. The object is going to be a specific example. So for example, we have Caleb. That's one object. We can make another one. We have Emily. And another one, Charles. So the class allows us to make numerous entities that are very similar. And this might seem weird at first, but literally everything inside of Java is going to be based around this object-oriented programming paradigm. So a user might be a very big object, but we can go down very small. Even a string is an object. So at some point, a string class was created, and we instantiate that class to make numerous string objects, which might have a specific value of, hey, what's up, or hello world, whatever it might be. The class is going to be defined inside of a file. The objects are going to be created as variables. So we might do something like this. We might say person X. We're basically creating a variable with the identifier or the name. This is the name, it's how we reference it. So this is the equivalent of saying int X. The person is the type. So we're essentially creating a new type. So this is a custom type. We create a variable of that type. We can create methods that have parameters of that type and so forth. So I'm going to be explaining how to do all of that throughout these videos. But for now, all you need to understand, the three things. Class is the blueprint, the structure. It's the cookie cutter. An object is an instance of that. So taking that cookie cutter and making 3 cookies. In this situation, we made people, we made Caleb, Emily, and Charles. And the third thing you need to know besides classes, objects, is that when we create a class, we're essentially creating a custom type. And we instantiate it by making a variable of that type. So lots of information, so write it down, watch this video until you understand the concepts. And if you got it pretty well, later on when we code it out, it should be pretty easy to solidify it in your brain. So thank you guys for watching. In the next video, we're going to be talking a little bit more about what you might put inside of a class. So stay tuned, be sure to subscribe, and I'll see you then. Peace out. Hey, what's going on, guys? Welcome back. This video, we're going to be talking about fields in Java. So what in the world is a field? Well, it's just a variable inside of a class. So for example, if this is a class, we'll just say this is a person class. We have this name here. This is an example of a field. So a field is literally just some variable that we can assign a value to it. So when we instantiate this class into an object, we can assign a value to this field such as Caleb. So this is a specific value that's given to this field. So to put this into context, when we open up a Java application, it might look something like this. You might have some class called MySweetProgram, and inside of here, you're going to have a main method. So it's going to look something like that. And inside this main method, we can create a variable. So we can say int x and we can assign it some value. But we can also create a variable outside of this method up in the class. So when we create variables inside of the class, but not inside of a method, they're known as fields. So we can go in here, we could say public int test is equal to 5. And now this variable is made accessible everywhere inside of this class. So if someone were to make an instance of this class, so they made an object of this field would be available to them, and it would default to the value 5. So let's translate this back into something we might create custom. All right, so we're back to where we began. We have this person class, and we have this name field. When we instantiate it, we're going to have a person, and this name field will have some values such as Caleb. So let's say we created this person like so. So we say person me equals new person, and then we put parentheses at the end and a semicolon. So that is how we would create this person. Then we can access that field by saying me dot name, and we can assign it a value such as Caleb. So that is how we would do something such as assigning Caleb to that field. All right, so that's the basics of fields. Now, just a minute ago, you did see the public keyword. What we're gonna be talking about in the next video is what that keyword means and how it's different than another keyword, private. So check it out because it's definitely important if you want to start working with fields, methods, and all that stuff. So check it out and subscribe. Hey, what's going on, guys? Welcome to this video. Today we're going to be talking about two important access modifiers, public and private. So hopefully by the end of this video you have a pretty solid understanding of that and what that means in the context of creating our own classes. So yeah, let's get started. Okay, so where do we even begin? Well, we talked about fields in the previous video, which is pretty much just a variable, but it's at the class level. And each instance of that class can assign a value to it. So not every object has the same value for that field. Going back to the same example I've drawn like 5 times now, we might have a person class, and one of the fields in here might be name, and let's just say it's a string name. So we give it a type and we give it a name. When we instantiate it, let's say we do it twice, we create 2 objects. Each one can have their own name. What? So yeah. It's pretty cool. So we could have an object down here where me.name is equal to Caleb. We could have another object where you.name is equal to nerd, and so forth. So again, this is just the blueprint. We're saying, hey, each person should have a name. So hopefully by now you understand fields, a little bit how they work, but there's a key word that you might need to know about, and that is public. When you create these fields, you might prefix them with the keyword public. So it'll look like this. But if they're private, we can do something really cool. So let's say this is private. Well, now we can use this variable inside of the class, and it's no longer accessible out here. So if we need to keep track of something inside of our class, that's how we do it. For example, we might define some method, a function, to work with some data, and we might need to store that data somewhere. We can store that data inside of this field. It's private, so we don't have to worry about anywhere else messing it up. So a common way this is used is with getters and setters. So basically we can have this private field and we'll call it name. So basically this is just a visual representation of this, and we can create methods called a getter and a setter. And what these do is basically gate access to this private field. Because these are going to be defined up here, they can access this name. And they can basically control how much access you get to this private field here. So we have a getter method, which will allow us to get the information and get it over here. Then we have a setter method where we can pass in information to change that field. And we can customize these to do different things. Maybe we can only get it a certain way, or we can only set it to certain values. That is one example of what you might use private fields for. It allows us to have more structure and more control inside of our class. So you can kind of think of it like this. We have some object. We'll just call him me. And there's public stuff that's accessible outside. But then there's also internal stuff, private stuff, that might be useful, but isn't necessarily there for everybody to use. You can think of those as just kind of hidden in the background, like so. We can't access them from the outside, but we can somehow do that through these other methods, which, for example, the getters and setters would do. So we can access this one from right here. This is getting very like theoretical, so maybe I'm getting a little bit too far from the point here. The point is, private is only going to let people access that thing through methods to get to it, or it can be accessed inside the class definition. So we'll see that in practice when we get hands-on after like the next video, I think. So stay tuned. In the next video, we're going to be talking about methods, which basically define what our objects can do. Very important. Make sure you go check that out, and I'll see you then. Peace out. Hey, what's going on, guys? In this video, we're going to be talking about methods when it comes to object-oriented programming, how we would create something like that, and so forth. So stay tuned. All right, so we talked about creating objects in the last couple of videos. Maybe you're just jumping in, so let me just give you a quick crash course of what we talked about. Very quick. We might have some class, and this class can have fields, such as a name, and it can also have what are known as methods, which basically define some behavior or something that each object can do, such as, and you would invoke this with parentheses when you use it. So how would we define something like this? Well, inside of a class, this is our class structure. We would create this in some file. We would create a method, and it might look like this. So right now we have an empty method. We say the return type. So this is going to give us back a string. We give it a name, such as talk. We put the parentheses, which is where we would put any parameters. So anything we expect to get passed in as input as arguments. Then we open and close the body, and our code goes here. So this might look like this. We can say return to basically give that string as an output. So we can say, hi, I'm, then we can end the string with a space there and say plus name. And this name here is going to come from that field. So that would be defined probably right here. I'll just do it real small. Public string name. That's really small, but that would basically return when we call this method. So this is how we would define something like this. But let's talk a little bit more about using it, because that's a little bit more important for what we're going to be doing at the beginning. So we define this person in code like so, and then we can use it like so in another method somewhere else. We create a new person like so, and then we set a value for the name, and then we can use this method. And it's going to return a string, so you need to do something with that. So for example, you could output it. So you can write all the system.out junk, but I'm just gonna put ... and then say me.talk. So this method will return, hi, I'm Caleb. And we can do whatever we want with that string. You could output it, you could pass it to another method, whatever you want. So that is the basics of methods. There's variations we're going to get through. So for example, static void main, that's the main method that everything is executed from. We haven't talked about static, but we will be getting into that. But for now, all you really need to know is that methods allow us to do something. It's where we can put calculations and so forth. We'll also use methods to basically gate who can access our fields. So eventually this field name here, we'll probably make it private, and we'll create methods to access it. So just like this one is accessing name here, that's still going to work because it's defined within that class code. But out here, we couldn't assign a value to it here. So we'll talk about how to get around that and so forth. So thank you guys for watching. Be sure to check out the next video because we're gonna get hands-on with the stuff, and I'm pretty excited to start coding because my shoulders hurt and sitting and typing is a lot better, so not really. Peace out and subscribe.
Hey yo, what's going on everybody? This video is the start of building some object-oriented programming code. We're just going to create a class and we're going to make an instance of that class. So very basic stuff. We'll get into more as we go on in these videos. So next video we'll talk about fields, then we'll get into methods and so forth. So what you want to do is over here on the left in this microscopic text, right click your project and click Add New Class. Here we can name it whatever we want. I'm going to go with user with a capital U. And with the methods down here, you do not want to check public static void main. When we created our application, we did, but we don't want to do that for our custom types. That's just for the starting point of the program. So click finish. And there you go, you created a class. Nice and easy. Now this is essentially a custom type. So that means we can create variables of this type. And here's what that's going to look like. We'll go into our code, and inside a main, we'll just say user with a capital U, give it some name, such as user with a lowercase u, and then we'll say new user. So anytime we want to make an instance of a class, also known as an object, we use the keyword new, followed by the name of the class in parentheses. This thing here is known as a constructor, and we'll get into creating those later on in this series so we can customize it, make it a little bit more useful. But for now, this plain one is fine with just the parentheses. We don't have to pass in anything. In Java, everything is organized into classes. You can even see right now we're working in a class called MySweetProgram. And this here is a method, which we'll talk about making those here really soon. We essentially created a custom type similar to int or string or whatever it might be. And we can start building stuff around this type, so we can take user as an argument, we can return users, we can do calculations on users or compare users. The possibilities are endless, and I'm really excited to start building stuff out. So be sure to check out the next video, because we're going to talk about fields, also known as class level variables. So it should be pretty fun. I'll see you then. Hey guys, welcome back. So we created this class, this user class, and we're creating an instance, which is known as an object, and storing it in this variable called user. So that's what we've learned so far. But now what I want to do is I want to create fields inside this class. So go back to our class, and what we're going to do is we are going to create a first name, and we're going to create a last name, and we have to give them a type. So prefix this with public, and let's go with string. And that with a semicolon, and do the same thing for the last name. Just like so. Now we do not assign values here at the class level, we assign them at the object level. We're just defining what things can be stored for the user objects. So going back to our code, inside a user, we can say user dot and see everything that's available to us. Two of them we created ourselves, first name and last name. So we can assign values here. So we can give him a first name of sub and a last name of scriber. That's you, right? So that is how we create fields. You can notice they're just like variables, but they're defined at the class level. It's a little bit different than right here where we created these users. This user here is defined inside of a method. So this is not a field. It's not a class level variable. This is a local variable to this method main. But for us, inside of the user class, we're putting them right in the class. And that is how you work with fields. They are just like any other strings in this case, so we can do a sysout and just put in user.firstname, and that should show up in the console, and it does. So thank you guys for watching. Check out the next video. We're going to be talking about methods, so it should be pretty fun. Hey, what's going on guys? This video, we're going to be creating our first method. So what we're going to do is go into our user class and define it here. So hopefully you're excited. I am, that's for sure. I'm always excited for this. It's pretty awesome that you can just create stuff with code. I mean, I just get so excited about that. So hopefully you guys do too. So to create a method, we're just going to go down a couple lines and we'll say public void, and we'll give it a name. We'll just call it output. And in here, we're just going to make it output the person's first name and last name to the console. So we can just say sysout, pass in first name plus a space plus last name. From the caller, we can show you how to execute this method or invoke it by just going user dot, and you can see it in here. If you scroll down, we got output right there. Click that and you're good to go. When we run this, you can see we get subscriber in the console. In the next video, we're going to be talking about arguments and parameters, so how we can basically customize the method to do different things. Very cool. Go check it out right now, and don't forget to subscribe. Thank you everyone. Really appreciate the support. Welcome back everybody. This video, we're going to be talking about arguments and parameters. So we have this custom method here, user.output. All it does is output the person's first and last name to the console. Really nothing special. We probably could have just did that ourselves here. But as we build out more complex methods, they're going to save us a lot of time. For example, if we wanted to output the person's first and last name numerous times for some reason, or we wanted to do some action numerous times, we could make a method to take that as an argument, and then it'll do it that number of times. So let's say we wanted to output it 6 times. Well, when you do that, you can see we get an error. And we have a couple of potential fixes. One of them is change the method, output, and add a parameter int. So I'm going to click that, and then in our user class, you can see it added that parameter I. I don't really like that name because I'm going to create a loop, and I usually use I for the iteration variable. So I'm going to change that to times. Now we're going to create a loop in here. For int I is 0, I less than times, I plus plus. In this loop, we're just going to output this. Very simple, but it saves us from having to write the loop in the calling code, and it doesn't pollute this as much, so it's a little bit cleaner. Executing this, you can see we get this numerous times in the console. And we can pass in different numbers, so it's very dynamic. We can pass in a 2, and you can see it only writes it twice. Now, so far, this method is alright, but it's not amazing. One of the reasons I don't like it is because it's outputting it to the console, but we might not want to do that. We might just want to return the value, and what that means is how can we get whatever this is calculating, this string here, how can we get that over here? That's where the return comes in, and that's what we're going to be talking about in the next video. Returns are super important, and you'll want to check it out. Hey, welcome everybody. This video, we're going to be talking about return statements. So specifically, we have this method in this class we created, and it's just printing to the console. And although that works, sometimes we're not going to want our code to just pollute the console like that, because we want to make the most versatile methods. Therefore, we should probably just generate some fancy string and give that back to the caller. Then the caller can decide if it wants to output it to the console, write it to a text file, or use that in some other expression, or whatever. We don't just want to assume they want to write it to the console unless we make it super clear in the title, such as output to console, or something like that. So what I'm going to do is first, I'm going to clear this off. We're not going to need this loop anymore. I'm just going to make one output. And I'm going to make it a little bit cleaner. So I'm going to say something like, hi, my name is, and put a period at the end. And I forgot a plus sign. Make sure you put plus signs between everything to concatenate. You can also bring it down to the next line if you need, like that. Now, instead of outputting this using print line, we're just going to get rid of that method call, and we are going to say return. This is going to yell at us, right? Because it says void methods cannot return a value. That's what this void means. It means that the method is going to do something for us rather than returning the value back to us to do something with it. So if we want to do a return, we need to say what type of data we're returning, such as a string, which is what we're doing in this case. By the way, I got some kittens and they're in the background freaking out and fighting and smashing into stuff, so apologies if it's distracting. Now that we clearly stated that it's returning a string, it looks happy. We're getting a little issue down here. Let me just take a look at it. I think I just have an extra curly brace somewhere. So this needs to go here, and then this here, and then that's gone. Sorry about that. Let's clean this up. Beautiful. Now, from the caller, here's how we're going to use that. We're going to get rid of that number there, and we're going to assign this to a string, like so. Then we can decide what we want to do with that string because we know it's just a string variable. We can do whatever we want. Wherever string would be expected, we can pass this message. But just because it's nice and easy, we'll put this out to the console. Just pass message in there, run it, and there we go. So this is much more dynamic, and now you probably have a pretty good understanding of return statements. Now, there is one other thing, and that is if you have a method that is void, you can still use return, you just can't return a value. What return will do is it'll just exit the method. So if you need to end the method, you can use the return keyword. Thank you guys for watching. Check out the next video because we're going to start talking about encapsulation, which is a key piece of object-oriented programming. And that's where we're going to get into getters and setters. I'm super stoked. Hope you are as well.
Hey, what's going on guys? Welcome to another in-person video for your Java series. We're going to be talking about encapsulation. As we go through some of this object-oriented stuff, I want to occasionally jump back in person just to talk about a concept face to face, or face to camera in this situation. But anyways, by going through the concepts when we start coding, it'll make a lot more sense rather than just typing but really not having any idea what you're trying to accomplish. So the in-person videos will help you get that concept down, and then we'll go into hands-on and code it out. So encapsulation is one of the three big pieces of object-oriented programming. We got encapsulation, we got inheritance, and we got polymorphism. And we're going to talk about each one of these in the rest of these videos. But we're just going to focus on the first one, forgot what it was for a second, encapsulation, which the whole idea of this is to hide the inner details of something. So we can basically encapsulate something, that way not everything is exposed to the whole world. And the biggest place you're going to see this is with class level variables. So let's say we have a variable. You may also hear field or various versions, but essentially we created a variable at the class level, not within a method. So this is going to be accessible all throughout the class. When we instantiate this class into an object, we can assign values to this. So for example, if we were working with users, we might have a first name variable, and we might have a last name variable. And then when I create a user for me, I might say Caleb and Curry for those variables. So we can encapsulate this, and the way we do that is with two types of methods known as getters and setters. So we have a getter method and a setter method, and now consider us over here. And we want to work with this variable. If we want to get that value, we have to go through the getter, and then it'll give us the value back. If we want to set that value, well then we need to go through the setter, and it'll update that value. The benefit here is that inside of these methods, we can do some fine-grained customization or determine how the variable will be returned, or determine what kind of valid values can be assigned to this variable. That is the essence of encapsulation, and you're going to see this concept all throughout computer science, not just at the fine-grained detail of a variable. If you think of a concept in general, you can apply encapsulation to hide the inner workings, and you can swap out that inner workings without affecting the interface for working for it. So to see that, you could basically envision changing this structure to a circle instead of a square, and the actual part over here doesn't change. I'm still working with the getter, I'm still working with the setter, but the structure behind it changes. So that's another example of encapsulation at a bigger level in computer science. But next video, we're going to be creating some getters and setters, so go check that out and be sure to subscribe.
Yo, what's up everyone? This video, we're going to be talking about creating a getter method. So, this is the basis of encapsulation. We're basically adding another layer to getting values from these fields. So take a look at our custom class here, this user class. Inside of this class, we have these fields here, first name and last name. Right now, they are public, and what that means is we can assign a value to them directly, such as user.first name, or whatever we name the variable. Although this works, I'm not saying it's a terrible idea, it just depends on what you're doing. In some situations, you're going a little bit more control, and that's what I'm going to be showing you guys how to do in this video and the next video. We're going to create the getter here and the setter in the next one. So let's go to our class and I'll show you how to do it. So we're just going to create a method, and this is going to get the value of a field. So we're going to call it and expect to get something in return. Keyword return. So we need to make a return statement that's going to give us the value. That means we need to put what type it is, and because we're going to be grabbing a string, that's the return type. So we'll say public string, and then by convention, we'll start it with get, and then we'll just say first name. And I'm using camel case here, so first letter lowercase, then each word uppercase. Parentheses, and set of curly braces. Now, do we actually have to pass in anything as an argument? No. So we don't have to define any parameters. We just ask for the name and it's given back to us. And then the code here is actually really simple. We just say return first name. Put a semicolon and it's happy. So now we can change this public to a private, and we can get that value through this method, which is public. So it's basically blocking access. It's not doing anything fancy here because it's literally just getting the value and giving it to us, but we can modify it. So for example, I can say to uppercase, and that's going to give us the value back in all caps. But we have one issue here. There's not an actual way to assign a value to the first name. So in our calling code, we're going to have an issue. Hovering over this, it says the field user.firstname is not visible because it's private. So what we're going to need to do is we're going to need to create a setter, which is another method similar to the getter, just a little bit different. So go check that out. It should be pretty easy. I'll see you in the next one. Hey, what's going on, guys? This video, we're going to be creating a setter for our field. We have this first name. It's currently private. There's no way to assign it a value from the calling code. Taking a look at our program, you can see we get this error. So I'm going to be teaching you how to fix that and how we can assign a value to it in a more controlled manner using a setter. All right, so let's create that setter. It's going to look a lot like this getter, but a little different. So we're going to say public. Now, what is this going to return? Well, we're going to give it a string to update this first name. So we're providing an argument. We're not getting anything in return. So this is going to be void. And by convention, it's going to start with set and then first name. Now here's where we need to focus because we need to take the string as an argument, which means we need a parameter here of type string. Give it a name. It doesn't really matter. We'll just say FN for first name. Inside of here, all we got to do is assign that value to this field. So we can say first name is equal to FN. There we go. Now back in our calling program, let's see what we do. In order to set this value, we no longer just use it directly. We actually use that method. So we put user dot, and you can see it in here. We have set first name. We pass that value in as an argument. So we say sub. Getting rid of that extra junk there. There you go. Now we can get the name the same. So to see that, we'll just do sys out user.get first name. Running this, you can see it gives us sub in all capital letters because that was one of the things we defined inside of the getter. Taking a look at that, you can see it says return first name dot to uppercase. So really, we have a whole new level of control here. We can modify the parameter passed in however we want and control what values can be assigned to this first name. So for example, we can do casing in here. We can say, hey, if this value is this, then you actually need to store this. So I hope you guys can see the value in the getters and setters. If you're just working with very simple classes, then you might be fine just having public fields and just accessing those directly. Now we're also going to want to do a getter and setter for this last name. So we'll do that now. Return last name. And then we'll create the setter, public. So let's give it a try in the calling program. We'll say user.set last name and we'll pass in scriber. And then we'll also pass in a space and user.get last name. And there we go, we get subscriber just like that. So that's working with setters. Hopefully that was nice and helpful. In the next video, we're going to be creating a custom getter and setter just to get a little bit more experience with it. So see you then. Hey, what's up guys? Welcome. The purpose of this video is to get a little bit more experience with getters and setters. Now, one really useful purpose of getters is to basically combine various fields from a class and give it back as one value. So an obvious example here would be to take the first name and the last name and combine it into a full name. So that's what I want to do. So let's hop over to our user class. Here's what we got so far. We got two fields here. We can actually label this one as private now. And then we got a bunch of getters and a bunch of setters. I guess just two getters and then two setters. So nothing too crazy. So what I want to do is I want to go down here and add a new method. This is going to return a string and it's going to be called get full name. And it's real simple. All you're going to do is say return first name plus a space plus last name. And because we're in this class body, we can access those fields directly, even though they're private. That's why this works. Now I'm actually going to take this and put it near the top because I think that's a more appropriate place for it, right beside the first and last name, like so. So we can see it right there. Let's try this out in the calling program. So getting rid of this line here, we'll pass it into the system.out print line and just say user.getFullName. Executing that, we get the same value, subscriber, but do note that originally sub was in all capital letters, and the reason that is because the getter for first name was doing a 2 uppercase. When we do this get full name, that's not happening, so you need to be careful. So if you want to be more strict about how these are accessed, what you can do is you could actually use only methods in your methods as well. So you could say get first name and invoke it like so. Executing this now, you can see sub is in all capital letters. That is a safer and more appropriate way, so that way we make sure our own class doesn't violate rules. This method and this method is doing almost exactly the same thing, but I'm just going to end up keeping both of them. We might go back and clean this out, but for now, we're just going one thing at a time, and I think we're on the right track. Now, there is some general filtering you can do for a set, so if you want to customize the set, you can. So for example, you can say fn dot. This is going to get rid of leading and trailing white space. So if there's a bunch of spaces before or after, that's going to get rid of them. So that's one way you can clean it. And you can also modify how it's stored if you want to store everybody's names as uppercase or lowercase or whatever. Probably not recommended for names, but maybe in the situation of email addresses, you might want to do all lowercase. So we'll just do 2 lowercase just to see how it works. And now when we run this, you can see we get sub still in uppercase. So basically it's being stored in lowercase, and then when we get that first name, it's actually being converted back to uppercase. So we're basically able to store it however we like, and the presentation can be however we like as well. So another situation, maybe you're trying to store phone numbers, and internally you wanted to store them as 10 sequential numbers as an example. But when you output them on the screen or give them to another method, you might want to put in dashes or some kind of formatting. That's what you can do with getters and setters. Thank you guys for watching. Be sure to check out the next video. I think we're going to be talking about something. I think we'll create an array list. Yeah, we're going to work with the array list of custom types. So that'll be pretty fun, and it's going to be essential as we get into more advanced programming. So check it out and be sure to subscribe. Hey, what's going on everybody? Welcome. This video, we're going to create a list of a custom type. So check it out. We have this custom type user. We can use that like any other type. So specifically, if we're working with a list, a generic where we have to put a type in here, we can use that custom type. So we can just say user. Give it a name such as users and say a new array list of type user. Like so. Make sure you import from java.util and import list from java.util. Now all you gotta do is say users.add and pass in our custom object user. So make sure you got all your names clear here because it can be really confusing if you're not paying attention. The uppercase, that's the class, that's the type. Whenever we need the type, we put it there in capitals, the capital U. The lowercase is the name of our variable. We can name it whatever we want. And then lastly, users plural is the list. That's all of the users, and currently there's just one user in that list, the one we just created. If it helps you, change some of the names. We could change user to just you, or you could call it me or person, whatever you want it to be. Just make sure you're clear. So what I'm going to do is I'm actually going to call this user you. Make sure I update all of the references to this variable, and then I'm going to create another user. So we'll say user me, set it to a new user, and set it some values. me.setFirstName, pass in Caleb, and me.setLastName and pass in Curry. Beautiful. We can add this person to the list as well, so we can say users.add, pass in me, and we can access these users real easily by using indexes. So we can say users.get, pass in an index such as 1, that's going to be me, and because this is typed to a user, we know what methods are available to us, so we can press dot and see them all here. So for example, we'll just get full name, and we'll put this entire thing inside of a sysout. There you go. Run this and you get Caleb Curry. So that is how you work with lists of custom types. That's going to come up a lot, especially when you're doing stuff like polymorphism. So make sure you understand how to do this, get the syntax down a little bit, and yeah, check out the next video because we're going to be talking about some loops probably. So we'll see. See you then. Hey, what's going on, guys? This video, we're going to be talking about working with loops and custom types. So specifically, we have this users list, and I want to talk about how we can basically add users to this list inside of a loop. So if you're reading from a file, or you just have a bunch of users you want to create and type in their values from the console, whatever it might be, it's going to help you a lot if you have a loop and you don't have to type out everything like so. So what I'm going to do is I'm going to get rid of these users here, get rid of these users.add, so we can just start with a fresh empty list. Get rid of that system out. All we have right now is a list, but we're also going to add in here an array of names. So this is going to be a string array, and we'll have one for first names, and we will also have a string array for last names. This is going to be assigned some values, throw some in here, like so, and we'll also do the last names. All right, so we put some data in there, and this is kind of assuming we read this from a file or something and put them inside of this array, but we don't always know these values up front. So assume we've read these data from a file or something like that. So now what we're going to do is we're going to create a loop, and in here we'll say int I is equal to 0, I is less than first names dot length I++. So that'll iterate through each element, and we can do whatever we want. So what we're going to do is we're going to create a new user, and then we're going to assign some values. So u.setFirstName, that's going to be first name's index of I. We're going to do the same thing for the last name. We'll say set last name, pass in last name's index I. So we're basically converting a bunch of string data into objects, which is much easier to work with in code. Last thing we're going to do is just add this user to the list. So we'll say users.add, pass in u, and we should be good to go. Once we're done, we can output all of the elements. So we'll say for, and this time we'll do it for each. And what I want to do is I just want to print their full name. So we'll say u.getFullName like so. Well, that's a lot of code, but let's see what we get. We run this and you can see we get each person out on the console, but the beautiful thing is that this data came from objects rather than just strings. So it's much structured and much better. So thank you guys for watching. Check out the next video because we're going to be talking about taking custom types as arguments, which is super handy. You won't want to miss it. I'll see you then. Hey, what's up everyone? This video I wanted to talk about how to pass a custom type as an argument. So if we wanted to create a method that would accept a user object, that's what we're going to be talking about in this video. So we have some code from previous videos. Don't feel like you have to have all of this if you're just jumping in. The main thing you need is some custom type. In our case, we have this user class defined in this extra file over here, and it has some methods that will get these fields. So you can copy some of that if you want, but the main thing is I want to go over in our code and create a method to take a user. So it's going to go outside of this main method. We'll say public void, and you can give it a name for whatever you want. We'll just call it print user. And now for the actual parameter here, we want it to be of type user and give it a name. Now inside of here, we can reference this user object. So we can say u.getFullName, and we can output this or do whatever we want with it. Now because this method here is defined within this class MySuiteProgram, we actually have to make an instance of it. That's because it's not static like this one up here. Now we're going to be talking about that in the next video, so you'll definitely want to check out how to turn this into a static method of the user class. Once we understand the static methods, it's basically a way to organize our code a little bit differently than just putting everything in this MySuiteProgram file. But for now, we're just going to keep it here so we can show how to instantiate this class and invoke this method. So all we really have to do is say MySuiteProgram, give it a name such as M, and say new MySuiteProgram. Like that. And then we just say m dot print user, and then we can just pass in some user. So if we created some user earlier, we could pass it in. So we have this list of users. We can just take one of those users. We'll just say users.get and pass in index 0. Execute, and you can see we get Caleb Curry at the top, and then we get Caleb Curry at the bottom, which actually came from this line of code right here. So that is how you create a method to take a custom type Now we're going to get into static methods and learn how to take this method and put it as part of the user class. So go check out the next video because we're going to get into the concepts for that, and I'll see you then.
Static methods. So the whole idea behind something being static is that it's attached to a class rather than an instance of a class or an object. So by the end of this video, you should understand the concepts, and then we'll get in the hands-on in the next one. So when you visualize object-oriented programming, you might think of something like this. You have a class, and then you make instances of this class, which are known as objects. When you define a method in the class, every time you instantiate this class into an object, that method is made available. So for example, you might have a user class, and one of these methods might be talk, right? And that's going to basically do an output saying the person's name and their information or something like that. So how would you do that with an instance method? By the way, an instance method is kind of the opposite of a static method because it's attached to the instances. You would do something like this. You would create an instance, call it u, and then you would say u.talk. It's on the instance, so one particular object. A static method, on the other hand, would be on the class directly, so it would look like this, where we say user, the class, dot, and then put the method directly there. We don't have to do it on an instance. So that is the difference between a static method and an instance method. Now in the next video, we're gonna get some hands-on creating static methods, so go check that out. Should be pretty helpful. And don't forget to subscribe.
Hey, what's up everybody? Welcome. This video, we're going to be talking about how to create a static method. Static methods are a little bit different because we call them on the class directly. So for example, we have this print user method. If this was a static method of the user class, we would invoke it like so, user.printUser. Notice we're using the class here, and then we're putting that method directly. We're not calling it on an instance like we would for setFirstName, where we have to create a new user and then use that identifier followed by the dot. Nope, we just call it on the class directly. So what I'm going to do is I'm going to cut this method and go to the user class. And I'm just going to go to the bottom, paste this in here, and then just add the static keyword. So some key differences: if you were to put this as an instance method, you would not need to take in the user as a parameter because you could access the properties directly using getFirstName or setFirstName. So if this was an instance method, it would probably look like this. So pretty similar, the only thing is you get full name directly and you don't have that parameter. Whichever way you want to do it, that's totally up to you. On occasion, static methods are going to be more appropriate, so we're just going to get some practice making those now. So let's get rid of this here and let's work with the static version. Over in our calling program, all we have to do is pass in our user to this print user method, like so. We can get rid of that stuff from earlier. Oh my goodness. No one literally talks to me ever. As soon as they start making videos, it's like, oh, I think I'm going to text Caleb. All we need now is a semicolon. Executing this code, you can see that it works. So when to use a static method? Well, if you have something that's generally related to users, but not a particular instance of a user, that's when you might want to use a static method. So in this situation, static's not probably the best because we're only working with one user object. So we could just use an instance method. But we might want to make something that works with numerous objects of type user. So that's what we're going to be talking about in the next video, where we're going to create a static method to work with a list of users. Then a static method might be a little bit more appropriate. So let's change this to take a list. We'll do that in the next video, so stay tuned. Hey, what's going on everybody? Welcome to your follow-up video on static methods. In the previous video, we created this static method that just prints a user, but this is not entirely super useful because we could just have this as an instance method like so, where we don't need the user parameter and we can call the method directly rather than calling it on the instance that was passed in. And that works, but when we're working with multiple users, we're not going to want this method at the instance level. We're going to want it at the class level because it generally is useful for users, but maybe not one particular user. So if you have no idea what I mean, let's just type it out and we'll see what I'm talking about. So we're going to change this static method to take a list of user. So prefix this with list and put user inside of the less than and greater than. We'll call this users. and we'll need to do an import. So hover over that and click import list from java.util, and that'll bring this code up here. Now, what I want to do is I want to iterate through these users. So we'll say for each user u, and this will come from users, all we want to do is write it to the output. So we'll just say u.getFullName. There we go. So we're getting the full name, and we can get rid of this one down here. All right, now this makes a little bit more sense because it's not tied to one specific user. So from the calling program, we can have a list of users, and we can invoke that. So let's create a new user. I'm going to call this one me, and I'm going to call the other one you. And then we'll just say new array list of type user. And then we'll say users.add, and we're going to pass in me. And we'll also pass in you so you can hang out with me. Cool, and now we can change this call. Instead of passing in one user, we can just pass in the entire list, users. And we'll probably want to change the method name to print users. So let's go do that right now. We'll go back into our code and put an S there. Let's invoke the code and see what we get. Run this and see Caleb Curry, Charles Null. That's because it doesn't have a last name. So you can do that. You can say set last name, but I don't know, I kind of like the last name Null. So we'll just keep that Null. We can really confuse people when they see null. They think it's actually null, but really it's just the last name. That's good coding practices. And there we go. So thank you guys. That is how we create a static method. Hopefully you have a pretty good understanding. You can kind of think of the user class as this bucket where we can attach different utility methods that we might use throughout our code. So it's really handy. And yeah, thank you guys. I'll see you in the next one because we're going to be talking about method overloading. Should be pretty fun. I'll see you then.
Hey, what's going on everybody? This video, we're going to be talking about method overloading in Java. So hopefully we can get the concepts down so when we start typing it out, it makes a lot more sense. So the whole concept of method overloading is that we can have the same method, but slightly different variations that have different parameters or a different number of parameters. So for example, let's say we had a method like this. So it's public void, doesn't return anything, and it has the name test, and it has one parameter, an integer x. Well, we could actually create a second version of this method that has a different parameter. In this situation, the parameter is of type string. Alternatively, we could create one that has multiple parameters. So for example, it could be int x, int y. And which method is invoked depends on how we invoke the method. So for example, we could say test, pass in a 5, and that's going to call this version because it matches. A 5 is an integer, this one takes an integer, it's a perfect pair. This one on the other hand takes a string, so if we did this and passed in 5 in quotes, it's going to invoke this version. So although the body of the methods might be very similar, the different inputs allow for the method to be more general. It allows it to accept various inputs and still function. Still function, that's kind of funny because methods are functions. Anyways, one thing you should know is that the return type, that does not contribute to the method signature. And the method signature basically determines if the method is unique. These two methods have different signatures. But when it comes to overloading, having a different return type does not change the signature, at least enough. So if we had int here and int x here, you can see these are the exact same parameters. They have the same name, just different return types. This would not work. This would not be a valid overload. So you're going to need to change it at the parameter level. If you need to do something like this, just change the name of this method and don't make it an overload. You could have test returns void and test returns int, or whatever you want to do. So that's your introduction to overloading. In the next video, we're gonna get some hands-on work with that. So stay tuned and I'll see you then. Don't forget to subscribe. Yeah.
Hey, what's going on everybody? Welcome to this video. This video, we're going to be talking about a very simple example of method overloading. And as we go on in the videos, we're going to make it more complex. So stay tuned. So what we're going to do is we're going to go inside our user class and see that there's this method output. And it says, hi, my name is first name plus last name. Well, we're going to change this a little bit first off. First, we're going to use the methods that we created, get first name and get last name. That way we can always go through that gate to protect our fields here. And I want to make an overload of this like so. What I want to do is I want to make a version where the greeting is not quite as nice. So what we're going to do is we're going to take a Boolean and we'll call it nice. I always forget to make this Boolean. And then inside of here, what we're going to do is we're going to return a message. We'll just say something really rude, and then we'll just put our first and last name using get full name, which you could also use up here actually. So we'll just get rid of get first name and get last name and replace it with get full name, and then add a period at the end. I guess we can do that down here as well. All right, now which one of these will be invoked depends on if we pass in a Boolean nice. And since this is a Boolean, it's going to be true or false, so we could do a condition to say, hey, if it's true, we can say something really nice. If it's not true, we can say something really mean, just for a little bit of more customization. So we'll say if nice, what we're going to do is we're going to actually say something nice. Otherwise, we'll return something mean. So over in the calling program, we're going to execute this method. So we'll just say me, which is an object we created earlier of type user, dot output. And there's two versions here. So we'll start with the first one. This returns a string, so we need to output it or do something else with it, such as pass it to another method. I'm going to comment this print users out just so we clear out the console a little bit. And it says, hi, my name is Caleb Curry. Alternatively, we can pass in a true, which will be nice. It says, you are a beautiful person, Caleb Curry. And lastly, we can pass in a false, which will say you are a freak, Caleb Curry. So here you guys can see all sides of me, and hopefully I'm not like the freak one where I call you a freak. Alright, well thank you freak bags for watching. In the next video we're going to go into a more complex example, so stay tuned. We're going to start building a method to search for users. So I'll see you then. Hey, what's going on guys? This video we're going to create a method to search a list for a particular user. You can generalize this to searching a list for any custom object, but in this situation we have a user object, so that's what we'll be working with. So we'll go into our user class and we're going to make this as a static method, so I'll put that at the bottom and we'll call this search list, and we'll keep it void for right now. We'll talk about what the return type should be in a second. And inside the parameters, we're going to need a list of type user. We'll call them users. And then we're also going to need a first name and last name, so we'll make those strings. Now we're going to iterate through the list passed in. I'm going to use a for loop. So we'll start with I is 0, and then we'll have this go as long as I is less than users dot size, and we'll increment by 1. Then we'll say if, and we're going to basically do a condition to see if the user is a match. So inside the if, we'll say users.get index I, then we'll say get full name. Now we have two options here. We could concatenate the first name and last name with a space in between them to see if it matches, or alternatively, we could take a full name as a string. So it seems like a good opportunity for an overload, so why don't we do that? This one will concatenate. We'll say first name plus a space plus last name. And in this situation, we're just going to return the index. So since I is an integer, we need to make this int. Now we need to make sure we always return an integer, even if it's not a match. So in that situation, we're just going to return -1, which basically is a way to say it wasn't found. All right, now let's do an overload of this. We'll say public static int search list. This is also going to take that list, so list of type user called users, and then it'll take a string full name. Now there's no sense in recreating code whenever we can avoid it, so what I actually want to do is I want to take all this code and I want to cut it, not copy and paste it. I want to get rid of it in the other method and paste it here. And what we can do is we can actually invoke this overload from this method by just combining the first and last name. So all we have to do is say search list. We're going to pass in the users, so we're just moving it along. And then for the second argument, we're just going to say first name plus a space plus last name. This is all going to get concatenated, put a semicolon there, and this still needs to return. So once this is done, we need to do something with that value. So what we can do is we can just say return. So the order of this will be evaluated. That number is going to be then returned to the caller. So let's give this a try, just make sure our code works first. And we also need to update this a little bit because this is looking for first name and last name. So we'll just replace that with full name. All right, let's give it a try. Go to our code. We have this list with me and you in it. Now let's create a search request. So we'll do this inside of the print line and we'll just say user dot search list. We'll pass in our users list. And let's say we're looking for Charles. And we're just gonna change his last name so there's no confusion here. I was doing that as a joke earlier, but I realized it was a bad idea. All right, so Charles N. Run this, and you can see we get -1. So something's up. So what's going on here? I actually know exactly what's going on. Taking a look at our user class, at somewhere in here, we have a to uppercase. And we're also changing the first name to lowercase. So we're basically manipulating the casing. So we could do the same thing with the arguments passed in, or if it's possible, we can just clear this out just so everything is the same. Just so there's no weird confusion, nothing freaky's going on, and it should be good to go. So let's run it and see if anything changes. Still not quite. So yeah, I fell for like the most obvious trick here, guys. I even talked about this earlier on in the videos. We're doing a comparison using this, but as we know, that's not a valid way to do comparisons in Java. So we actually need to use .equals and then pass in full name. All right, let's try it now. I'm gonna comment those out and run this. And now we get the value we expected, 1. So the main thing I wanted to show you guys was the overloading, how we can basically call another version of the same method after we do a little bit of tinkering with the parameters by combining them into one. So hopefully that was helpful, and hopefully now you understand how to do a simple search by iterating through every single element and comparing some values.
Hey, what's going on everyone? In this video we're going to be talking about method overriding in Java. Now this is different than overloading, where I did a video on that a couple of videos ago, so go check that out if that's what you're interested in. So overriding is basically replacing a method in a subclass or a derived class. So stay tuned, it's going to be awesome. Let's get started. So in object-oriented programming, we can have an inheritance hierarchy. So imagine we have a user class, then we inherit this user class from student. Anything defined in the user class is going to float down to the derived classes. So for example, if we have a method work, these are also going to have this method work. So any teachers we create have the capability of working. I mean, I don't personally know if students can work or not, but at least in this diagram, they're capable of working because it's inherited from user. But what if we wanted the teacher or the student to have a different type of work? For example, the teacher might go do research or whatever teachers do, and students might go drink beer. So we can actually override this work method inside a teacher and student. Now you don't have to do anything fancy to override a method in a derived class. You just have to put that same method, so the signatures have to match, in the derived class, and it will automatically invoke the derived class version. Now inside a student, let's say we did not define the work method. If we created a new student down here and said student.work, it's not going to get that work method from the student class, so it's going to be getting it from the user class. So it's going to get the more general work method. So that's the whole concept of method overriding, basically derived classes giving new versions for methods that were originally defined in the base class. So hopefully that makes sense. In the next video, we're going to get some examples of this, so go check it out and be sure to subscribe. Peace out.
Hey, what's going on everybody? This video, I'm going to be teaching you how to override the toString method. So when exactly does this come up? Well, for example, if we are just printing some object, such as this user object, me, and we run this, we don't exactly get the string we were probably hoping for. We might have wanted it to put out the person's first name or last name, or some information about the object. So that's what I'm going to be teaching you guys in this video. So to override the toString method, which by the way, if you put a dot after me and say toString, you can see it right there. That's going to be implicitly called when you pass it into this print line, which is why I didn't have to put that explicitly. But if you want to override that, what we can do is go into our class, find a good spot because we got a lot of stuff going on. So I'm going to put the override at the bottom. You can actually right click, hover over source, and generate toString. And look at this, you can choose the fields to include in the toString method. So we'll check first name, last name. Alternatively, you can go into the methods and say get full name instead of the first name and last name. So that's what I'll do. And there you go, we get the very basics here. So here's how you override. You can copy the syntax here. Basically, we just need the method to have the exact same name, and we put this @override above it. So now, back in our calling program, we can get rid of this toString because again, that's implicit. We can run this, and look, we get a little bit more of a descriptive thing. So get full name, invoking that returns Caleb Curry. You can ultimately change this, right? If you just wanted to do the name, you can get rid of all this stuff here. But that's kind of cool. I like that it generated that. So that is how you override toString. Thank you guys for watching. In the next video, we're going to override the equals method. Hey, what's going on guys? Welcome back. This video, we're going to be talking about how to override the equals method. So what you can do is you can right click and click source. And by the way, I'm inside of my user class, a class I built myself. And in here, you can click generate hashcode and equals. Go ahead and check first name, last name, and generate. And wowzers, we get a lot of stuff here. So this is a really thorough comparison of these objects, and it's going to compare them by value. So what that means is in our calling program, what we can do is we can compare these objects now. So we can say me.equals, run this. We're getting false here. That's because our names are not exactly the same. So we'll change your name to my name. I'm not going to change my name to your name. Are you crazy? So we're able to compare these objects at the field level. It's pretty awesome. So now I'm you and you're me.
Hold up, wait, stop, this doesn't make sense. Hold up, wait, who are you? I am you, I am me. No sir, you are you.
Alright, so taking a look at our class, you can go through this code to see how exactly it works. I probably would have done a much more thin version where we just compared the values of first name, last name, and if they're equal, then we would return true, otherwise return false. But this is much more thorough, checking for nulls and so forth. So anytime you can generate something from Eclipse, definitely do that. We also have this hashcode thing, and the hashcode thing is used to put the objects in a hash table. It goes through a hashcode method, which will basically turn your object into a number. So if two objects are equal, they should in theory have the same hashcode. So going in here, we can say me.hashcode is equal to you.hashcode. And it's true, our hashcodes are equal. Thank you guys for watching. Be sure to check out the next video. And we're going to be talking about, I think, some more overloading stuff, so stay tuned. Hey, what's going on guys? This video, I'm going to be teaching you how to overload our method we created earlier to search for a user. So let's take a look at that method inside our user class. Oh, bunch of stuff here. I'm going to do some minimizing just to clean it up. I can't breathe. So we have this search list, and you can see this takes a first name and last name as a string. I want to overload this to actually take a user object, and then it'll take the first name and last name from that object. So let's create that. We'll say public static int search list, same exact name. It's going to take a list of type user, call it users, but now it's going to take a user object and we'll call it you. Now you can think if there's any way we could invoke this version so we don't have to repeat any code. Of course you can do whatever kind of comparisons you want in here, whatever kind of code you want, but definitely want to try to reuse code whenever possible. So I'm going to show you guys how to do that in this video. All you really got to do is just call search list, pass in that same users list, and for the full name, all you got to do is say u.getFullName. And again, we're going to return whatever value that gives us. This makes the search list a whole lot more versatile because now the caller doesn't have to worry about taking the property values. They can just pass in the whole object. So now what we're going to do is we're going to go back to my sweet program and we're going to invoke that. So we'll say user dot search list and we'll pass in users and we will search for you. Now I'm going to change up your name a little bit just so we're clear you're not me. We'll also want to see what this output is, so I'm going to put this inside of a system out. And running this, we get the value 1 as expected because you're on index 1. This is index 0, that's index 1. Now, the only thing we're comparing by is first name and last name. So you could also use some of the methods that are already available to us. So for example, you could use this equals method inside this here. All you would have to do is basically copy this code down here, but instead of saying get full name, you would just put the equals directly on the user object and then pass in the user you. So that's my coding challenge for you guys in this video if you want to try to use that equals method inside of this method up here. Thank you. Leave your guys' solutions in the comment section below. And now let's move on to the next topic where we're going to talk about returning custom objects. Hey yo, welcome back guys. This video we're going to be talking about returning custom objects. So we have these search methods and all they do is return the index where a particular user is found. What if we wanted to return the actual user object? Well, that's what I'm going to be doing in this video. So we'll say public and it's going to be static and the return type is going to be user. Now here's an issue. If you wanted to call it the same thing, search list, and have users and you as the parameters, that's not going to work because the return type is not enough to make a valid overload. So we actually need to name it something different or we need to change the parameter list. So what I'll do is I'll just say find user. So we're going to find that user and return it. And this is still going to take a list of type user, call that users, and we'll take a user called you. And we're going to use a for each loop. So for each user coming from the users list, what we're going to do is we're just going to do a comparison. We'll say user.equals, pass in you, the parameter value here. And if this is true, all we got to do is return user. Very simple. If we get through the whole loop and no one is true, then what we need to do is we just need to return null. And on the calling side, you can check for null to see if that value is found. All right, let's give it a try, see if it works. Let's go to our calling code. And in here, we're going to get rid of this line here. We're not going to use that old search list. We're going to use the new one. So we'll say user dot find user, pass in our list of users, and the user we're looking for. Let's say we're looking for you. We could see if that's found. Now, it may be the situation where you don't have access to that object directly like so. So what you might do instead is you might create a representation of what that object would look like. So let's do that. We'll create a user search and say new user. And what are we searching for? Well, the first name should be not. And the last name should be me. Cool, so now we might actually search using that object we just generated. And because this method returns a user, we can assign that directly to a user object that we just create like so. And what we can do now is with this new user object, we can just output it by passing it into the print line. Running this, you can see we get the full name, not me. So it's not null because if it was null, let's just say, mix this up a little bit by changing that name. And ran this, you can see we get null, so it's not found. So it seems that it's found and it actually returns that object. Now the key thing to note here is that it is the same object, it's not a copy. So the memory address is actually passed around as a value and we can change the fields. So if we did found.setFirstName and changed it to Sally, well, check this out. If we go and print you up here, remember, running this, you can see your name is now changed to Sally. And the reason that is because we're searching for this. It's found, it returns you, and now found is the same object as you. So I'll see you guys in the next video where we're going to talk a little bit about this in a little bit more detail. So See you guys then. Hey guys, welcome. This video, I wanted to talk about the whole concept of passing by value or by reference. So stay tuned. Hopefully you can learn a lot from this video. Now, I literally hate this topic because I don't really feel like there's an agreed upon naming convention for what anything is when it comes to references and pointers and value versus reference and so forth. So, by the books, Java is said to be passed by value. And what that means is if we pass some argument to a method, it passes the value and the value is copied into the parameter. But the gotcha here is that if we're working with an object, the value passed in is the location of memory. So it's still changeable in the method. So what I wanted to do is I just wanted to create an example method, try to change things and see what happens. So what I'm going to do is I'm going to clean up our code from the previous video a little bit. If you're following along, all you got to do is just get rid of this right here. So we have 2 user objects and we have a list of users, which we'll probably be working with throughout this video series. So now what I want to do is I actually want to create a static method on the user class and just work with it. So I'm going to scroll down to the bottom here, put it right here. We'll just say public void change crap, and we'll take an integer. And then we'll just say x++. And notice that it's void, so we're not returning the value. We're trying to just change the value and see what happens. Now from the caller, here's what I want to do. User.changeCrap, pass in some variable. So we'll say int y is equal to 4, pass in y, and then sys out y after the method call. Run this and we get the value 4. So you can see that increment did not affect this variable. But now I want to do a little bit something different here. I want to make change crap take a user. So it's going to be user x, and what we're going to do is we're going to say x first name. We're going to set it actually. So set first name and pass in changed. Now from the caller, I want to pass in u, like so. And in the output here, I just want to pass in u. Running this, you can see that your first name is now changed. So the changes made inside the method persisted outside of the method when we are working with a custom object. So hopefully that cleared things up. Just be careful when you're passing objects or returning objects to not modify them in the wrong spot. So be really, really careful. If you need to be really sure, you can always just create a new object and then it's not going to do anything wrong. So for example, x is equal to new user. Now when we set that first name, it's not going to be seen on the outside. So executing this, you can see you remain not, which is your first name right here. Awesome, thank you guys for watching. The next video, we're gonna be talking about inheritance. And if you want another good resource on this topic, because I'm not good at explaining anything, there's a good Stack Overflow answer, and it is right here. Boom, right here. Is Java pass by reference or pass by value? And you can read exactly what I was saying right here about the confusion. All right, thank you guys. I'll see you in the next video. Peace out.
Yo, what's up guys? This is your video on inheritance inside of Java. Now, we did talk about inheritance throughout this object-oriented section, but I wanted to devote a video to it now just to get on the same page with what it is. Inside of inheritance, which is the second big piece of object-oriented programming, we have encapsulation, inheritance, and polymorphism. So we're on that second one here. The whole idea is that we can create classes that inherit from other classes, or they extend another class. So a common example is with animals. You could have an animal class, and then you can have a dog class, and a cat class. These are going to be animals, so we can define common behavior in this animal class, and the dog and cat are automatically going to get that behavior. In the context of the code we've been writing so far, we have used a method .equals. And you might be wondering, where did this come from on our objects if we didn't define it ourselves? Well, this is actually inherited from that inheritance hierarchy. So we might make a custom object such as user, and we can use this .equals method even if we never created that method inside of our class. That's because in the hierarchy, user inherits from object. And one of the things inside of object is a method called equals. And that's going to basically flow down to user automatically. And we do have the option of overriding it, which we talked about in a couple videos ago. So we can make our own equals method to do a more proper comparison.
Hey, what's going on, guys? This is your follow-up to the inheritance video we did in the previous video. So we had this class in earlier videos, this user. I really just stripped out everything from it except these public fields. And here's why I decided to use public fields. The primary reasons is that first name and last name are not complicated. I don't feel the need to have two methods for each one of these just to get the value and set the value. I'm not doing any kind of crazy validation or anything. If you want to do that, then you probably want to have those getter and setter methods. Otherwise, public fields should do just fine for simple things. It's a lot easier to read too. So now over in our calling code, I got to clean this up too. So we're literally just going to start from scratch. Now what I want to do essentially is use this user class as a base class. And I want to derive from this class with another class. So I want to create a class over here by right-clicking our project and saying new class. And we're going to call this student. Is say extends and then the class name. So student extends user. So we can put common things in the user class, and then we can create subclasses or derived classes that extend this. So they're going to get everything themselves. So to see this in action, over in the calling side, we can say student s is equal to new student. And the first thing you'll notice is that when you press S and put a dot, you have first name and last name available to this object. Even though those fields are not in the student class code, they are derived from this user class, which the student class extends. That's why they're there. We can also put stuff that's specific to the student inside of the student class. Let's go through an example. Let's say we want a way to indicate whether an account has been verified. Well, we can define something like that inside a user. So what we'll do is we'll just say Boolean verified, and we'll make this public. And we can default this to false. Now in the student, we can basically have our own Boolean verified field. So what we can do is we can say public Boolean verified, and we can default this one to true. We can also have fields that do not exist inside a user. So for example, we could have a public string major. So those are just some of the capabilities. Now from my program, I can say s.major. We can assign it some kind of modern, really practical degree, and we can output this. And you can see it works. So that's the basics of inheritance. Check out the next video because we're going to be talking about some overriding concepts, and you'll definitely want to learn how to do that with object-oriented programming. So stay tuned.
Hey, what's going on, guys? This video I wanted to talk about a computer science concept known as virtual, and we're going to put that in the context of Java and see what that means exactly. Now, throughout the last couple in-person videos, we have talked about how we can override methods and how we can use inheritance to pass down methods from derived classes. So think of it like this. We have a method, we'll call it hello, and then we can override this like so. So this came from a base class, this one from a derived class. Now, if we typed out this method, gave it a body, then we would be overriding this one here. Now, in computer science, in order for us to override a method from a derived class, this method needs to be labeled virtual. But before you start typing out virtual and stuff, inside of Java, you do not have to type virtual because it's done implicitly. So in other words, all methods, there's some exceptions I'll tell you about in a second. Most methods are going to be virtual by default. So you don't have to type anything out. And in the derived class, we don't have to say override or do anything fancy either. So I did mention there were some exceptions, and not all of them are virtual. Well, the ones that are not virtual are static methods. And in addition to this, private methods are not going to be virtual as well, which makes sense because if a method is private, it's only there inside of that class. Now, I would encourage you to look up the details of the concept of methods being virtual because you should understand how it works And you might also get some more information on the exceptions when the implicit virtual is not a thing, and so forth. So in conclusion, Java makes our lives pretty darn easy because we don't have to do any extra typing. We can basically create that method in any of our derived classes, and it's automatically going to override any of the methods higher up in the hierarchy, the inheritance chain. So thank you guys for watching. Stay tuned for the next videos because we're going to get some more hands-on practice and some other good concepts. So I'll see you then, and be sure to subscribe.
Hey guys, welcome. This video I wanted to talk about creating a method in this user class and overriding it in a derived class such as student. So to do that, we'll create a method in here. We'll just make something simple like say hello, which is just going to output something to the console. And we'll make this void and public. We'll just say, hi, I'm a user. My name is plus. And now what we can do is we can just concatenate the first and last name. So we'll say first name plus a space plus last name. Now inside a student, we should have this available to us. So when we are working with a student object, what we can do is we can just say s dot say hello. We should probably give the student a name, so we'll say s first name, assign it. Executing this, it says, hi, I'm a user. My name is Smarty Null. I always forget about that last name, darn it. And we'll just call this not a candy, just so no one gets this person confused with the Smarty candies. Cool, well what if we wanted to make a specific version for students? Let's show you how to do that. So what we'll do is say @override, and then we'll say public void, say hello. And now we can say something specific to students, such as, hi, my major is, then we can put the major, and then maybe we can extend this by putting a period and saying inside the same string, my name is, and then put the first and last name. We can use those here even though they're defined in the user class. And we'll probably want to put a space between them. I think I got one extra parentheses there. All right, there we go. Let's run this. Hi, my major is null. My name is Smarty, not a candy. So we can go assign a value to this person's major. s.major. Beautiful. So you can see we can use the user class as like a general class, and then we can derive from that class and make things more specific. Thank you guys for watching. Be sure to check out the next video. Heyo, in this video, what I wanted to do is I wanted to talk about abstract classes. So check this out. If we go into user and where we have public class user, we can add a keyword in here. We can say abstract. Oh, not all caps. Abstract. And what this does is it prevents us from instantiating a user. So if in our code we tried to say user u equals new user, this is going to give an error. Cannot instantiate the type user. And the reason is because it doesn't actually exist as an instantiatable class because it is abstract. So anything that cannot exist, you can label it as abstract. Hopefully that makes sense. But in reality, if you wanted to force users to be students or teachers or whatever it might be, then you can make the user class abstract. And then the only way we can get value from the user class is if we extend it in another class, such as we did here for the student. We're still getting the benefits from the user class, but we can't instantiate it directly. We have to use a derived class. Another example of this is if you think of animals, there doesn't actually exist animals. There only exist dogs, cats, llamas, alpacas, specific examples of animals. The idea of an animal is an abstract idea, so if you were trying to create a hierarchy for animals, you'd probably have an animal-based class with a bunch of basic stuff that would be labeled abstract. Then if you wanted to use those things, you could extend it in a dog class or a cat class or whatever it might be. So that's your introduction to abstract classes. In the next video, we're going to be talking about abstract methods, so check it out. Hey guys, welcome. In this video, we're going to be talking about abstract methods. So the previous video, we created this abstract class, But now I want to take a look at this method here and make it abstract. So when you make a method abstract, what it does is it prevents you from having a body for this method. So hovering over this, you can see abstract methods do not specify a body. So we actually have to get rid of this entire body and replace it with a semicolon. So this is sort of like virtual because you can override it, but it's actually one layer stronger because not only can you override it, but you actually have to override it. So in our student class, which extends user, we have this say hello method, but let's just say for a minute we commented this out. When we have this commented, we get an error, and it says the type student must implement the inherited abstract method. So if you want to basically say any classes that extend from a class must come up with their own implementation for a method, you can make it abstract in the parent class, and then all of the classes extended from that must create their own body. So uncommenting this, you can see everything works fine, and that is how abstract methods work.
Hey, what's going on, guys? This is your dedicated video to polymorphism. We're going to talk about the concepts and prepare ourselves as we move into that subject in code, just to get that concept down before we start typing junk out. So the whole idea of polymorphism at a general level is that something can kind of morph into different things depending on how we look at it. And when I say that out loud, I sound crazy and it doesn't really make sense. But in the context of programming and object-oriented programming, polymorphism allows us to treat an object as different types of objects. And this really comes from that inheritance hierarchy. You know, just as an example, if we had a user class and then we had two derived classes, student and teacher, well, you can take a student and you can treat it like a user. Now, I'm thinking in the concept of a web application or something like that. If you wanted to think more real life, you might change user to person, right? So the whole idea here is that, you know, if you see someone you know and you know they're a student, you might go up to them and say, hey dude, how are classes? But if you go to a stranger, you don't necessarily know that they're a student. So you might just say, hey dude, how's the weather? So the way you would treat this person you're coming up to depends on the context. If you know that person, you know they're a student, you're probably going to treat them like a student. But if you don't know, you're going to treat them like a person. Well, the same exact thing applies in programming. You can treat a student as a student or as a person, or back to the original case, I'm going to go with user. So that makes things like this possible. You can create a new student and assign it to a user. Makes sense? Or you can make it a student. That's fine too. You could also make a list of users and put both students and teachers in there. And the cool thing here is you can go through that list and you can tell the students and the teachers to do something such as work, and they're going to do the appropriate thing. The teachers are going to go do research or hide in their office. The students might go study or go to parties, whatever students do. And we don't have to make some kind of crazy casing. We can just iterate through the loop, and because we're talking to users in general, we can say something general and they're going to do the appropriate thing.
Hey, what's going on, guys? This video, we're going to go through an example of polymorphism. So the first thing we should probably look at is our inheritance hierarchy. We have a user class, it's abstract, and then we extend this class through this student class. So user is kind of the parent, student is the child. But what I want to do is I actually want to create another class. So right click our project and new class, and this one's going to be a teacher. Finish. And this is going to extend user. And then hover over this and see we have to inherit user.sayHello. So we'll do that down here. And we'll just say, I'm a teacher. And make sure this is in asys out. And obviously this needs to be void. Okay, I think that should be good. Oh, and it needs to be public. Dang it. All right, there we go. Wow, that was just embarrassing. Usually I'm not that bad, but I was getting confused because I was putting the override on the same line, so it looked like it was complete. Now because teacher and student both extend user, we can treat them both as users. So over in our program, what I want to do is I first want to create a new teacher. and then set some values here, like so. So what we can do is we can actually create a list of type user and treat both of these objects as user since they extend user. So we'll create a new array list, and then we'll just add these by saying users.add, pass in s, and pass in t. Now when we iterate through these, we'll use a for each loop. We'll just say for user u colon users. And then we'll say u dot say hello. Running this, it looks like I got an error in my student class. Let me just double check this. Looks like I'm missing a curly brace. All right, great. Now let's run this. And you can see the first one says the student version, and then the second one says I'm a teacher. We also have this extra output coming from right here, so I'm just going to comment that out. So the whole concept of polymorphism is that a student can be a user and it can also be a student, depending on what context. This allows us to be very general by addressing a parent class, and then all of the classes that extend that will do the appropriate thing. Now, if for some reason user was not abstract and you could instantiate a user, then you called say hello, well then it would do the user version of the say hello method. So it's very dynamic. Imagine if we had 20 different classes that all extended from user. We can just create one version of our code that addresses all users and it would work. So that is your example of polymorphism. There's a lot more you could study on that, so be sure to do that if you're interested. Next video, we're going to be getting into constructors, and it's basically an opportunity to clean up all this junk by using custom constructors.
Yo, what's going on everyone? In this video we're going to be talking about constructors. Get that concept figured out, so then we can go make some examples in code in just a moment. So stay tuned, it's going to be pretty fun. Alright, so what in the world is a constructor? Well, a constructor is pretty much just like a method. So it's something we invoke, and there's a key difference. When you create a constructor, you don't put a return type. So no return, and the other difference is that the way we invoke it is with the new keyword. So when we do something like this here, it's a terrible arrow, there we go. Oh, there we go. This here is how we invoke a constructor. So we've been using constructors this entire time, we just may not have known that. And you see it looks really similar to invoking a method, but we prefix it with the new keyword. Inside of the user class, the way we define this is exactly the same as a method, but there's no return or return type. And the name has to match the class. So these match. And then in here we can define what the constructor does. Now why would you need this? Well, the primary reason of a constructor is so we can initialize the object with certain values. So for example, we could pass in a first and last name here, or let's just go with the first name because I don't feel like writing a bunch, of Caleb. Then inside of the constructor, what we can do is we can assign that value to the fields in this class. So we'll put that in a parameter here. We'll just call it string n. And then all we have to do is say first name is assigned the value n. So this is how we can get this value here to go into the variables for the class user. It's basically a way to make sure from the very beginning the user has valid values. Cool, so that's your intro. The other thing you should know is that by default, there is an implicit default constructor. So that's going to just be like this. So when you say new user with no arguments, you're getting the default constructor. But if you create a custom constructor, so such as one that takes a string, the definition of this default constructor is no longer going to implicitly happen. So in our class, if you want the option for a default constructor with no arguments passed in and a custom constructor where we pass something in, you're going to have to explicitly define that default constructor, which literally will just look like this. Super easy. You just got to remember that. The reason is because if you want to make a scenario where an object has to have initialized values, you can get rid of that default constructor and make a custom constructor, and then it's not going to be implicitly created where we can make an object in an undefined state. So for example, if a user has to have a first name and last name, you can require that in the only constructor, getting rid of the default one. So that's your introduction to constructors. Now let's get creating some. I'll see you guys in the next video.
Hey, what's going on, guys? This video, I want to talk a little bit more about the default constructor. So when do we use the default constructor? Well, we've actually been using it a lot through this series. So here's an example. When we say new and then a class name followed by empty parentheses, this is the default constructor, and it's made automatically for us. So looking at the student class, inside of here, we don't see anything about a constructor, but if we wanted to manually write it out, it'd probably look like this. We would say public student, and it needs to match the name. So student, and then parentheses, and then the curly braces. So it looks almost exactly like a method. It really is a method, but the only difference is that it has no return type, so no void, no string, no nothing. And it has to match the class name. What we can do is we can override this to do something custom. So for example, we can do an output and say creating a student. Now when we run this, you can see it says creating a student, because this constructor is hit when we say new student. So that is how the default constructor works. Typically the default constructor will be used for classes that when you instantiate it, you don't need to give it any upfront information. It's pretty much in a good state as soon as you create it. But in the situation of a student, we might need to be very clear upfront that the student's name is this and the major is this, or whatever it might be, in order for it to be a valid student. For example, you're not going to have a student walking around with no first name or last name. So it would be appropriate if we could go in here and pass in the first name like so, and also pass in the last name. And you could also do the major, but maybe they're undecided, so I don't really think that's a necessity. So what we could do is do this, but you can see it's not happy. Why is it not happy? Well, that's because if you look at our student class, this constructor does not have any parameters. So what we're going to be doing in the next video is we're going to be talking about how to create custom constructors and some gotchas you need to know. So stay tuned. Hey, what's going on, guys? This video, I'm going to be talking about custom constructors. So here we have the default constructor, which if you don't put it here, it's going to be made automatically for you. But now I need to create a custom one. So taking a look at our code, we are trying to create a new student by passing in the first and last name. You can hover over this and it'll give you some suggestions. And one of them is to create a constructor student string. So when you click that, it brings us to the student class, and you can see public student, and it creates these two strings for us. Now the purpose of this constructor is to initialize the fields with the appropriate values. So for example, we can say first name is equal to FN and last name is equal to LN. And it should work. So we can go over in our code and we can say sysout s.firstname, and we should get a value. And it does work. Awesome. But there's one gotcha here, and that is if you look at our student class and we get rid of this default constructor, it's no longer going to be created automatically. So anytime we have a constructor that's custom, the default constructor is no longer implicitly created. So what that means is over here, if we try to just say new student with nothing in the parentheses, we're going to get an error. And it says this constructor is undefined. So you need to remember, if you need that default constructor and you're creating custom ones, you need to add it yourself. So you can follow this fix, create constructor student. Very simple. And now you can do that. But be warned, it might make your student in an undefined state if it doesn't have a first name or last name. That's up for you to decide what is required for a student to be a valid student. Thank you guys for watching. Hopefully that helps you understand constructors a little bit better. Thank you, and I'll see you in the next one. Oh, and don't forget to subscribe, of course. Duh. Hey, what's up, guys? This video, I wanted to teach you guys how to invoke a method in a superclass. Or in other words, if you have a class that extends another one, so student extends user, how can we call a method in the user class? When would you ever possibly want to use this? Well, we're overriding this say hello method, But what if we, for a specific reason, wanted to invoke the user version instead of the student version? So that's what we're going to be talking about in this video. All right, so in the user class, what we're going to do, first, we're not going to make this abstract because it kind of makes it impossible. So we're going to actually give this an implementation, and we'll just say user version. All right, so there may be a situation where in the student class, which extends user, it needs to invoke this method for a particular use, and here's how to do that. Inside of the student class, all you gotta do is say super dot, and now you can access all that stuff. So for example, say hello. Now let's invoke this and see what happens. From our code, all we gotta do, first thing we need to give it a first and last name because we don't have that default constructor, so kind of off topic, but I just thought I'd finish that out real quick. And then all we gotta do is say s.sayHello. Run this, and look, it says user version, and then it says down here, this is the student version. So this is important if the user class would have some set of logic that you need to access inside of the student class, but you don't want to have to repeat it. You can specify you want the parent class version of something by prefixing the method call with super. And you do that within the context of the derived class code, such as student here. So that's how you use the super keyword. Thank you guys for watching, and check out the next video. Hey, what's going on everybody? This video, I wanted to talk to you how we can create a field that is read only. And by that, I mean you can only assign a value to it at the initialization of the object, but after you set it, it's set with that and you can't change it. So the easiest way to do this is to create a constructor that will assign the value. So when you call that constructor, you have the capability of giving that first initial value, but you can make the field private so then you don't have the ability to change it after that. So to do that, we actually get these fields from the user class. So look at that and change these to private. Now, because when something is private, the only way we can access them is through methods, what we can do is we can create the user constructor. So let's say public user, and we'll take those as parameters, first name and last name, and we'll just assign those to the fields. So first name is FN and last name is LN. Okay, so this is an abstract class, so we're not going to be invoking this constructor directly in our calling code over here. So what we need to do is we actually need to call this constructor from our student class. So here's how we're going to do that. Go over in our student class, and inside of the constructor here, what we can do is we can actually say super and pass in FN and LN. Get rid of that here, and the parent constructor will do the assigning for us. All right, so let's give it a try. In our code, what we're gonna do is we're going to create a new student, pass in a name, like so. And so this is how we're going to assign the first name and last name. But if you say s dot, you're gonna notice that first name and last name is not a thing. So it doesn't show up, it's not accessible. But we can still access those values. We just need a way to do that. So for example, inside of the user method, we are currently doing user version. We could alternatively just output the first name and last name. So just as an example, we'll just do the first name and a space and then the last name. This is in the same class, which is why we can access these. Now from our calling code, all we gotta do is say s.sayHello, run this, and look at that. That's how we can get the value. So we can create getters for these fields. You could say get first name, and you could create get last name. Define those inside of the user class, but don't create the set ones. Just leave it so where the constructor is the only way you can assign that. Thank you guys for watching, and be sure to check out the next video.
Hey, what's up guys? This video we're going to be talking about interfaces and how they're different than inheriting from an object. So when we are creating classes, there's two ways we can basically describe the behavior that this class needs to have. The first is through a base class, such as a user being extended by a teacher. This teacher, any objects that are of the type teacher, are going to inherit the stuff from user. So that's the first way we get inheritance. And the other way is sort of like inheritance, but it's a little bit different, and that is through the use of interfaces. So interfaces define behavior. And you can think of interfaces very generally, which is basically how you work with something. So let's say we have this object, And this wall is the interface on how we interact with this object. You know, and it has certain characteristics that describe how this object is usable. So maybe we can have the object give us some output, or we can tell the object to do something with a particular value. Whatever it might be, we can basically work with this object through this interface here. And that's the concept of an interface, but when we're actually programming, we can create an interface and tell the class that this object comes from that it has to meet the requirements for this interface. So imagine you could take these rules of how to work with this object and write them in code. Maybe this is a little too conceptual, but give me a minute and we'll get a little bit more concrete. So rather than working with a general object, let's say we were working with something specific, such as a cat. So I might have a cat class, and this cat can do certain things. This cat can walk, it can talk or meow, or let's just go with meow. And it can eat. It's pretty much the only thing cats are good for. So we can define each one of these behaviors using interfaces. And we can reuse those interfaces. So for example, cats walk, but so do dogs. So dogs can use that interface, humans can use that interface, and so forth. So in conclusion, with interfaces, they define particular behaviors that classes need to implement. In the situation of walk, we can basically say everything that needs to happen for something to walk. You know, it needs to balance, it needs to be able to coordinate, it needs to be able to move forward. We can define that behavior, or at least the general structure for that behavior, in an interface, and then classes can implement that interface. So that can be implemented by cat, that can be implemented by dog, that can be implemented by human, and so forth. So a class can extend another class, but a class doesn't extend an interface. Instead, it implements an interface. So a class inherits from another class and can have that code already there, but when a class implements an interface, you have to define that functionality in this class. So both are important, just make sure you understand when to use which. If you're trying to define what something is, or you want that code to automatically already be done, it's just gonna inherit from another class, boom, it's done. With an interface, you're going to have to write a lot of code in this class to make sure we meet that interface requirements. When we have a bunch of different classes that all implement an interface, a particular interface, we can basically trust that they are doing something on their part. In the case of walking, we can say any class that implements that interface, we know that they can walk, so we can tell them to walk and we can trust that they can do it. So it's kind of conceptual here. I understand that it's a little weird. So what I want you to do is I want you to go to the next video, because we're going to be going into creating interfaces and a little bit more detail on interfaces versus classes in the inheritance hierarchy. So stay tuned and don't give up yet, because it is pretty conceptual up here. But I wanted to get those concepts out, and I'll see you in the next video. Peace out.
Hey, what's up guys? This video we're going to be talking about how to create an interface in Java. And the interface is where we can define particular behaviors and then implement that interface. So what we need to do is right click on our project and click New, Interface. You can either create your interface name as some general kind of object such as animal, or you can be specific to a particular action such as walking. So for example, I'm just going to call this walk. And in here we can put the signatures for the methods that we want classes that implement this interface to have. So for example, oh man, I didn't want to put walk. I wanted to say talk. Dang it. We're going to do talk. And we're also going to change the file name. Or you can just hover over this and rename file to talk.java. There we go. Oh yeah. And in here we can make the method that we want anyone that implements this interface to have, which we can call say hello, which we've been using throughout this video series. And what is the return type for this? We're just going to say void. So I'm assuming it's going to say hello to the console. You could also make a string version that returns the message, whatever you want. Now to use this interface, it's actually really easy. So go into a class such as student, and you can see that this extends user, but it's also going to implement talk with a capital T. We could do that for the other classes as well. We'll even do it inside a user. So this one implements talk, and so does teacher. Now when you implement an interface, you're going to be required to have the methods defined in this interface, specifically say hello. So if we were to get rid of the say hello method, and we're also going to need to get rid of it in the parent class, which was giving me an issue earlier, I forgot about it, because it's going to inherit this say hello method. So we need to get rid of it just to see this error. And now inside a teacher, you can see we get an error. And it says, must implement the inherited abstract method talk.sayHello. So what we can do is we can say add unimplemented methods, and we can put whatever we want in here. So you can see that the interface forces a class to meet certain expectations. Specifically, they must have certain methods. You can implement numerous interfaces, so you can basically break out different behaviors or different structures for objects into interfaces and then implement those. That way, anyone that implements talk in this situation, we can trust it to have a say hello method. So going into student, we can do a similar thing. Let's get rid of that call. That's just giving us an error. And you can see we still have that say hello method, so we're not getting any issues. Then in our program, what we can do is we can actually make a collection. So we'll make a list, and this type here is going to be talk. And we can just say things that talk, and we'll assign this a new array list. Now the things that can go in this list must implement the interface. So for example, we can say things that talk.add and pass in s, and that will work. In the next video, we'll be talking a little bit more about some things you should know with methods. It should be pretty fun, so go check it out, and thank you for watching. Hey, what's going on, guys? This video, I wanted to talk about the final keyword when it comes to methods, so stay tuned. All right, so here's the thing. If we create a method in a class that's going to be extended, such as this user class, which the student class and teacher class extends, we may want to have a method that we do not want overridden. And I'll show you how to do that in this video. So we will say public void say hello, and what we can do is we can mark this as final. Now check out in our derived classes, student here, for example, hovering over that method, it says cannot override the final method from user. So that means the classes that extend user cannot provide their own implementation. So that's what the final keyword will do. It's good if you just want to basically say, hey, this is the last implementation. We don't want this to be changed any further down the inheritance hierarchy. This is final. So yeah, that was really short, but that's all I gotta say. So thank you for watching, and I'll see you in the next video. Hey, what's going on, guys? This video, I wanted to talk about final classes. So in the previous video, we talked about final methods, and you can see it prevents us from overriding a method in a class that extends the class that had the final labeled method. So we can actually just get rid of this method since we can't override it, and we'll do the same thing for teacher. But how is a final class different? Well, a final class actually prevents anything from extending it. So for example, we can label this class as final. Then if we tried to make a new class, and then we gave this name as I don't know, just call it test for now. If we tried to say extends teacher, we're gonna get an error. It says the type test cannot subclass the final class teacher. So if you want to end the inheritance hierarchy and say nothing can extend this, then you would use the keyword final. So we're gonna have to get rid of this test class because obviously it's not gonna work out. So we'll just delete that. Awesome. So that is the final keyword. Hopefully that is helpful to you guys. Hey, what's going on, guys? This video, I wanted to talk about enumerations or enums. Basically, enumerations allow us to have a list of possible values for a variable. So to create an enum, it's gonna look like this. We'll actually do this inside the user class, and we'll just create this as a field. So we'll say public enum, and then we can give it a name such as status. Then we would do curly braces, and we put the possible values in here. So for example, we could have active, inactive, and probation, which if this is used in the context of a school system, probation just might mean they are at risk of academic failure or getting kicked out or whatever it might be. You could also do some status like gold, silver, bronze if you have a gym or some kind of subscription status. that would work as well. And when we do this, we're actually creating a new type called status. So we can create another field and say public status, and I think we can actually name it the same exact thing. So the type is status and the name of the field is status. All right, now let's take a look at how we might use this thing. We'll go over into the calling side. We have the student object, so we'll just say s.status, and we can assign this s.status and choose an option. So we'll go with probation. And we can output this just to see what it says, s.status. And running this, you can see we get the value probation. So that's pretty cool. That's your introduction to enum. You may also see the status options. In this case, active, inactive, and probation. You might see those in all capital letters. It's just a convention. You can do whatever you like. Thanks guys, and I'll see you in the next video where we're going to be working a little bit more with enumerations. Hey, what's going on guys? This video I wanted to talk about how to use an enumeration inside of a switch statement. It's actually very easy and you'll often see the two together. So let's create a switch and we're going to switch on s.status. And then we can just create cases for the different labels. So we'll say case probation. We'll do an output and then we'll say break. We can do a similar thing for the other ones. So we can have case active and case inactive. So then we'll change the output here. Running this, you can see it says ouch. So that's how you do a switch based on the different values of an enumeration. Hopefully that was helpful for you, and yeah, you better want to go check out the next video. It's kind of important. Like, it's kind of the end of the series. Honestly, I'm kind of excited, so I'll see you guys then. Not that the series wasn't fun, but it's always great to finish a series. So go check that out, and you get to congratulate yourself for finishing the series.
Wow guys, I cannot believe it. Woo! You made it all the way to video number 100. I'm surprised. I honestly didn't think you were gonna make it. Most people will watch video 1 about 2 minutes in and they'll be like, yeah, I'm done. But you guys stuck through. Unless you're just jumping in video 100, and in that case, you're starting in the wrong spot. So go back to the beginning. Now, I should say thank you and congratulations, but I also want to encourage you not to end your learning here. There's so much more to learn with Java. If you're looking for what to study, I would look into web development with Java and also user interface development if that's something you're into. Now, personally, I like web applications, but if you want to build desktop applications, that's fine as well. You can also look into Android applications, but basically, don't stop learning, keep going, and I'm really, really proud of you guys, but don't stop. If you're looking for more topics in Java, I would encourage you to learn generic programming first off, and then I would look into some of the other data structures to do various things. So you can look into hash tables or whatever that you might be interested in. You probably also want to get into database reading, input and output, so how to read from files and output to files and stuff like that. We should also probably study more on exceptions and error handling, as well as debugging. So those are some general concepts that if you're looking for some more stuff to study, go do that. And if you're looking for other series, I have a lot on my channel, including C#, C++, JavaScript, and probably some other database stuff, so go check it out. And the only thing I have to ask from you guys is just please subscribe, and when I come out with a new video, go check it out. That really helps my channel, and it means the world to me. Thank you, and I'll see you guys in the next series.